Hello, fine. So a very good morning to respected chief guest, director sir, and all invited speakers, faculty members, and our dear students. I request everyone to please switch off their phone or put them in silent mode. I am Dr. Ritu Gupta, Associate Professor at Department of Chemistry, IIT Jodhpur, and also the convener of this program. And the conference is titled as Empowering Science and Technology with Women, a Step Towards the New Era. Thank you all for becoming the part of this event, which is women-centric in nature, however, incomplete without an equal participation from both genders. As many of you would have realized, the event is titled counterintuitively as Empowering Science and Technology with Women. Truly, the catchy title has been desperately coined to emphasize the development in science and technology will be enhanced only with an equal participation from female fraternity. Indeed, the genesis for organizing this event came to light when I attended WOST conference at Chennai last year, and Professor Verma expressed his thoughts of organizing an event for women scientists and motivated me to take this initiative at IIT Jodhpur. Thank you, sir, for this initiative and creating such an opportunity for all of us and bringing us together here. I'm also very grateful to our director for his constant guidance, motivation, and encouragement in organizing this event. I shall brief you on the detailed program a bit later, but I am very pleased to convene the proceedings. On behalf of IIT Jodhpur, I extend a very warm welcome to all of you again. It is my pleasure to invite all the dignitaries on the stage, please. I request Director Professor Shantanu Chaudhary, IIT Jodhpur, Professor Sandeep Verma, SERB Secretary, Professor Anil Mishra, Director INMAS, Professor Alok Dhawan, Director CBMR, Professor Shobna Narsimha, JNCSR, Dr. Lipika De, Scientist at TCS, Professor Richa Singh, Head CSE, Professor Mitali Mukherjee, Head BSB, to please come over to the stage. We have with us this morning our guest of honor, Professor Sandeep Verma, Secretary SERB, and I request our director, Professor Shantanu Chaudhary, to offer him flowers and felicitate our chief guest. Professor Sandeep Verma is Secretary of SERB from April 2019. Professor Verma holds a doctoral degree from the University of Illinois, Chicago, followed by 2 postdoctoral stints at Johns Hopkins, USA, and Max Planck Institute, Germany. He joined the Department of Chemistry, Indian Institute of Technology, Kanpur in 1997, where he is a professor of chemistry. His work has been recognized by the Goel Prize, J.C. Bose Fellowship, Shanti Swarup Bhatnagar Prize, DAE SRC Outstanding Investigator Award, Swan Jayanti Fellowship, to name a few. He recently received the Distinguished Alumnus Award of Banaras Hindu University, Varanasi. He is an elected fellow of all the science academies. He is an associate editor of ChemCom and serves as an editorial advisory boards of several reputed journals. Thank you so much, sir. We are fortunate to have you with us. Now, we have with us Professor Anil Mishra, Director, DRDO in Mass. And I request Dr. Shobna to felicitate the guest. So Dr. Anil Mishra is presently director of DRDO in Mass at New Delhi. He obtained his PhD in chemistry in 1988 from BHU, Varanasi, and postdoctoral research at Université de Dijon, France. Research scientist at University of California, senior scientist at NETS, France, and visiting professor at Max Planck Institute, Germany. He has published more than 300 papers in various journals of international repute, granted US, European, and Indian patents. He is the recipient of several awards, and the most prestigious one is DRDO Young Scientist by Prime Minister of India in 1998-1999. Thank you, sir, for joining us today. We also have with us today Professor Alok Dhawan, Director DRDO, Director CBMR. I request Professor Samanvita Pal to felicitate the guest. Professor Alok Dhawan is currently Director of Center of Biomedical Research, Lucknow, and previously served as Director CSIR, Indian Institute of Toxicology Research, Lucknow. He was the founding director, Institute of Life Sciences, and Dean, Planning and Development at Ahmedabad University, Gujarat. Professor Dhawan developed the different areas of toxicology apart from an innovative ecosystem at CSIR IITR. Professor Dhawan is currently working on various translational projects in healthcare. We are honored to have you with us, sir, today. Thank you. We have with us today Professor Chandrima Saha, INSA President. We requested her to join this event, and Professor Saha expressed her willingness and support. However, due to some important engagements, she could not make it in person. However, we are fortunate to have with us today online. Dr. Chandrima Saha is currently Professor of Eminence at the National Institute of Immunology, New Delhi, where she served as Director. She is currently elected President of the Indian National Science Academy in January 2020. Dr. Saha was the Vice President, International Affairs of the Indian National Science Academy, Council Member of Indian National Science Academy, National Academy of Sciences, Allahabad, and Indian Academy of Sciences, Bangalore. Dr. Saha received several awards: Shanti Swarup Bhatnagar Medal of INSA, DP Burma Memorial Award, Ranbaxy Science Foundation Award, Darshan Ranganathan Memorial Award, to name a few. Her primary interest in research focuses on death processes in rapidly proliferating cells, where her laboratory attempts to understand how the cell death process contribute to cell survival. Thank you, ma'am, for joining us today. We will arrange to send the momentums and the flowers to you by post. Thank you. We also have an important inaugural guest participating online, Professor Tanushri Sahadas Gupta, Director, SN Bose National Center for Basic Sciences. And due to some prior commitment, she could not make it in person. However, we are fortunate to have with us today online. Professor Tanushri Sahadas Gupta works in the area of computational condensed matter material physics, and a major thrust of her research is in the application of first principles electronic structure calculations to understand the physics and chemistry of novel and complex materials. She obtained her degree, PhD degree, from Calcutta University in 1995. After a few years of postdoctoral research abroad and also within India, she joined SN Bose National Center. She is currently senior professor and director in the same institute. She is a fellow of American Physical Society, the World Academy of Sciences, Indian National Academy of Sciences, and Indian Academy of Sciences, and National Academy of Sciences. And also she is a recipient of Swan Chanti Fellowship, MRSI, ICSC, Superconductivity and Material Science Annual Prize, to name a few. We are glad to have you with us today, ma'am. Thank you for joining us online, and we will arrange to send you the momentums by post.
Thank you.
Thank you. We also have with us our senior women scientists and professors as our invited guests in the technical sessions. And we would like to welcome Professor Lipika De, Chief Guest, TCS, who is also with us this morning. I request Professor Ananya Debnath to present the flowers to ma'am. Sorry. We would also like to welcome Professor Shobna Narasimha, JNCSR Bangalore, as one of the senior women faculty among the invited speakers today. I request Dr. Pragati Sharma to present the flowers and momentum to ma'am. We also have many dignitaries from our institute who are senior women faculty members and leading the positions. We would like to welcome Dr. Richa Singh, who is currently a professor and head at Department of Computer Science and Engineering, IIT Jodhpur. I request Dr. Shobna Singh, IIT Jodhpur, to present her a bouquet. We would also like to welcome Dr. Mitali Mukherjee, who is currently a professor and head at Department of BSBE, IIT Jodhpur. I request Dr. Jaida Sarkar to present her a bouquet. In the audience, we also have our distinguished sponsor from RSC, and I extend a warm welcome to Dr. Ajit Sharma, Head RSC India, and I request a volunteer to present a bouquet of flowers to him. It is a matter of pride for me to honor our director, Professor Shantanu Chaudhary, on this occasion. I now request dignitaries, Director Sir, Professor Sandeep Verma, Lipika Ma'am, Shobna Ma'am, Mitali Mukherjee Ma'am, to please proceed with the lamp lighting.
Hello, hello. Ya Kundindu तुषार हार धवला या शुभ्र वस्त्रावृता या वीणावर दण्डमुण्डितकरा या श्वेत पद्मासना या कुन्दिन्दु तुषारहार धवला या शुभ्र वस्त्रावृता या वीणावर दण्डमण्डितकरा या श्वेत पद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिर्भिदेवै सदा वन्दिता सा मां पातु सरस्वती सरस्वती भगवती निशेष जाड्यापहा माता सरस्वती शारदा हे माता सरस्वती शारदा विद्यादानी दयानी दुःखहारिणी जगत जननी ज्वाला मुखी माता सरस्वती शारदा हे माता सरस्वती शारदा कीजे सुदृष्टि कीजे सुदृष्टि सेवक जान अपना इतना वरदान दीजे ताल तान और अलाप बुद्धि अलंकार शारदा हे माता सरस्वती शारदा विद्यादानी दयानी दुःखहारिणी जगत जननी ज्वाला मुखी माता सरस्वती शारदा हे माता सरस्वती शारदा हे माता सरस्वती शारदा आ धन्यवाद।
You just heard a wonderful rendition by Miss Madhvi. Let's thank her for the Saraswati Vandana. Now, it's my duty to brief all of you about the program as the convener of the event today. We have made every effort to bring women achievers from all fields of science and technology on this common platform. The event is based on an inclusive approach to promote gender parity towards sustainable scientific and technological development. We have received a great support from SERB and RSC while organizing this event, and the same is gratefully acknowledged. This event will focus on all modern areas of chemical life sciences, materials engineering, chemical sciences, AI, IoT, including interdisciplinary areas. This unique gathering will offer the opportunity for students to meet and interact with young women achievers and senior scientists who are role models to many of us. The program will foster interdisciplinary research and transfer of knowledge that eventually can lead to a larger collaborative network. The scientific program will feature plenary lectures on general science topics, invited talks by eminent Indian researchers, and entrepreneur talks, panel discussion, and dynamic poster sessions. This morning, at the registration, we could look at the blooming faces of the research scholars with a lot of joy and happiness in their minds to attend this event even in the summer heat of 45 degree. This shows their enthusiasm and great passion for science. There are 154 registered participants from various institutes from MNIT Jaipur, Central University of Rajasthan, University of Kota, Delhi University, Manipal University, Jai Narayan Vyas University, Mahila PG College Jodhpur, IAS University, CDRI Lucknow, Banasthali Vidyapith, University of Kota, Amity University, and last but not the least, IIT Jodhpur. There are nearly 90 plus girls, 60 plus boys participating in this event today, and I expect when they return to the patent place, they will keep some inspiring thoughts from the event in their minds. I now request Director IIT Jodhpur to give his remarks about the event.
Dear Professor Sadhvi Verma and other dignitaries on stage, and the delegates who have come here from across the country to participate in this workshop, Empowering Science and Technology with Women. And the tagline is a step towards a new era. I think we are already in that era. If I look at from my experience of being in this SNT world since 90s, and I think I have seen a major change today. In fact, being in IIT, in fact, if I remember my BTech days, in my BTech class, there's only one girl in the Department of Electronics and Electrical Communication at IIT Kharagpur. But today, if you look at the first year, here we have a very large percentage of them, approximately about 20% of the students who are girls. So obviously, girls have come into the system and in a very large number. IITs have been, in some sense, a slow mover in that direction. Because if I compare that with other engineering colleges, engineering institutions, I'm talking more from an engineering perspective, because I've been in the academics of engineering for a long time and personally a researcher in that space. So I know engineering much better compared to other areas of science. So in that area, if you look into it, the girls have come into the engineering education, engineering research in a very big numbers over last 2 decades. If I give the statistics of IIT Delhi, look at that statistics of students, even 5 years back, the majority of the PG students were girls. So therefore, it's not a new era, a step towards a new era. We are already in that new era. We have girls in the whole system. And if I take example of IIT Jodhpur today, I think about 20% of our faculty colleagues are girls or women scientists, and exceptionally qualified women scientists. We have women scientists heading 3 of our departments. We have women scientists as faculty members, as associate deans, students. We have faculty members as wardens of the hostel. So faculty members have come forward in the scientific areas. They have come forward also in administrative positions. And there has been a question at various forums that why IITs never had a women director. And see, today I think IIT Kharagpur is 70 plus years, the oldest IIT. I'm an alumni of that. And including others, older IITs, IIT Delhi has also crossed 60 years, which is youngest among those old 5. We have not got a women director. That's a fact. And that's exactly where the new era should take us. The key point is we have crossed the first level. In fact, we have also crossed the second level where we are seeing scientists, women entrepreneurs also. The other point is, in recent times, if you look at the startup statistics, there are a very large number of students who have graduated into entrepreneurs. And I know myself personally quite a few of them. In fact, my students have also moved forward in that direction. So we have crossed possibly also the second barrier. The barrier, what we have not really touched, is what I say is a pinnacle. Basically, it's an aspiration we built among the women scientists and young research scholars, the aspiration to reach the pinnacle. We have crossed the plateaus, we have crossed the hills, which are of a lower height, but we have not really touched the Everest. And I think aspiration for that is very, very critical. And that's also very important for Indian scientists. In fact, I can quote work done by, again, one of my female student. She was working in brain imaging. And she came up with a theory in terms of the ability of the female brain to do multitasking in a much better fashion than male brain. And it was very well read and referred article across US and also global scientific arena. And it shows the diversity that women scientists can bring in to the realm of science. So let us accept the fact that men and women are not identical. If they're not identical, there are also differences in the thought process, the differences in the nature of creativity. And if you look at the nature, the growth of nature has happened and has been triggered by essentially the diversity element. If we do not have a gene pool diversity, then the whole living system, even the human beings, would have disappeared, possibly in the process of evolution. So therefore, in terms of thought process itself, it is absolutely essential for the women to aspire to reach the top, and then only they can bring in that diversity, that critical element, which can create a creative disruptions. And creative disruption at a different scale. When we talk about innovations, startups, we talk about disruption, that the scale of that disruption is much smaller. But if we have 50%, at least the 50% of the entire scientific community as women scientists are coming from a diverse brain formations, in fact, which is also linked to the genetic characteristics, that can actually lead to a real growth of science. And that in the Indian context, with its diversity of population, diversity of people coming from backgrounds, these diversity is something which is to be ensured and enhanced. And in that context, I think this whole exercise cannot be only by the women, but also by men. Because men are equal partners and they have to support this whole process to grow. And I have seen myself in various forums and various ways that how this enablement of the women in terms of their scientific progress becomes critically dependent and a function of the support of their partner. And as a support of the partner, both maybe as a scientific co-worker or even as partner in life, they have a big role to play. And even the whole society and the system has to accept that role on either side. And it's an equal role. It's not, and that equal role in terms of the social value system of the Indian context is extremely critical for bringing out more women into the open public forum where they are really aspiring for pinnacle. In terms of value system, possibly we expect that you reach a certain level, and that's what is expected of a woman. It's not so, and I think the whole social system has to change and accept, and it's changing, but also it has to grow in a various ways, because women scientists who are at a certain level today, they have to have the belief and the strength to fight for the pinnacle. And that pinnacle, that what I already stated, is extremely important for also the growth of science. The other important point I just was thinking about, that when we visit different campuses, different locations, how many, say, buildings, say, auditoriums, say, any kind of places, even the roads, streets, which we actually name to remember the people whom we think are worth remembering. I think the representation of women has been very less in that space. Not many campus edifices are named after women scientists, not many. There are, but not many. In fact, we made a policy, we have not yet implemented into it, that most of our buildings and many of our buildings in the campus, which we would like to name to recollect the contributions of women scientists to the Indian science systems. There has been many such examples, but we hardly, if we ask, I think many people who cannot remember or recollect the names, that so easily we recollect the name of male scientists. And that's actually also an aspirational point for the young research scholars who are moving into this space. You need to have role models. And role models who are at the pinnacle. That I'm actually stressing about the fact that this new era is a fight for the Everest, fight for the pinnacle. And that's exactly what the entire scientific community has to enable, an equal participation of women in that journey. And then only we can really talk about empowering S&T with women. Let's look forward that future. Thank you.
Thank you, sir, for sharing your thoughts and enlightening us. I now request Professor Sandeep Verma, SERB Secretary, to give the remarks on the event.
Good morning, everyone. Thank you, Ritu, for introduction. At the outset, I would like to thank Professor Chaudhary, IIT Jodhpur Director, for hosting this wonderful meeting in this beautiful campus. All the distinguished dignitaries on the dais, my friends, colleagues in the auditorium. It's really a privilege to be here, participating and talking to all of you about this meeting, which is empowering S&T with women. And I disagree with Ritu, it's not counterintuitive. Actually, it is the truth that science and technology has to be empowered with women, not vice versa. So I think the title is very apt and in line with the thought process of our departments of science and technology. And that certainly is the point I am here to emphasize upon. So when we met some time back, as Ritu pointed out, there was a thought process, or there still is a thought process in the Ministry of Science and Technology, having recognized the fact that we really need to bring gender parity in our system. And I'm very fortunate to see that all of our colleagues in the ministry, in the department, are in tune with this thought process. And that allows us to develop enabling mechanisms which brings parity, which brings inclusion, and that are going to be the two drivers as we go, as we are witnessing the Azadi Ka Amrit Mahotsav, as we move into the Amrit Kal till 2047, and we want to realize certain aspirational goals, which definitely needs equal participation. And in terms of, contribution, that is to be looked at very carefully, nurtured, as well as, empowered, so that the desired results are in front of us. So when I look at the program, there are nice, clean 4 verticals of research. There is collaboration, there is interdisciplinarity, and more importantly, the 4th focus, that is, what are the challenges posed by our colleagues when they are trying to do top-level S&T research or R&D, what kind of problems they face and how it can be addressed so that everybody is moving ahead with the same pace. So looking at such scenario, what was indeed realized that if I were to tell you from the standpoint of funding mechanisms and funding opportunities in the department as well as Science and Engineering Research Board, there was a very high level of skewedness in funded proposals when you look male versus female, right? So that was a a challenge that was facing at us. And what we did is that SERB came up with a new program called as POWER, SIR POWER, which stands for Promoting Opportunities for Women in Exploratory Research. And I'm very happy to share with you that within 2 years of the launch of this project, we are now receiving close to 3,700 applications for about 100 projects or equal number of fellowships. But what we have done now is looking at the number of applications. We have increased the success rate so that more number of projects could be funded at both level 1 and level 2, means top level institutions as well as second tier institutions, which are state universities, etc. So that the level playing field is such that we are competing amongst equals and there is still no disparity even within the women researcher community. So this was important, and I can share with you with much sort of confidence that we are now speaking to certain foreign agencies who are hopefully going to tie up with us so that we can have power grants or power fellowships, which will enable our researchers to go abroad and, sort of bring back their colleagues, their collaborators back to India. So this two-way mobility, especially for female researchers, is going to be emboldened, and sort of we will put enough money so that there is going to be enough support for such an initiative. So that is one emphasis. What is also important for us is that we found or we have known that there are career breaks for our female colleagues. So I'm not sure if most of us are aware, but I encourage you to go through our website where career breaks in female researchers, duration of the entire career, that can be addressed by specific programs. So the notion or the idea of having this meeting is not just to bring together top minds, also, as some of us were pointing out, create the right kind of role models. Director sir just pointed out having the right role models, but you also have to interact with each other. You have to collaborate. And when you have reached that level of maturity, you also have to play the role of hand holding. So you can enable your own colleagues, and that eventually is going to be important. And certain programs are again available, which allows you to bring in the right kind of participation. One program that we have here is TARE. So I'm almost trying to popularize SCRB amongst the colleagues here. TARE is again where you take colleagues from state colleges or state universities. And if you are from a well-funded institution, you bring them on board. So for 3 months, we pay their fellowships. So these teachers, these college teachers or university teachers could be exposed to the right kind of instruments, the right kind of infrastructure, research problems, and talking to you, their ideas, their horizons get widened up. And that is one important feature that we have brought it in our SERB program that you wish to take advantage of. So now we want to also look at that how this support is going to play out in the coming decades. And this is where I think participation from all of us is important, because we can think as much, but if 5 of us think together, then we may have better ideas, we may have better, suggestions that could be put together, because it is our job to put these things in motion, in action. And we assure you, as long as some of us are here, we are going to look at it very carefully, and there is money at our disposal that can be put to new programs, that can be put to the right instruments that is going to enable our researchers moving forward. So we have to think together, we have to act together, and when time comes to deliver, I think all of us, it is going to be all of our responsibility to deliver on taxpayers' money and move the entire ecosystem forward with the title what we have today, that we are going to empower science and technology, because there are numerous national missions which are going to be, crippled, if I may add here, if we are not having the right kind of participation from every side, right, from all sides. So at the moment, the new science, technology, and innovation policy of India is going to have a new chapter, or a chapter, dedicated chapter on diversity and inclusion. You would find that a refreshing change and a new era, or the new era forward, as director pointed out, is looking at us. It would beckon us as we move towards in the future. So this is where I want all of your commitment. We are here to serve you. We are here to listen and deliver, but please do engage with us. And I wish all of us a great meeting, including the scientific talks. And we are going to be here till tomorrow. So any idea that you want to bounce off us and give it to us, you are most welcome to interact with us. And with these few words and remarks, I wish all of us a great meeting. Thank you so very much for coming and participating. Again, thanks to IIT Jodhpur director, as well as Dr. Ritu, for this brilliant organization. Thank you so very much.
Thank you so much, sir, for briefing us on on SERB activities for women in science, and also enlightening and motivating us with your inspirational words. Uh, Now I request Professor Chandrima Saha, President in INSA, to give her remarks. We will be connecting her online. I also request dignitaries to please come down on the stage.
Am I audible?
Yes, ma'am, you are audible.
I'm audible, right?
Yes, ma'am.
Thank you. Dr. Shantanu Chaudhary, all the dignitaries who are on the dais and online, faculty and students of IIT Jodhpur. I thank Dr. Ritu for the introduction, and there is a small correction. I'm currently with the Indian Institute of Chemical Biology as JCBO's Distinguished Chair Professor, and I'm not with National Institute of Immunology right now. Thank you very much, and I'm delighted to be here. I wanted to, sort of start my comments on a very positive note. I think both Dr. Chaudhary and Professor Verma have been very optimistic, and I would like to start again on a note from Eric Falt, who is the Southeast Asia Director of UNESCO. And he said very recently that a braided river never falters on its way to the sea. Just as Indian women scientists invariably demonstrate intellect, grit, and power in the accomplishment of their personal and professional quests. So I think this is a recognition for Indian women in science. And if we look at it, we have been having conversations about women in science for a very long time, with decades. But why we're still facing such an issue is something that we need to really discuss. There are strong arguments that majority of the interventions that we have done so far may not be sufficient. But as I saw in Professor Varma's presentation, that they have come out with very novel programs. And also in our other programs of the government, we have many women-friendly schemes. I'm sure we're going to make a progress in them, but we really need to look very closely at what is the problem really is. Is it societal inequalities, or is it really the gender difference? Now, it is very interesting that in Finland, which is a country that excels in gender equality, they have one of the lowest proportions of women earning STEM degrees. And that includes Norway and Sweden, which also rank higher in gender equality. So where is the real problem? I think we still have to go a little more deeper into the issue. Now, why is it important to encourage more women to pursue to be in science? A nation like ours, needs talent, ideas, and creativity. For that matter, all the nations do. But participation varies among fields, and about 30% participation of women in science, as data points out. Therefore, one needs to encourage more women to join the science stream, and that is very much a societal issue, because the family has to encourage the girl child to take up science. So that is an important point. And what does really diversity do in scheme of things? Diverse teams could generate more different ideas and innovative solutions to problems. And COVID-19 has shown us that teams working together from different collaborations, from different scientists, have given us a great power of science. Now, Professor Shantanu has mentioned about role models. I think role models are very important, as they give a sense of relating to a person successful in a given profession. Now, if we look at the role models that we have known in our lives, is it true that women always face problems? And the women that we look up to as role models, are they very different? Or did they face any difficulties in their journey? And what kind of struggle did they have? And what made them succeed? So, one of the most well-known examples of this is Madame Curie, who, in spite of being the first woman to win a Nobel Prize and the only woman in history to ever win it twice, and the only human ever to win a Nobel Prize in two different sciences, faced a lot of problems. The reason I'm talking about her is because those were the era when women had so much difficulties. We are in a completely different era now, and we have so much facilities where women can flourish. And also, coming closer to home, that Madame Curie made, discoveries that literally changed the world. But she had so much difficulty in, getting into universities, really speaking about her science, never got elected to the French academies. So they have faced a lot of problems, yet they succeeded. So more closer to home, Dr. Muthulakshmi Reddy, if you remember, she created the Adyar Cancer Center, a wonderful institution that has treated millions of people for cancer. So she was a legendary medical practitioner and a social reformer and a legislator. She succeeded in very difficult times. Then the Christian Medical College and Hospital at Vellore was established by a woman, Ida Shudder, who came to India and made India her home. She created this fine medical college, one of the Asia's foremost teaching hospitals in India. And then you look at Mary Punen Lukos, who created the formidable healthcare system in Kerala. And these were women who went through very difficult times, yet they succeeded. So I think for any woman to succeed, determination and involvement and passion is very, very important. The facilitation can be done, but yet it is for one particular woman or a group of women to succeed, they need to have determination. And that is my take on women. Now, women force in science actually includes women in science administration, women technicians in science laboratories, women teachers of science subjects, women entrepreneurs in science, women researchers in science, and women students in science. So we have women in every facet of the scientific endeavor, and we really need to facilitate their coming into science. First of all, the first step is to come into science and then go along from there. And I'm very optimistic because if you look at uh, data, you see that the PhDs have increased Indian women from 2010 onwards to 2019. It's from 33 to 40%. The postgraduate is from 41 to 56%. And undergraduate from 37 to 43%. Actually, Professor Shantanu mentioned that how the increase in numbers of women has taken place in the engineering colleges. So it is a very optimistic scene, according to me. And in medical sciences, also women are participation is about 66%. So it is very encouraging to see this. And then what Professor Verma alluded to is that they are doing these novel programs, and the number of women PIs in 2000 from 2002 has increased to about 27. In terms of research projects, there may be more latest data which I'm not aware of, but it is certainly encouraging to see that. Uh, for graduation and post-graduation, women actually outnumber men. But there is a point where, after the PhDs, the number of women do go down. And that is because of societal pressure of being, in the family. And so a gap between completing PhD degree and starting the first faculty job, if you look at a UNESCO data, you will see that both men and women have career gaps. But for women, it is larger to about 47%, and for men, about 30%. So there are these data that we need to understand why these are there. Because the most common reasons for a career break in women in pre-marriage cases, which Niti Aayog data indicates, is about 14%. Before the first child, it's 30%. After the first child is 37%, and after second child is about 17%. So we have to look at how to facilitate these women who are in these groups, and how we can facilitate them to continue in science. And if you look at India in general, you will look at the data, number of women voters have gone up. We have the largest number of women pilots. So it is a very encouraging scene. And the National Education Policy of 2020 by the Ministry of Education and the latest draft of the Department of Science and Technology of forthcoming Science and Technology and Innovation Policy both have a very clear and precise commitments to gender equity and universal inclusion. So there is also the DST program of Gati, which ensures that the institutions also practice taking up women. I just would like to point out a few points where we can look at is that we have to analyze the women in different layers of the society, what their problems are by going a little deeper. And also the schools and universities should take steps for gender sensitization in the field of education. I think family has a big role in school children to really encourage them to go in science. And exposure to role models is essential, as I pointed out. And counseling is important for women coming from poorer and underprivileged sections of the society. And we have to implement policies to make it easier for women to make a career choice by both our central and the state governments and private companies as well. Financial support as fellowships we do have from Department of Science and Technology, but that needs to be has to be a bigger effort. And in leadership positions, women need to come in, which is happening. So that is also a very optimistic scenario. And private sector should attempt to enhance opportunities for women. We also should be mentoring younger women who have women who are in senior positions should be mentoring younger women how to go about their journey and how to reach what Professor Shantanu alluded to as pinnacle. And there should be gender inclusive work-time benefits, which is necessary for the man as well as the woman, because they run a family and they have a child. So the women-friendly facilities are necessary for all organizations practicing science. So these are the few comments that I had. Thank you very much.
Thank you so much, ma'am, for the wonderful message enlightening us about the policies, challenges that women in science face and how to circumvent that, and also how the future roadmap for women scientists in India is. It is quite inspirational and encouraging for us to know all the details. Now, may I request Professor Tanushri Sahadas Gupta, Director, SN Bose Institute of Basic Sciences, to give her remarks on the event.
Thank you very much. I would like to start by congratulating IIT Jodhpur for organizing this very pertinent event. And as Professor Shandip Verma said, actually, the title of this event is very apt, very timely, very, very pertinent. And I also thank Director IIT Jodhpur for inviting me to this event. I would like to actually share some of the slides, if you allow me to share, because I don't see the share option to be active. Is it possible to make it active?
Yes, ma'am, it is possible.
Okay, I think it is active now. Can you see my slides?
Yes, ma'am, it is visible.
Okay, I just try to make it full screen. So women in science, I think this has been mentioned both in the remarks by Professor Chaudhary and also Professor Shah, Chandrima Shah. In terms of women in science, one of the biggest thing is the career obstacle. We definitely need equal contribution of men and women. It's like the two wings of a bird. If you don't have another wing, the bird cannot fly. For a nation to excel, you definitely need the contribution of both men and women. But there is a kind of a disparity in the career growth between the men and women, which has been discussed very heavily, that although both start with the same step size of a staircase, the sizes of these step sizes keeps on increasing as these women proceeds along the career path. As was repeatedly mentioned by Professor Chaudhary, that reaching the pinnacle, reaching really the peak of the Everest, that seems to be way more tougher for a woman compared to that of a man. And you know, this journey of this and the struggle of this woman, I think this was very nicely captured in the book by called Lilavati's Daughter, which was edited by Rahini Gadgole and Ram Ramasamy, which actually gave, basically the struggle story of many of these women scientists of India. And I was fortunate enough to contribute one of my story. And what I'm going to do in my remarks, instead of being general, I'm from my own perspective, I'm going to tell a little bit about my journey. Hopefully that will address some of the issues which we have already discussed. So I started my school and college, which was, I came from a middle class Bengali family where the parents were very, very conservative. They were overprotective. They were very affectionate, but at the same time, they were overprotective. Being the girl child, they were very hesitant to send me to any school which is a mix of boys and girls. So because of their overprotection, I was sent to an all-girls school and all-girl college in my secondary and higher secondary studies. So as a result, I was actually quite shy when I had to open my mouth in a gathering which has both men and women. So because I was not really exposed to such kind of environment. The first breakthrough came when I kind of revolted and I said Presidency College, chose Presidency College for my bachelor study because I considered that to be such a well-known college, and it was my dream to go to that college, which was a kind of a co-education college. And I took physics honors, which was a tough subject for considered to be a tough subject for a girl. And in our class, we had 17 boys and only 4 girls. So we were a minority. And afterwards, of course, for my MSc, I went to Science College, where my experience of dealing with the boys came handy. And I was very fortunate, in spite of all of this fact that there were many talented boys in my class, and I had to really compete with these boys. I managed to stand first in my MSc class, and you can see my proud parents with me when I received the gold medal. But you see the date, that was 2017, because the medal was given many, many years after. And my parents' views and their overprotective nature has changed, and they have become the proud parents because of their daughter's achievement. So this was, I am saying all this in 2 lines, but this was a long battle and long struggle for my parents to convince them that I should go to Presidency College, I should take up physics, and more importantly, I should go abroad. So after my master's, I joined as a PhD scholar in SN Bose Center. So that was the place where I also did my PhD. And there I met 2 very wonderful men, Professor Abhijit Mukherjee, who was my PhD supervisor, and Indra Das Gupta, who was my co-worker in my PhD program, who later on became my husband. And it was also mentioned again and again, without the support of the men, the women cannot excel. And in my life, I think I have understood in the most efficient way. Professor Abhijit Mukherjee, he took so much care of me. I remember the first time I wanted to attend a conference abroad, which was in ICTP in Trieste. My father, because of his overprotective nature, he didn't really allow me to go abroad. He was not at all willing to let me go. But it's my supervisor who took up the case. He called my father, he met him, he convinced him through a prolonged discussion how important it is for me to go travel abroad and attend this conference. So, he didn't really think that whether it's a girl or it's a boy. He found the potential in me and he fought for it. And my colleague, as a colleague, he had an immense role in terms of convincing, motivating me. Although I have done PhD in an Indian institute because of my family pressure, but for my career progress, I should go out of this country. I should have a better exposure and I should continue with it. So he motivated me all along. So after that, I went abroad. I succeeded in going abroad. So my first postdoc was in Paris in an institution called Oneda, and I went there just after my marriage. So there was a lot of pressure from the family because my husband was in MPI in Stuttgart. It was not at all normal for any family to accept that you get married and then the wife immediately proceeds to a different country and the husband goes to a different country and they start living separated right after their marriage. So it was not at all allowed thing in a Bengali middle class family. So I had to really struggle a lot, and I must say I am fortunate all along in my life to get all these wonderful men around me. So he was my postdoc supervisor in Paris. And then from Paris, I moved to Stuttgart, where I joined my husband. And I was again very fortunate to meet this very wonderful man, Professor Ole Anderson, who had a very big role in shaping up my career. And after this postdoc, I came back to India and I joined as a faculty in Essengo Center, from where I have done my PhD. So to become a faculty in a place where once you are a PhD student is actually a dream comes true. And all I want to say that is possible if you really have the perseverance and the dedication, which was also mentioned in Professor Chandrima Shah's speech, that it is the perseverance and dedication that makes you what you are dreaming for. And there I basically had my own research group, which works on modeling of materials. We are primarily interested in the problem of the electronic structure theory of materials, problem of magnetism, the problem of properties of materials at nanoscale, and also the properties of arts material. And this is the picture of a group, and you can say of my group, which has possibly more number of girls than the boys. And it was mentioned by Professor Chaudhary again that women are better in multitasking. And I do believe that because I find my girl student to be much more disciplined in a sense that they are much more focused. And if I involve them in more than one project, they perform better than the boys simply because possibly they can handle better the multitasking. And in the same institute, as has been mentioned, I'm currently the director and I'm very happy about it because I think Professor Chaudhary mentioned it, that reaching the pinnacle, we do have made breakthrough, but really the ultimate breakthrough has to come where you have to reach the pinnacle. And mentoring was mentioned. I have mentored girl students. Very happy to say that two of my girl students, they are currently faculties, one in IISER Kolkata and another one found job in Japan in Tokyo Tech, and she is an associate professor there. Life is not always work, but a lot of fun. And you can say that with my girl students, and they mix gel very well. I mean, in a group, having the girl student, they act like a perfect mentor to the young boys. And I'm always very, very fortunate to have all these girls in my group. And these are some of their achievements, very nice moments. And I just couldn't resist but sharing this picture from which I got from the internet. So it shows a cartoon picture where there is a room and there are three ladies in the room, and this man opens the door and tells, "Excuse me, ladies, could you tell me where the selection committee members are?" Because he never expected in that room with these three ladies that can be a selection committee meeting room. But these three ladies just answer, "Here we are." So that is the dream we have. That is the pinnacle we want to reach. And there have been lot of activities, lot of events organized. This fact has been appreciated at all levels, and I'm very happy to say that now there is a gender equity in physics group, other than many other groups which have focused primarily on the physicists. Physics is a subject which is considered where probably the gender ratio is most bad, because physics is considered somehow not like a subject which is that for the girls. And conferences has been organized primarily looking at the gender equity in physics. And government is very vigilant, and we can see our former DST secretary in this women scientist and interplaners conclave, which was a big event in Indian Science Festival, as you can see. And this is not an Indian event. I think it was mentioned in Professor Chandrimasha's remarks. It is a global effect. We organized an Indo-French seminar about women in science, and there we found that actually the problem in India and France are very similar. Only the numbers are different. Only the hard numbers, the ratios that we are talking about, the number of women directors, the women PhDs, those numbers are different between India and France. But the very fact that as you go up and up, the women disappear, those things, also the stereotype, what kind of subject is chosen, that trend is absolutely similar between India and France. So just by attending that meeting, what I learned, the problem is universal. The nature of the problem is universal. So probably all across the world, therefore, the people are joining hand to really solve this problem. And this has been already mentioned in Professor Verma's talk. There have been a lot of policy effort. The significance of this issue has been appreciated, grasped, but by many institutions, organizations, at the funding level, at the level of the institute, everywhere there is this awareness that this is an issue which we cannot ignore and we have to attend to. But there is still enough scope of improvement, awareness. I think this program that we are organizing in IIT Jodhpur is one among that. Promoting women in leadership position, recruiting and retaining the next generation women, that should be one of the key steps that has to be taken. There is a big role of the search committees as well as the funding agencies, and probably some more input can be given to the committees and funding agency in terms of the policies they have. Finally, this is the book that was published by INSA, and this book is on ethics, but there is one chapter that was devoted to ethical issues associated with gender bias. So the gender bias is considered as an ethical issue, and in every chapter there was a quote, and we chose the quote which has been stressed. The essence of this quote has been stressed, in fact, by all the speakers in their remark. Achieving gender equality requires the engagement of women and men, girls and boys. It is everyone's responsibility. It's a societal issue which, as a society, we need to address too. And finally, what is the key that, many times the, people ask, especially if you are considered as a science achiever, what is the key? The key is there are several different problems, several different remarks that are thrown to a woman, but nevertheless, she persisted. So the persistence is the only key point for the success. You have to be persistent. You have to convince your parents. You have to convince the people in your neighborhood. You have to convince your colleagues. You have to convince the funding agency. You have to convince the institutional head. So in all levels, the persistence is the only key point. So with that, I would like to conclude my remarks, and I wish all the best for this 2 days program. I'm very sorry I could not be personally present, although I wished it very much, but there were some pressing commitment here for which I could not. But I am absolutely sure I have seen the program. It's a fantastic program and it's going to be major success. No doubt about it. Thank you very much once again.
Thank you so much, ma'am, for sharing your own experiences and journey as a woman researcher. It is quite inspiring for all the girls and women scientists present over here. Thank you so much, ma'am. I now request Professor Anil Mishra, Director in Mass DRDO, for giving his remarks.
Very good morning to all of you. Professor Chaudhary. I was thinking that what should I share with you? And then last night we had a small discussion. And I went back in 500 BC and I asked myself a question. This we'll share later on about the Arnold Francis, that she got the Nobel Prize in 2018, but we'll share later on. So I asked a question myself that we had a Gurukul in 500 BC, and there were no student from other gender. What could be the reason? Keep asking myself, I didn't get any answer about it. So I think this is one thing that we should really look upon, that why in Gurukul there were no student from other gender. The title is very tempting and is really befitting for me, is that human potential to bring science and technology is very much essential. We have heard about the data that every institution, they have got the ratio of 60 to 40 or the 70 to 30 from both gender. But what is missing in this, I will take only 2 to 3 minutes to conclude. That 33% of the people, they apply for something to get the funding, but only 12% they get it. So what do you think about other 20%? They don't get it. Whenever we try to achieve something, we strive from the both gender, but with some limitation in the other gender, I will not say. And one thing that I would like to declare from this podium is that we should stop saying aurat. Is a very bad word. We should start saying whatever the gender you want to say. Dr. Chaudhary very nicely mentioned about the artificial intelligence and human performance. It will be coming. So there, again, gender will be not considered in that one. But what I thought that going through some of the very beautiful era of women scientists in this country, and surprisingly, we have Santi Sarup Bhatnagar, J.C. Bose, all these names we have to give the award. But I request Dr. Burma to consider 3 names, if they can constitute the fellowship, and they will be the really potential, you can say, to change the world in science and technology. If we can constitute one award in Kamala Soni name, that is, she is the biochemist in 1939, she got the PhD. So we never thought about these women, those who have contributed a lot to this country. So Kamala Soni, biochemist, if she is given one fellowship on her name, then it will be very nice that one can think about propagating the science in a different way. The second name comes to me is that In 1960, Rajeshwari Chatterjee, you must be knowing, all of you, that she was the person to really develop about the microwave electronics engineering in IIC Bangalore in 1960s, did the PhD. So my request to Professor Burma that he can constitute a award, either fellowship on her name, that will be very nice. Not the last one, but we know all about Banerjee, Asma Chatterjee, I will talk about. Asma Chatterjee, she was very good in medicinal chemistry. She did PhD in 1961, and again contributed to the science in a very different way in medicinal chemistry. So if we have the three fellowship coming from any sector, either it comes from DRDO, either it comes from DST, either it comes from any funding agency, you just see their career, that how they started and they build up institution. And today, if we have the fellowship on their name, either some scholarship on their name, then certainly science will progress in different direction. This is what I would like to share from this podium. And that will be the really barrister. Likewise, I like Francis Arnold history, and then we should really inculcate in ourselves. She got the Nobel Prize in 2018 in chemistry. If you move the next slide, you can just scroll the slides, and then it will be for them to learn and to read. And with this remark, I close my speech that we should really think about that how Gurukul and how come that all rivers are named on the name of them to please and not to give something which is required to progress from the childhood till the final education to contribute in any kind of decision and then any kind of science and technology that we have been talking. Thank you very much. Just you scroll the.
Thank you, sir, for sharing your thought-provoking views on women participation in science with us. May I now invite Professor Alok Dhawan, Director, Center for Biomedical Research, to share his remarks.
थैंक यू वेरी मच ऋतु। आप सबको नमस्कार। सबसे पहले तो मैं अपने परम मित्र, माय कोलीग, डायरेक्टर आईआईटी जोधपुर को धन्यवाद देता हूं कि उन्होंने मुझको इस काबिल समझा कि इस ऑगस्ट गैदरिंग में आके कुछ अपनी बात रख सकूं। मैं डॉक्टर संदीप वर्मा को हृदय की गहराइयों से बधाई देता हूं कि उन्होंने एक ऐसा टॉपिक चुना जिसमें कि हम सब मिल के योगदान दे सकें, हम सब मिलके इसके ऊपर मंथन कर सकें, चिंतन कर सकें कि हम यहाँ पर क्यों हैं, जहाँ पर इस समय हम हैं। लेकिन बहुत अच्छा लगा प्रोफेसर चंद्रमा साहा ने जब ये बताया कि ये केवल भारत की चिंता का विषय नहीं है, पूरे विश्व में ये चिंता है कि किस प्रकार से हम वुमेन को आगे बढ़ाएं, उनको एक लेवल प्लेइंग फील्ड मिले। और अगर आप देखेंगे तो जो सबसे विकसित देश है, जिनको हम विकसित देश बोलते हैं, आज भी उनके यहाँ पर पे पैरिटी नहीं है। I think from that perspective, I was talking to Professor Verma yesterday evening, कि we have done far better in some instances where that biases are not there. I agree that people at the pinnacle, as Shantanu mentioned, perhaps are not as many and few and far between. But I think if you talk of leaders in science, I think there have been many leaders in science, in entrepreneurship, in mathematics, in engineering that you can count in terms of women who've done wonders. As far as I'm concerned, I mean, because I heard Tanushri talk about her personal experiences, I would say as an administrator, I thought women bring a different culture to the boardroom. Let me begin from the top, and then I'll go down and share with you the differences that happen when women are in the boardroom. And as soon as and the other thing is when you're an administrator, I think if you have a woman as the second in command or a woman who's handling your office, that's the best thing to happen. Not only they bring in a lot of compassion, lot of, decorum to the office, but also I think they are best in keeping the secrets. It's the other way around, because when the men are around, they go and tell home and then that secret goes out. But if the women are at the helm of affairs, that secret never goes out. That was my experience for past 10 years at least now. So I think it's a fantastic thing to have women at the top, to work with them, to understand their perspective, to understand their point of view, to understand how you can make a difference in the same institution where you were born, brought up for almost 30 years like I was, and I suddenly realized things were missing in the institution, because now I had a person who could tell me upfront that this is what needs to be done to make it more inclusive, make it more friendly. And the changes were there to see. I mean, I won't go into the policy issues initially, but I'll delve into that as well. But Sandeep, I can share with you that at some point in time, the girl students who were in plenty in the institution were either due to family pressure or otherwise would leave, say, about 5:30 or so. And when I left in 2020, they were playing badminton at 8:45 in the evening. So I think that totally revamped the thought process of women, and the students who are still playing badminton at 9 o'clock in the evening. I think if you provide an ecosystem where they feel secure, they feel empowered, I think that is what needs to be done. जहाँ तक नए भारत का सवाल है, मैं समझता हूँ जो मिनिस्ट्रीज कर रही हैं या जो प्रधानमंत्री स्वयं कह रहे हैं, हर जगह पे एम्पावरमेंट, हर जगह पे आपको अपना फुल पोटेंशियल एक्सप्लॉइट करने के लिए एक इकोसिस्टम प्रोवाइड करना चाहिए। मैं समझता हूँ बहुत ज़रूरी है, और हर एक क्षेत्र में मैंने पीएचडी बायोकेमिस्ट्री किया था, लेकिन एमएससी केमिस्ट्री से किया था। सो आई गॉट टू नो द बेस्ट ऑफ बोथ वर्ल्ड्स। जब पीएचडी किया उस समय मैं डिपार्टमेंट में विजिट करता था, ऑल्दो आई डिड माई पीएचडी फ्रॉम CSIR. Out of a total of about 15 or 17 students in Lucknow University Department of Biochemistry, I never saw more than 2 boys in the entire batch in post-graduation. So I think that was how it is as skewed. I think there are perhaps now 4 or 5 boys, and that's it. So it just goes to show that at the post-grad level in science, even in chemistry, there are about 60 students, and I think no more than 10 or 12 boys, all the rest are girls. So I think that level, the girls do really well, and as they progress up the ladder, and I think all the previous speakers have mentioned, that somehow they sort of lag behind. I think that is where we need to improve the conditions at the workplace, perhaps, especially for the married women. If you can ensure that they have enough facilities at the workplace, I think they would be, more than happy to contribute. The other thing of course, as a male, I realized very late in life, though, that, women have their way of doing things, and you have to understand their way of doing things. You cannot, and I'll share a very recent example, I would say. Maybe 5-6 years back, a professor with whom I worked since '93 in England, for some thing she said, I'm going to write a recommendation for you because I've seen this, or she had received a letter from the government of India that they would like to look at potential candidates for a position. And she said, look, I'm going to write a recommendation for you for that position because I understand that you're the best suited. So I'm just, because I've never written a letter to the government of India, I'd like you to see the letter. And you have to believe me, when I saw that letter, there were 2 or 3 paragraphs about my scientific career and my scientific journey and how she knew me since '93. But the last paragraph was devoted only to my interaction with my family as she perceived, and how how she felt that I was a family man and this and that. I said, well, Diana, you don't have to write this. And I mean, she's now 81. She said, Alok, you shut up. This is how ladies write letters, right? This is how a lady will write a recommendation letter. It will never happen that I'd write a paragraph about a lady if I have to recommend her to a position, which is a directorship position, okay? But she said, you should now realize, that how ladies feel, how they think, how they write, and it's different from males, right? Different from men. So I think we need to understand their perspective, their frame of mind, their thought processes, what they bring to the table. And I think most of them said today, the speakers before me, that they're multitasking. Of course, they're multitasking. But one thing they always do very well and with great finesse is the fact that while they are in the administrative positions, they still don't forget that there's a family back home, and they would realize this very well, as opposed to the men, I would say. So I think it's a fantastic thing to be having such a conference and sort of trying to see how we can facilitate this process. And I think if as a society we have to sort of excel, it's just a thought that came to me this morning, that if you sort of want to run fast, you perhaps can run alone, but if you have to go further, then you have to take everyone along. If you have to reach the goal, I think the goal is to ensure that everybody in the society contributes. And for that, we have to take them along, and for whatever it takes to ensure that both the genders are equally represented, not only at grassroots, but also at the head of the institution. I think it is very important that facilitatory mechanisms or mechanisms otherwise which ensure. The other thing I feel quite passionately about is the fact that we talk about science, technology, engineering, but not much effort is given to mathematics. And I think that's the other field which we need to see more of women come into mathematics. I mean, I have had the privilege of seeing a couple of them in the recent past who've converted mathematics, which was a very boring subject, to be honest, into something which is called as creative mathematics. And they teach mathematics which are different methodology. The pedagogy is different, So I think the creativeness that they have is very difficult to find in us, to be honest. But for me, I always say that I was dumb yesterday. So every day is a learning process for me. And this is one such program that I'll never forget in my life. And I should thank Sandeep for putting me up, where for once we are in minority. I think by and large we are in majority, and the girls are very less. It also gives us a great pleasure to share our points of view and how, as so-called leaders of science and technology, we can facilitate. I've been having thoughts that how people in this auditorium itself have done wonders in terms of their entrepreneurship, in terms of leading science. And they're very small things. I mean, I'll just mention last bit and then I'll stop. There's a lady in Lucknow, where I belong. She's a nutritionist. And so her husband is an MBA, and both of them came to pitch as a startup. And I was an expert sitting in that pitch. And the lady presented the entire thing, and the husband presented the data. And they said, within 5 years, we're going to become 1,000 crores. And sort of we laughed. And they'd come for about 3 crores of investment. I think there are close to about 500 to 600 crores now, less than 5 years. And only because she's a nutritionist and she was able to come up with the correct, they sort of pitched into the correct system, which was snacking. And they've come up with very well thought of snacks that you can have, which are roasted, and they don't give you calories, extra calories, or no extra salt. And I think that is also trying to understand how you can pitch in as an entrepreneur. If you have it, I mean, I think ladies, if you look at them, they're the best managers right from the very beginning at home, the best leaders if they come to the leadership position. So I think if an entrepreneur, if you have that bug in you, please ensure that you take it out as quickly as possible. I think I've known at least 3 or 4 such wonderful ladies who've done fantastic work in a very short period of time. I think ये जो नए भारत की बात हो रही है, नए भारत को आगे ले जाने की बात हो रही है, 2047 की बात हो रही है, ये आप लोग का समय, हम लोग उसको बैठ के देखेंगे कि किस प्रकार से आप लोग इसको आगे लेके जाते हैं। मैं समझता हूँ भारत का जो भविष्य है वो बहुत उज्जवल है। आप जैसे लोग और जो हमारे सेक्रेटरीज बैठे हुए हैं यहाँ पे या डायरेक्टर साहब बैठे हैं, इन लोगों ने जो एक प्लेटफॉर्म प्रोवाइड किया है, आई थिंक दिस गोइंग टू गो ऑन. Several such symposium will be organized across the country, and I think I'm very grateful to Sandeep for thinking in these lines. And so with this, I'll stop, and thank you very much for giving me this opportunity. Thank you.
Thank you, sir, for sharing your thoughts and inspiring and motivating us on this occasion. I now invite our guest, Dr. Ajit Sharma from RSC India on the stage and brief us about RSC initiatives for women in science.
A very good morning to all of you. A very warm welcome to everyone to this unique science event, Empowering Science and Technology with Women. This is a step towards building a new era, which celebrates and showcases the diversity and inclusion. We are privileged to collaborate with IIT Jodhpur and Science and Engineering Research Board, SERB, on this program in the backdrop of the historical and charming city of Jodhpur. Personally, I would like to congratulate SERB Secretary Professor Sandeep Verma and Professor Ritu Sharma from IIT Jodhpur in organizing this event, as well as thank them for extending an invitation for us to be a part of it. For those who are familiar with the Royal Society of Chemistry or are not familiar with the Royal Society of Chemistry, I would like to mention that we are a leading chemistry community with over 45,000 members across 100 countries. We are a leading publisher and are advancing chemical sciences around this world. As a learned society, we are committed to promote gender equity, diversity, and inclusion. We are glad to know India's new science and technology policy, which has laid significant emphasis on diversity and inclusion. India has launched some robust initiatives to empower women in science. We too have been working on the diversity and inclusion initiatives. So in early 2018, we published a report, Diversity Landscape of the Chemical Sciences, which raised many questions about the current state of diversity in the chemical sciences, and in particular, highlighted the lack of career progression for women. Later, we explored the cause of poor retention and progression of women in our Breaking the Barriers report and made commitments to counteract them. For example, we launched career grants. This is aimed at helping women chemists to attend chemistry-related meetings, conferences, and workshops. For an additional cost, if there has to be, this money can be used to cover any additional cost chemists incur towards care and all. Our recent report on gender bias in chemical science publishing found out that the biases do exist both in the pre and post publication status as well. These subtle biases, which occur throughout the publishing pipeline, combine to put women at a disadvantage where disseminating this research. For instance, female authors are less likely to be benefited from the visibility provided by being a corresponding author. We are taking measures to address these challenges. My colleague, Alejandra Paliramo, who heads our Global Inclusion Program, will share details about our initiatives to address gender equity, diversity, and inclusion. Gender diversity is high on our agenda partners, Department of Science and Technology, British Council, Tata Trust, Tata Technology, and ISO Pune, launched UK-India initiative, inspiring India in research, innovation, and STEM education. We also call it iRise program. This is to enhance the skills and drive innovation across the STEM ecosystem. In this initiative, gender diversity is a key component, and female PhD scholars are being offered industry internship at India's leading business organizations, along with professional skills training. So this program has been recognized by both Prime Minister of India as well as Prime Minister of UK as a major bilateral initiative and has been included in the UK-India Science Roadmap 2030. Going forward, we are collaborating with the Chemical Research Society of India and other partners to publish evidence-based report on gender diversity in the Indian chemical science research community. This report will investigate challenges and opportunities that influences the career progression of female chemists. In this regard, I would like to invite you all to attend a special session on the societal challenges for women in science, chaired by Dr. Shweta Raghavan. We urge to share your thoughts and inputs during this session, which will help us in developing this report. Before I finish, I'd like to thank Professors Ritu and Irwin from SERB, who have worked very diligently, very hard to make this event happen. Wish you all a stimulating and a productive program. Thank you very much.
Thank you, Dr. Ajit, for sharing your thoughts on the event and briefing us with the activities of RSC. Now, I thank all the plenary speakers, all the inaugural guests for the event today, and also the invited guests, faculty members from various institutes, and students of IIT Jodhpur and various institutes, all the registered participants for joining the inaugural session. Before I stop, I would also like to introduce the schedule of the day. We have 4 different themes. Theme 1 is on biomedical, bioimaging, and therapeutic for healthcare. And we have speakers of the day, Professor Ruchi Anand and Dr. Neetu Singh from IIT Delhi. In the second theme, we have on sustainable chemical synthesis, and we have Professor Namrata Rastogi from CDRI and Professor Shabana Khan from IISER Pune. On the other theme, we have on advanced materials for energy and environment. There we have our speaker, Professor Shobna Narasimha from JNCSR Bangalore and Dr. Pooja Devi from CSIRO Chandigarh. And then we also have Dr. Khushbu Kushwaha from Wiley, who will be briefing us on Wiley initiatives on women in science. We have another session in the evening on societal challenges for women in science, and that would be a town hall activity, which will be moderated by Dr. Shweta from RSC. We will also have Dr. Alessandra Palermo from RSC UK, and she will be talking about RSC's diversity and inclusion. Following that, we will have a cultural program in the evening, and I look forward to that. On the next day, tomorrow, we will have another theme, which is on AI, IoT, and data science. And we have our distinguished speakers, Dr. Lipika De, Chief Scientist from TCS, and Professor Shriparna Saha, Associate Professor from IIT Patna. And following that, we also have another theme which will cover women entrepreneurs, and they will share with us their journey in science and technology for bringing the entrepreneurial activities. So we have with us Dr. Sufia Khan from Banasthali Vidyapeeth, and also she is a founder at Brumlins Water Technologies. We also have with us Dr. Anuya Nisal, who is founder Surgeon Medio Products. And then we have Dr. Manjusha Shelke, who is also co-founder and director at Rechargian Energy Private Limited. Following that, we will have a group discussion, and we will close the event with the poster prizes, which are sponsored by RSC and Wiley. So I have few announcements to make before we break. First, I request all the students to put up their posters before the lunch session without missing any of these sessions in between. And also, I request all the speakers to put up the presentation for the next technical session. Following this, I will also request my colleague, Dr. Shruti Dhara, to convene the proceedings for the technical sessions. Thank you all, and I request all of you to please come for the high tea. Thank you.
using you?
Hello. Hello. Hello, mic check. Good morning once again. We will shortly start with our technical session. The first theme of the day would be biomedical bioimaging and therapeutics for healthcare. And Professor Mitali Mukherjee from IIT Jodhpur would be chairing this session. Before I begin, we have a couple of announcements to make. This is for the presenters. Each talk will comprise of 20 minutes of presentation, followed by 5 minutes of question and answer round. I repeat, each talk would comprise of 20 minutes presentation, followed by 5 minutes of question and answer round. Presenters are requested to stick to the time limit. There would be a first ring at 18 minutes, followed by the final ring at 20 minutes. Let me introduce the chairperson for Team 1, Professor Mitali Mukherjee. Professor Mukherjee is a professor and head of the Department of Bioscience and Bioengineering at IIT Jodhpur. She has a PhD in molecular genetics from Indian Institute of Science, Bangalore, and was earlier a chief scientist at the CSIR Institute of Genomics and Integrative Biology. Her research is in the broad area of understanding human genome structure and variation for its application in the discovery of biomarkers for predicting susceptibility to diseases, understanding human phenotypes, and environmental adaptations and mapping mutational histories. She has also developed a new area of research, Ayurgenomics, which aims to integrate Ayurveda with modern medicine through genomics. She is also an affiliate faculty at the School of Artificial Intelligence and Data Science at IIT Jodhpur, and she is presently involved in developing Center of Excellence in Integrative Precision Health. One of the sub-projects in this initiative is IoTech that combines electronics, digital health, and AI, and multi-omics approaches for realizing evidence-based Ayurveda solutions in a transdisciplinary framework for implementation of integrative medicine in different clinical settings. Professor Mukherjee is also coordinating a project in the Jodhpur City Knowledge Innovation Cluster called Thar Designs that aims to carry out an integrated study of the desert ecosystem to propel discoveries, inventions, and innovation for addressing health challenges in arid regions. She has been a recipient of a number of national awards, including the CSIR Young Scientist Award 2001, DBT Young Woman Scientist Award 2008, Shanti Swarup Bhatnagar Award 2010, Vaspik Award 2016, and is a fellow of Indian Academy of Sciences and National Academy of Sciences. She has been recently nominated in the Women Lift Health Leadership Journey 2022 India cohort. Let's welcome Professor Mitali Mukherjee, and I request her to chair the first technical session on biomedical, bioimaging, and therapeutics for healthcare. Please, ma'am.
Hello. Good morning, everybody. Can I just, I'm a little vertically challenged, so I thought I'll just, it's a pleasure to invite women scientists in this special forum, and it's really a heartening change, and this concept of this symposium itself is very fantastic. So I'd like to first invite our first speaker of the day, Dr. Ruchi Anand, who is a professor in the Department of Chemistry at IIT Bombay. And she did a PhD in the Department of Chemistry and Chemical Biology at Cornell University. After that, she conducted postdoctoral research at the Sloan Kettering and University of Pennsylvania. After that, she joined IIT Bombay in the year 2008 as an assistant professor. Her lab employs a combination of X-ray crystallography, cryo-EM, biochemical and biophysical tools to understand molecular mechanisms and implications to human health. And I will not get into the detail of what she works because I would like her to have more time on her presentation. But she has served as an editorial advisory board for ACS sensors, and she was a recipient of the National Academy of Science Fellowship in 2019 and won the National Women Bioscientist Award, Department of Biotechnology in 2018, and was awarded the CRSI Bronze Award Medal for 2020. She's also the recipient of DBT Wellcome Trust Alliance Senior Fellowship in 2020, and she was admitted as a fellow to the Indian Academy of Science in 2022. So congratulations for so many achievements, and I would really like to invite you for the lecture.
I hope I can. Thank you so much for the invitation. I just want to say that before I open my presentation. And if I can somebody? And it's a very unique endeavor, I have to say that. And I'm very, very glad to be part of this endeavor, and I'm very proud to be standing here, being able to participate in this. So I congratulate both SERB as well as IIT Jodhpur, the organizers, including Professor Ritu, who has invited us all here and brought all the women together. And it's like I said, it's a unique experience, one of a kind, and I'm so glad to be here. So I hope I can.
Get a few minutes.
Okay, I can actually start since time is of essence. I just wanted to say before even I begin my talk that our lab basically works on two major themes, as was being mentioned. We work a lot on developing biosensors, and mostly we work with proteins and enzymes and try to harness their molecular mechanisms and then see if we can do an application as well as understand basic science. So in application, we basically have tried to develop a lot of biosensors for water pollution monitoring. And here we have aromatic pollutants that we have designed. And I'm very fortunate, I would say, to be in IIT because we were able to go from, in this case, from just designing and mutating proteins and designing a bunch of biosensors, we were able to go to actually making a device which we showcased in TechFest in 2020. So that was something that I feel like, if you can move from your science across disciplines, and I think that happened because in IIT we have access to the engineers. Apart from that, our lab has a very major focus in trying to develop therapies for the problem of antibiotic resistance, because antibiotic resistance is a huge problem that is occurring throughout the world, where they are boons, the antibiotics are boon, but now bacteria are catching up. And the problem that we work on is how do bugs become resistant and why they become resistant. That is what I'm trying to address here. So generally bugs become resistant because the basic problem is that the antibiotics that target, many of them, not all, they target the protein synthesis machinery. This is where all the proteins, all the enzymes, all the workhorses in your cell get, I'll just move to the slide, moves. Stuck. Sorry. Yeah, so till this is still getting stuck. So it's the ribosomes are the molecules which make mostly all the proteins. So when you make the proteins in the cell, what antibiotics do, like erythromycin, if you remember, tetracycline, the common ones that, you sometimes take off the shelf. Many of these antibiotics that you take off the shelf, these go and bind to this molecule called the ribosome. It's a very big molecule, and it is used for precision protein production in the body and making all your enzymes, all your requirements, all ATP, energy giving enzymes, energy, harnessing enzymes, I would say. All of them happen through this molecule ribosome. And in this ribosome that is there is, you can maybe skip this, it's okay. In the ribosome that is there, we have this ribosome that is there. Is there a pointer? So this ribosome which is there is a very large molecule, and the drugs go and bind here. And so what the question that we try to understand is, if we know the mechanism by which they, it's okay. If we know the mechanism by which they go and bind, then maybe we can understand how it is then becoming resistant. So this erythromycin that I was talking about, these macrolide lincolnamide streptogramin class of antibiotics, they go and bind in the protein exit tunnel. Okay, so whenever in the ribosome there's a protein exit tunnel, these antibiotics go and bind, and they do not allow the protein chain to come out. And that is the mechanism by which they kind of stop protein production. So bacteria, they don't like that. Bacteria don't want to die, they want to live. So what they did was they came up with a very smart way to stop these antibiotics from binding. What they did was they came up with this methylation reaction, and you can see there is a base in the tunnel which gets methylated, and you can have a mono or a dimethylation, and it is S-adenosine methionine, all mostly biological methyl donor is that. And what then happens is, when they come and bind there is a steric clash with the antibiotic, and the antibiotic cannot bind. So a bug which was like perfectly responding to antibiotics, if it is able to get this enzyme which methylates at a particular position where the protein chain is coming out, the protein chain cannot come out, and that's the mechanism of resistance. So then we thought that, let's try to understand this mechanism a little bit better. At a chemical level, it's an enzyme which puts a methyl group in the N6 position of this particular adenine, right? So what we wanted to know was, can we try to understand how this enzyme works and why this enzyme only goes and methylates this particular position. Now, methyl transferases are very important enzymes. There are methyl transferases which are there for your gene regulation, for histone modifications, trying to stop certain epigenetic processes. There are DNA methyl transferases, and this is an RNA methyl transferase. So even in gene splicing. So how does one enzyme know that it has to go to the ribosome at a particular position and then do its methylation and become, make a bug a superbug? So we wanted to understand the mechanism of targeting in this particular case, because similar mechanisms and similar things are present in nature. So targeting is the key here. Why would I want to know targeting? Because if I know targeting, I can stop the targeting, develop certain drugs so that they never actually reach the ribosome. Because if I try to develop inhibitors for this SAM, they all have the same pocket. They have a very similar mechanism. So I get stuck in, off-target effects. So if I know the targeting mechanism, then that would really help me. So what we did was, we said, okay, that's a good idea. Let's take two enzymes. One enzyme which only goes to this pathogenic site, and another enzyme which also has a resistance, but it's also involved in biogenesis, which means completion of formation of the ribosome. So in short, we took two methyl transferases. This particular methyl transferase only goes to this particular site, and this particular methyl transferase only goes and methylates this particular site. There is no cross reactivity. Now, if you look at the enzymes, they look like, twins of each other, like cousins of each other. So you would think, where in this enzyme is the information that I have to go to A place and not B place, and vice versa? So if we know this, the targeting problem will be solved, right? So we took two approaches. I will quickly go through the first one, and I hope I still have time for the main thing that I wanted to say. And in the second one, we took a ribosome protein complex. In the first one, we took a more chimera type of approach. So let me describe very quickly the first approach. What we did was, we said, let's take this enzyme, which goes to position A, and by doing a lot of experiments or thinking, what we did was we made chimeras of this enzyme. So I think somehow this slide got forwarded. But what we did was we said, where are the differences? Because the targeting may lie in the differences between them. So we did a phylogenetic approach, structural approach, and then we made a lot of chimeras. We cut and pasted portions of one protein into the other to see where the targeting determinants are going to be. And that's what I was trying to say here. We cut it, this is the enzyme which we want this to be earned. But we started with this enzyme and we wanted to know, can this enzyme do the methylation of the position, this RNA template, which is that particular position, which it was not able to do before. So what we did was we cut and pasted various portions of the enzyme. And you can see here, there are two loops. And I'll call this as loop 1 and this loop 12. When we paste these two loops in the version of the enzyme, which does at that particular site, it starts working. Yeah, so it starts working when that happens. So you need these two loops, you switch them between the enzymes. So what I've done is I started with an enzyme which did not go and methylate a particular position. I switched the loops from a different enzyme, made chimera. And by doing so, I made an enzyme which was now capable of being working like an enzyme which works in a superbug. Okay, now I tested this hypothesis further and I went into cells. And when I went into cells, what I figured out is if you take these chimeric enzymes and put them in cells, these cells, whenever they grow, that means they are resistant to the antibiotic. You add the antibiotic, if antibiotic is working, cells will not grow. So you can see the original methyl transferase, they don't work, but when we methylate when we change the loops, then it starts working. And that's what we see here. And so that told us that the determinants lie in these two loops. And if you can design inhibitors that are directed towards these loops, that might be good. Now, all this I did, we were doing with just RNA template. And that's not a place we want to be. What we did was, we wanted to actually go to the ribosomal level. So this is one RNA template and this. So this is still, a caricature type of model. So we decided that what we will do is, we will actually move to the ribosome. Okay, we will take the 30S ribosome where this methylation site is, and then see if we can make a complex of this protein with this particular RNA. Not the whole 30S ribosome. It's a huge complex, actually. So for this particular thing, we could not use crystallography and other techniques because it's very difficult to crystallize such big macromolecules. So we use this bioimaging technique called Tri-Electron Microscopy. Here, there are many techniques, but if you want to go to the atomistic level, X-ray crystallography and now single particle cryo-TEM is another approach where you don't need crystals also. So we decided to use this bioimaging technique. And in short, what we do is we make grids here and we put our biomolecule and image it. Okay, and then we image the biomolecule and then we reconstruct the image by using certain algorithms, statistical based algorithms. So that's what exactly we did. And we were able to collect data and make several models. And here you can see we were able to get a number of structures down to about 3 angstroms or so. So what does this tell us? What it tells us is how does this enzyme go and bind at that active site? Okay, so this is the ribosome, the ribosome where this methylation will happen. And this is the enzyme in purple. You can see here. This is the enzyme in purple, and this is one of the helices where it goes and sits. So if I will to show you, maybe if I have, I may be able to show you in a movie in the next slide, but what I want to show you is this particular enzyme, how does the recognition happen? Now we are not in a small RNA template. We are in the entire ribosome type of structure. So what we noticed was that the way the recognition happens is, it is like a bubble wrap, okay? So the RNA goes and sits and completely engulfs this enzyme and makes specific contacts. And by doing these specific contacts, it makes sure that only the right methyl transferase goes and sits in the correct pocket and nothing else. So you can see here, when the right methyl transferase goes, the RNA helices of the ribosome, they move, allow for this particular methyltransferase to actually get in. It flips in so that methylation can happen at the N6 position. And that's how we were able to trap it in the structure that we got. Right? And so that's how the chemical reaction happens. But the specificity is determined by these peripheral yellow, forget about just remember colors here. Many of these colors of RNA in the ribosome are making contacts which are specific to the protein. Right? So we went a little bit deeper into it. I don't know if I can or not. I'll try to play it if possible. And if it's, so this is it is a bad. So this is the ribosome, and you will see this is the protein. This magenta thing comes in. It is surrounded by these RNA. You can see it's like bubble wrapped, and there are specific places like the head and at the bottom where these methylation kind of happens. And what I want to tell you is that there are two sites, if you can see here. There is two places where there's a base flipping happen, and that's how the recognition happens. So if you want to develop drugs for against this enzyme, this is a very good site, which is far away from the active site, about 15 Armstrongs far away from the active site. So that's what you can tell from this structure here. What else can you tell from the structure? What else you can tell is that you can tell how this particular enzyme actually recognizes the methyltransferase. So if you take snapshots of the structure, what you find is that just before the enzyme enters, it was a tight, these helices were tight. Then the enzyme came in, everything became disordered, the helices moved, allowed for the enzyme to enter, and then when the enzyme leaves, again, there's a methylation and it becomes tight again. So the mechanism of how the entry and exit happens also you can tell from this imaging studies. So the power of this kind of imaging is at an atomic level, you can get all this information. But the other thing that we did was we said that now we have the image, right? We know how this whole process is happening. Why don't we go to these specifics, like where this protein and this RNA contacts each other? Let's go to specific residues and then see what happens, okay? If we mutate these ribosomes itself, do the binding still happens or there are problems in the methylation? How does it work? So to do that, we got this machinery from Rachel Green's lab in Johns Hopkins, and that gave us the ability to make mutated ribosomes. We could introduce mutations in the ribosome. For example, I could make this helix shorter or longer at my will, and I did that. And we could also change various interactions and bases, right, which we were thinking were very important in the interaction. So to name a few, what we did was the obvious. We actually mutated the active site. We got rid of the adenine, made it into a guanine, cytosine, stuff like that. And obviously the activity is gone. We also took this whole site and we shuffled it in the ribosome to see, if the minimum number of amino acids are enough, bases are enough. That was not true. You have to be at that particular position because you have to be bubble wrapped properly, right? So that was very important for this. Not only that, like I told you, the 3D architecture of the surrounding environment is very important. And when we actually change that in 3D architecture, we see a lot of issues. And you can see the activity goes down dramatically in cases where you are near loop. I mean, it's a lot of data to take, so let me just tell you. Whenever you are near this loop, remember those two loops I talked about, loop 1 and loop 12? Anytime any bases near these loops are changed, the activity profile dramatically changes, which tells you that these two loops, along with this head domain, are very important. This is where the head of the enzyme is. This is the loop 12. This is loop 1. Both of them are very important for actually recognition. So you get to know where the recognition elements are so that you can kind of attack them. Not only that, we were able to show that both these loops are so important that if you go to pathogenic versus non-pathogenic, the shape and the size and the interactions of these loops change a lot. So you can see in two enzymes, in one enzyme, these loops are very short, so the interaction from the RNA is completely gone. But in another case, these loops are long enough to actually, the red loop is longer than the small loop, so they cannot interact, and that's how specificity is maintained. So size and the shape of the loop and its interaction with this region, what gives the specificity. All right, so the moral of the story is we now know determinants that we can tweak such that we can make this enzyme not actually reach its binding site. For example, now we are developing inhibitors to this loop 12 so that if we are able to have small molecules sit there, they will not be able to then accommodate the ribosomal RNA, and the targeting mechanism is kind of disrupted. Okay, so the main aim was to try to understand the origins of antibiotic resistance and see if that tells us how we go about tuning tuning maybe small molecules, which will be then able to help us in drug design. So we learned a couple of things, and to summarize, the most important point I want to say is that targeting is done by base-specific interactions, and in the ribosome context and in the protein context, two loops play very important role, and ultimately the base has to flip to get methylated, and there are sites which are 15 angstroms away in the enzyme, which is near loop 12, which are very important for this base flipping to happen. And if you can make allosteric inhibitors, then your job will be a little bit better. So we were able to come up with insights in this work as to how to go about doing that. With that, I want to acknowledge Vinod, who at NCBS, who basically taught us cryo-EM. We had, this was our first stint with it, and we spent a lot of time with Vinod and Rahul, who's the postdoc in his lab. And Jui was the student I have a lot of respect for, because, you know, she single-handedly learned the whole ribosome, how to purify it and stuff like that. And now, I mean, she's an amazing student, and now knows how to do the whole cryo-EM from start to finish. I'm done. And this is Ruchika, who did the first part of the work. And last not the least, I want to thank Serb here, standing here. We are going to get a cryo-electron microscopy facility. Actually, we've ordered it, all thanks to the initiative from Serb. There are 4 such centers, and we are proud to be one of them, and to push this arena of science further. And thank you all. I would be happy to take questions. And sorry about this reverberating noise that I couldn't.
If anybody has some questions, okay, maybe I'll ask you a question. So, because I've been in the area of genomics and I work with the structural biologist Lipi Tukral in IGIB. So we did some fun experiments during the COVID time looking at natural mutants which survive COVID and of the viruses, and the ones which go away in time. And it provided her some very, very interesting sequence pockets which could be targeted. So it reduced the search space to natural variants which survive and natural variants which disappear. So do you use some of those kinds of genomic methods to filter out maybe the natural variants from the sequence domains?
More than the natural variants, what we do is that we actually look at many enzymes of, for example, methyl transferases. I mean, I skipped through it, but we made phylogenetic trees where we look at the basically genome sequences. And what we want to do is we want to understand how this enzyme is evolving into this particular methyl transferase. And when we were trying to design chimeras, what we did was we actually took this into account, and we pasted portions of one enzyme on the other and see in the phylogenetic tree where it moves. And we saw that some of these mutations resulted in becoming pathogenic.
Okay.
So that's how we tried to use it, but at the sequence level, not at the protein sequence level or the genome level.
Okay, thanks so much. So thank you for the wonderful lecture. And I think we will move on to the next speaker. Yeah, let's give a round of applause. And then let me introduce you to the second speaker of the day, Dr. Neetu Singh, who is the Associate Professor at the Center for Biomedical Engineering in IIT Delhi. She did her bachelor's from the University of Mumbai, even the master's, and then she moved on to get a doctoral degree in chemistry from Georgia Tech Institute of Technology in Atlanta. She obtained her postdoc at the Harvard MIT Division of Health Sciences and Technology. She moved back to India and joined as an assistant professor in the Center for Biomedical Engineering in 2014. In her current program at IIT Delhi, she's establishing research programs that explore systematic probing into nanomaterials, biological activity, and formulates design principles for developing nano system for specific biomedical and healthcare applications. And she's been awarded with a large number of young scientist awards in the country, like the IYBA by the Department of Biotechnology, and then she got the Young Veena Arora Young Researcher Award at IIT Delhi, and Nasi Scopus Young Scientist Award for Women in Science 2019, and DBT's Janki Ammal Young Scientist in 2021, and SERB Power Grant Fellow in 2021. She is also a mentor for IITD startup, Kriya Labs, that's bringing valorization to agro-waste by technology solutions. She's also the editorial advisory board member of journal Bioconjugate Chemistry, that is pioneering publications of ACS and new Springer journal in vitro models. So congratulations for achieving so many things in such a young age, and I think you'll be a role model for many younger scientists who are aspiring to be in your position. So over to you. Yeah. Is it? Stop, I think. Stop. Yeah. So we couldn't get the movable speakers, right?
It is here, Mama.
That's fine. I'll pick it. It's okay.
Just start a new speak.
Yeah, perfect. Thank you. Okay, so thank you so much for giving me this opportunity. You know, it's wonderful to be among, I think someone used the word minority and majority, so I feel great, you know, being a majority today. You know, I'm not going to give my introduction, but the whole philosophy of today's talk I'm trying to show here is how with our research, I've been trying to break barriers and I've been trying to come up with solutions. So I'm a chemist by training, as you, Professor Mitali mentioned. I did my bachelor's and master's in organic chemistry and moved to US and pursued polymer chemistry and biomedical engineering and so on, and realized that, you know, we can do a lot of things at the interface of chemistry and biology. And Ruchi wonderfully showed us how she has been using biochemistry to address problems in, antibiotic resistance and so on. So, you know, the broad goal of, you know, healthcare or the challenges that we have in healthcare is basically to come up with easy diagnostics, for example, early detection of diseases. And let's say we have, you know, we have not been able to detect the disease early on, can we have a complete organ replacement? That's what we've been working on. And in fact, everyone working in healthcare in biomedical engineering has these two goals as the broad goals for the research. So with that, what we would like to do is, we asked a very simple question. If we have to interfere with diseases, or if we have to come up with solutions for diseases, be it in diagnostics or therapy, we first need to understand them in vitro. We can't go for animal models or say human models or something like that, right? So we need to come up with realistic in vitro models. And that's the simple question that I asked a long time ago when we started our research group here, is can we develop these organs in vitro so that we can understand, or perturb diseases? Forget about organs, they seem a little complicated and many people have tried doing it, they've not been very successful. So let's start from very simple things like, can we just develop the diseased tissue? And tumor, for example, seems like just a bunch of, a tissue. So can we just mimic that? Can we just make a tumor in the lab? And can we study that and use that for various studies and understanding diseases? So this is just an overview of what we do at IT Delhi. My lab is focusing mostly on disease monitoring with the in vitro models that we prepare. We work on engineering organs, we work on developing new delivery vehicles, and all of these three areas, we are using knowledge of chemistry and biology to come up with solutions. And I'll give you one small snippet of what we've been doing in disease monitoring in the talk today. So I think Ruchi had already explained to you how important resistance to antibiotic is and how it is actually a pandemic and how it is going to become a big deal in a few years from now on. This is just to give you some statistics so that you become a little more aware and start realizing it, taking it a little seriously. If you look at COVID, which is what we all are facing and we're scared of right now, it's actually nothing compared to what is happening in number of deaths due to cancer. So cancer, of course, remains one of the big problems today in healthcare. And then the second one is AMR, which is antimicrobial resistance. In fact, a lot of European countries have already started reporting people dying because of these resistant bacteria being present in them. And the reason for this is our overuse of antibiotics or maybe abuse of antibiotics. And in 2050, we are going to actually, the predicted numbers are similar to what we have for cancer right now. And that's a very scary situation. If we don't come up with solutions right now, I think we will be in trouble. So how do we study? Why are we using antibiotics? Basically what happens is, and all of you have faced this, you get fever and you go to the hospital. The doctor does not have time to identify whether it's a viral fever or a bacterial fever, and they just prescribe antibiotics, right? So 2 or 3 days, if it is because of a bacteria, you will get better. If not, it's all right. You just take the antibiotic anyways. So that's the approach we've been taking in the clinics these days. And the reason why the doctors are doing this is because we do not have a method which can rapidly tell us whether the patient has a bacterial infection or a viral infection. It takes about 3 days to identify if it's a bacterial infection. Within 3 days, the immunity works and you anyways become better. So why waste that time and why waste that much money on that, right? So wouldn't it be nice that we take the blood sample within maybe say 1 or 2 hours, the doctor is aware that it is a bacterial infection and they can process the case as a bacterial infection, or it's not and process it accordingly, right? So right now, the techniques which are available right now is basically commercially available is these companies, BD has something called as Bactec, and there are many other, Thermoscientific has something. What this does is they have these vials, and these vials have a molecule, organic molecule, coated on the bottom of these vials. The patient blood is collected in these containers or vacuum containers, just the way blood is collected. And the blood which carries the bacteria starts growing. It's a closed system. The bacteria starts to grow. Once the bacteria starts to grow, there is a change in CO2 level. Because of that, the pH drops. And the dye simply senses the change in pH. Now, the problem is for this, so this is the principle behind it. And sorry, going back, okay. So the problem is if you have really low number of bacteria, look at the vial sizes. The larger the volume of the sample, you start increasing the sensitivity. Of course, right? Because either the bacterial infection you have to have large number of bacteria so that the pH really drops dramatically, or you have more samples so that you start seeing the change in the pH. Simple, right? So with this information, we thought, can we miniaturize this vial And I'll keep that thought with you. I'll come back to it once I tell you the solution. So that's the status of bacterial infection. So the idea is if I can miniaturize the vial, if I can have lower volumes, if I can, maybe I can use the same dyes for detecting, I mean, I'll talk about it in a little bit. Let me just move forward. What do we do? What is the status for studying cancer? Simple. Tumor biopsies is very common. You can get tumor biopsies for any kind of cancer right in today's clinics. And from tumor biopsies, you can easily collect tumor cells. It's a very straightforward technique. People do it all the time. Now, the question is, what happens after that? After that, they are grown in a 3D environment or a 2D environment, depending on what kind of study you're planning to do. And you start doing these endpoint assays. Endpoint assays is, all the typical assays where you do after 24 hours, 48 hours, whatever. Or to identify what proteins are present, what are the biomolecules, what are the genetic information, any kind of studies that you want to do, whether they're growing, not growing, all studies, right? Now here the problem is the transient information is lost. So we know that there's a lot of cell-cell signaling, and which is extremely important for cancer progression, right? That information is lost. Many of these proteins have short half-lives, and of course, all of these methods will not, the endpoint assays will not allow you to look at those, right? The pH changes, for example. Now, let's put the same pH change that I talked about here. If there is a pH change, local pH change, you have buffer in them. You will never see the minute pH changes that are happening in the microenvironment. And that's something very simple to detect, I mean, and that's exactly what we did in our solutions. So overall, with this information, the challenge was we do not have an appropriate 3D in vitro model which can be used to study these simple questions that I'm posing. What is the pH like? What biomarkers are present? Can we do it in real time? Can it be high throughput? Because if I'm doing a bacterial monitoring, I don't want one patient sample. I want maybe 380 samples done in 20 minutes, right? So it has to be high throughput. So here, small volumes, real-time monitoring, high throughput is one of those things that I want my solution to have. And what we did was come up with this microfluidic platform, and we wanted to make a tissue mimetic microfluidic platform. What I mean by that is the platform that we have, the 3D system that I'm trying to make, must mimic the tissue of interest, okay? So this is basically the tissue of interest initially for us was the tumor. And as I told you, we thought it's a simple system, not knowing the biology of it, naive chemist coming into this interface. And we thought, once I can do this, I can ask all these several interesting questions. For example, what is the growth rate? What affects the growth? What is the drug regime that should follow? It'll give personalized medicine. Everything is going to be solved, So very, very ambitious list. Of course, you can go to look up our papers on these topics, and we also have some patents, and I'm going to show you the technology. So, sorry. Okay, yeah, so basically what we thought was that simple. Everyone is growing these tumors in 3D. Can we just put a sensor? Remember the pH sensing that I talked about and the small organic molecules that everyone has been using to detect? We thought, can we use something like that? Instead of a small molecule, because small molecule, the pH changes that you see, or the fluorescence that you detect from small molecules is because of aggregation. Most of the time it is because of the aggregation. And that might not help, because if they start aggregating, the spectra will not be very clean, and there could be many reasons because of which you can see these aggregations. So we wanted to use nanoparticles to actually create nanoprobes to see this pH changes, So any nanoparticle which will fluoresce due to the pH changes is what we wanted to choose. And then you can encapsulate these nanoparticles in the local environment, let them do the job. So pH would be one, biomolecules, for example, you want to look at any enzyme, how are the enzymes being upregulated, anything. Now it just opens up the Pandora box. So before we do that, so here, in my solution that we proposed, what we had was we'll have to have a 3D environment, we'll have to develop a nanoparticle sensor, and then maybe do whatever we were planning to do, all the studies, right? So we wanted to study the tumor first, and we, as a polymer chemist, to me, tumor looked like a core shell structure. I thought that, it has a nice core, highly cross-linked core, and a very less cross-linked shell, So if I want to make a miniaturized tumor environment, it must have these core shell structures. And of course, then, there are a lot of other things that happen, and, we will take that up later on, initially when to start with. So that's exactly what we did. And let me just quickly tell you a little bit about the probes that we chose. So the nanosensor probe that we chose was, as I said, it was nanoparticle based, and we were intrigued by carbon dots. The reason why we liked carbon dots was because unlike other nanomaterials, for example, quantum dots, inorganic quantum dots, where you have the fluorescence emission is dependent on the size or the quantum confinement that you can achieve and the band gaps of the material that you're choosing, this carbon dots actually, the fluorescence emission was dependent on the functional groups or the surface functional groups that were present. For example, there was literature which suggested, of course, it's controversial with what is the real reason for this, but it was understood that they produced surface traps which changes the energy levels, and because of that, you see excitation dependent emission in the fluorescence. So you were able to, of course, here, because they are functional group dependent, we can dope it. We can add any molecule. For example, you can dope it with an amine and have more of NH2 groups. You can dope it with carboxyl containing functionalities. You can dope it with any inorganic materials and create whatever fluorescence regions you want. So we prepared these carbon dots, and we had two peaks here. One peak in the blue region, the other peak in the green region, and there was a reason for it because we wanted to have ratiometric. Remember the reason for aggregation in small molecules? We wanted to keep one peak which was independent of any pH changes, so that you can keep that as one of the marker or the reference. And internal reference, and then you can look at the other emission peak to identify what is happening in the environment. So as I said, these functional groups not only gives you advantage of tuning the emission properties, they also give you advantage of, because you can now have carboxyl groups and amines, which are pH sensitive. So they will give pH sensitivity to the whole nanoparticle. You can also use them for reading out with electrochemical readouts, fluorescence readouts, pH sensitivity, and you can use them because there's a redox reaction happening. You can easily read them out with an electrochemical, voltammetry and things like that, which will make your technique very, very rapid and precise, okay? So then that was the sensors. What do we do with the 3D platform? As a chemist, I like to control things at a molecular level. So what we wanted was, we wanted to create these microgels, which will be our miniaturized vials where the cells will be growing. And in those miniature vials, I should be able to control the porosity, the composition, the sizes, everything. And that's exactly what we did with the microfluidic system. So you can see here that controlling the flow rate controls the size, controls the cross-linking densities. You can control the beautiful pore sizes of it. What it means is that if you have a 10 micron or 100 micron bead, you will have 10 microbes maybe. If you have a 500, you can increase the volume, so on, right? That will, now consider this. You have maybe 2 bacteria growing in a small vial, right? Small vial of, let's say, 100 microns. Even if they double, they become 4, the pH is going to change dramatically. And because remember, the probes are next to them. So I'll be able to detect those pH changes very quickly, and I'll be able to detect them even by electrochemical sensing, right? So I will be able to detect all these things very, very quickly. So with this, so I'm just showing you that I have complete control over the cross-linking density and all that. I'm going to move on. So this is exactly what we did. So here we have the cells, we have the carbon dots, we have the monomers. Now, choose your composition, completely modular system. You put them through this microfluidic chamber. You create these beautiful beads. Of course, we used UV in the initial days. Now we have moved on to alginate, and there are many other techniques. It's nothing important. We can do that. And what you do is, at day 0, they are not fluorescent. At day 6, this is something which I forgot to mention. Here, we also wanted our carbon dots to be turned on kind of a system where once the pH changes, you should have bright green or bright fluorescence. The readout should be on a signal rather than an off signal, which is what is there for organic molecules. In organic molecules, you start seeing lowering of the emission. So after day 12, we start seeing these bright beads when the cells are growing. And this is basically to show you how sensitive our sensors are, pH 7.47 up to pH 5. This is, again, showing you can map the pH changes in the environment. And this is basically, here what we can do is, this gives us an opportunity to actually quantify the pH changes. Now what you could do is, you can look at how bright they are and you can plot it. And as a scientist, we love that. Quantification is wonderful. So now with this technology, we were able to create core shell. We were able to create hypoxia by changing the cross-linking density. You were able to monitor. And what we've done is, now use this to monitor the growth rate of multiple cells. So these experiments which were done by LMR assay or some other endpoint assays, we are doing it in real time, and we are looking at just simply by looking at the changes in the fluorescence ratio at blue and green, we are looking at the growth curves. You can break the cell, you can retrieve the cells and look at their genetic profile as well. Now, this has given us a platform to carry out some wonderful experiments, and now we are collaborating with AIMS in medical oncology, where we are looking at how does the expression of USP37, this is a very important protein, cytoplasmic protein, affects the cell proliferation. Nobody has been able to study this, with a real-time changes in the protein level. And what we have done is, this is samples, so showing clinical samples showing that USP37 is indeed important for cancer growth. And this is just to show you that even we've been able to monitor this over days, the growth rate over days, without killing the cells or endpoint assays. These are precious samples. So we've been able to actually identify the role of USP37, and this can be one of the targets for future cancer targets or metastatic studies and things like that. Now that we have this platform, if you have a very aggressive cell, what they will start doing is moving out. Remember the core shell structure I was talking about? Imagine the shell has a signal which the core cells like. They will start to migrate. Once they start to migrate, we thought that we will be able to track the trajectory of the cells. Instead, what happened was we saw that the migratory potential meant that the cells started to form organoids or small spheroids inside the whole microgel faster. That we thought was a readout for the migratory potential of these cells growing, Okay, so I'm going to skip that. So this is, again, we've done all these biological studies, look at the EMT markers which are responsible. So now we've started doing all the fundamental studies as well. We've started looking at the bacterial. So same with cancer cells, you can put bacteria here and now look at electrochemical readouts and see. And we've been collaborating with ILBS to actually look at these things in clinical samples. And we've been successful we've done 50 samples, and we were able to predict samples which were negative by the clinical tests, and we said that they have the bacteria. RT-PCR confirmed that they indeed had the bacteria. So we thought that our system is sensitive. We are still working on getting this technology in the next stages. So with that, I have shown you, bacterial, all of this. I'm going to skip all of that. Okay, so I would like to, we do there are a lot of other things that is happening in the lab. I'm not talking about it here, but a whole philosophy there as well is using chemistry to develop future materials, And I've been very lucky to have support from IT Delhi as my funding to start the lab. IYBA in the initial years helped, DST Nano Mission helped us set up the lab. DBT Nanobiotech has been funding us for quite some time now. Recently, I got Sir Power Fellowship, which is helping us fund our research. Janki Amal, and of course, I have a small lab. I have a lot of females whom I mentor, and that's all. Well, I had few slides about my views on gender sensitivity. If you allow me, I can just share that. So I always thought that science is gender neutral. As a kid, when someone would ask, can you tell me two scientists? I'm sure Einstein and Marie Curie will come to your mind, right? So I think science has been gender neutral for a child, whether it's in India or anywhere. We've had Indian women scientists as role models as well, and we've talked about them since morning, so I'm going to skip that. And let's look at the statistics here. The statistics is that in Southeast Asia, there are 42% women in the scientific workforce, not at the independent research level. When you look at independent research level, it's only 15%. So it's not that we do not have women in science or technology. They are there in the labs, working, not seeing in the front line or anywhere, right? So what is happening here? I'm sure you've heard of leaky pipeline. So what happens is that they choose to do work quietly, without getting disturbed by other factors, without getting, facing the real world and, seeing all the issues. They are working quietly there. What we need is basically mentors, which actually allows us and gives them confidence to come out and, explore the world and come in the front as well. And that's what happened with me, with my PhD advisor. He gave me one advice when I was graduating. He said that, Neetu, I'll be one person in your life who will always think about your career. Your parents will be biased. They will tell you about your personal life. They want you to be happy and they'll protect you. Your family, your husband, everyone is going to be biased. They're going to protect you. I don't care about your personal life. I'll always tell you what is good for you for your career. And I think it is a very important advice for me because you always need someone in your life who will tell you what is good for you professionally. It doesn't matter what you're going through personally. They will always think about your future in your profession. And you have the personal people, people telling you in your personal life as well. And you as an individual take those two information and curve your path, My advisor, postdoc advisor, Sangeeta, actually realized that I am losing out on the personal front. So she mentored me for my personal life a lot rather than my professional. So she was a great source. And she was the reason why I had my first child in my postdoc years. This was a very competitive postdoc at MIT. Right after 1 year of marriage, I had my first child. I did my postdoc for 3 years. I had 5 publications and a 2-year-old. So I don't know how I did it. It was only because of Sangeeta that I did it, And this is, so this is my small snippet of my journey. So I graduated in chemistry, went to US, and realized that I can break the barrier of disciplines, and I can move to biomedical engineering. Ended up doing a postdoc in 2008 at MIT. Had my first child in 2009, so you can see that, right after getting married. 2008 is when I got married, by the way. Had my first child. Joined NCL Pune together. Both of us had offers at different institutes, but we decided to join NCL Pune. My husband had at IIT Delhi, I had at IIT Kanpur. We left our IIT jobs and joined NCL because my postdoc advisor told me, Neetu, it's important to have starting, memories, starting your lab memories, and it is important to share that. I took that advice seriously and I joined NCL. And later on, I moved to IIT Delhi because I had gotten a job by that time in 2014. Right after joining, my probation and my second child were born at the same time. So I was confirmed, my job was confirmed after probation on April 15th, and my child was born on April 14th. So, right after joining, I had my second child. And then the journey continues, they're growing, and my lab is growing as well. I have graduated about 6 students now. I have completed 12 grants, 50 plus publications, and we filed 10 patents from India. So I'm very happy about, I'm very, very happy with this journey that I've taken. And I would like, I just want to tell everyone that just go for it. If you are in doubt, talk to your mentors, talk to your advisors, talk to anyone, just write to us and we'll help you out in that situation. I'm sure we all have gone through what you are going through at that time, so thank you so much. Yeah. I think we're doing the question section now. I'll just ask you. Okay.
So thanks so much for the wonderful, very infectious in energy talk. And I'm sure with all your trajectory you showed at the end, women should not complain. You have to make your life and you have to calibrate whatever is best for you, and still you can be extremely competitive and extremely productive. So congratulations again, and I would request if people have questions, then they can, yeah, there's a question in the front seat. So is there a mic? Can you?
I can take it.
Neetu, thank you. That was a very impressive study. So I just have a very brief question. So you, on the tumor, right? So you're breaking up the tumor into individual cells. And then you're pushing that through a compliance surface. So you break the tumor. Into individual cells. So an organoid single cells work differently. I've broken I've had sleepless nights just looking at how these work.
Absolutely, yeah.
And then you've put them through your gel, a compliance surface. So I have two questions here. Have you looked at what the compliance is? Because different tumors grow at different compliances and stiffnesses. So have you calibrated that?
So here, what we're doing is we're not taking the samples from the patient. We've not reached that level yet. What we're doing is we're using cells. We're not using primary cells. What I mean by that is we're using just cell lines and trying to grow the tumor, the tumoroid. So here it's a very simple model where we're just simply trying to look at the growth rate, because we thought that the pH is something that we can detect. I agree with you. We've not studied those things, but that will be a challenge because every tumor has a different environment that it likes to grow, and different, even mechanical properties of the material can affect the tumor growth. So those will be our challenges. We have not reached there yet. We're very, very simplistic model right now. But because, as I said, because we have control over the composition of the material, we can actually change, we can manipulate all of that.
Yeah, no, I completely understand. But then if you look at the tumor progression, the stiffness, so even in the body, from the first stage of cancer to the last, you have so much change.
And this was the reason why we wanted to develop the metastatic model, because one question that bothers me a lot is why does a breast cancer metastasize into bone? Initially it was thought that it goes to the brain, maybe the ECM elasticity is similar. And it crosses the blood-brain barrier and blah, blah, that's an argument, different argument. But then why does it metastasize to bone? Because then the stiffness of the ECM is completely different, right? So I don't know, maybe Mitali ma'am would have more answers to that. But that's something which has intrigued me quite a lot. And we wanted to study if we can change the stiffness and we can have some sense. So we can look at cell signaling, we can look at ECM signaling, we can look at all of this in our platform. And that is why I had broken them into a core shell, where the shell will provide all the external cues that we're seeing. But again, this is something which I'm envisioning will happen. I don't know. I'll have to do those studies. We are not there yet.
You probably also...
So, in the interest of time, could we have some other questions? And maybe you could continue it over lunch.
We can have it offline.
Yeah, sure. We can have one or two questions to both the speakers.
Hello, a very nice talk. One question I have about the carbon dots which you are using to monitor the pH change. So in the carbon dots, as you know, that size has a role to play onto the number of surface functionality, and you are exploring that to measure the pH change. So how you are ensuring that you have one size of the carbon dots and you measure the change out of the external environment, not because of the variation in the size of the nanoparticle itself?
So if you have a polydispersed sample, your emission spectra will tell you that. The peak of the emission spectra will clearly tell you whether you have different wavelengths and all that. So you have to monitor. So this particular synthesis that we're doing, we're using an electrochemical method to do that, and we get a very monodispersed sample. So that's something which we are avoiding here.
Okay, so by synthesis, you are controlling that.
We are controlling. Okay, absolutely.
So only two more questions, and rest can ask after and during the lunch hour. Dr. Ravi, you can have a question. And
hi, thank you. That was a wonderful presentation and also an inspiring journey too. So my question is, have you looked at any other nanomaterials other than carbon dots, like say, for example, nanoclusters?
Yeah, that's a good suggestion. We have not. So as you can see, we've invested. This is work of 4 of my PhD students, So our journey has been only since 2008 years old, right?
Yeah.
So we've not moved on to new materials yet. We're just trying to focus on one and then take it to the next level. Probably I would like to see this as a device for at least bacterial testing, and that's where I'm putting all my energy on. But that's a good suggestion. Anything. So we have moved on to a different biomarker. We've moved on to MMPs now instead of pH. That's something which we are working right now, and maybe in a couple of years we'll have something on that.
Okay, and just a follow-up question. Are you also looking at, I mean, right now the carbon dots, the downside is that they're activatable with UV light, right?
Yeah.
So maybe it would be better if you can have some nanomaterial which can be activated by infrared lights.
Sorry, I'm sorry, I'm interfering you, but the reason why I chose this UV is exactly because
the backtech. The machine is already there.
Okay.
So the technology is all, I don't have to work on, the readout process then. So that is why we chose that fluorescence and the green region that they are using. So, and as I said, we are very focused on bringing it to the next level. So we are not going to change the material. It took us a long time to develop this material. So we are going to focus on it. But those are good suggestions. We will look into that.
Thank you.
Yeah.
So I think
I have a question.
One pressing question, okay? We will take that. That's the last question. And after that, you can catch them.
Ma'am, I have a question that how do you culture those micro encapsulated cell? Where? I just want to know because earlier you have stated that during culturing media and it buffer also
Yeah, so we
has
don't
a
have any buffer. In fact, our initial experiments were done in oil, so we just encapsulated them and the media was present only because we wanted to create a closed system similar to backtech, So the beads would have the media, but then we would put these beads in a hydrophobic environment so that, they don't come out or anything, they don't leach out. So that was our early days experiment. Now we've moved on to small vials and we have it in media, but we don't put any buffer or anything in that.
But for a longer time period, how
Because
do
we can detect bacteria in about 2 hours.
Okay, but for cancer cell lines,
So
if I'm
for
not
cancer
wrong,
cell lines-
adherence is quite important.
Yeah,
for
so
the-
we've done experiments till about 12 days, 14 days, and they seem to be fine right now. But I agree with you, those, because the genetic profile might change. We've not looked at those.
And I have second question.
Can
During the
microencapsulation, can we have the question later? You can catch her at a later. I think she's here for today and tomorrow.
So all the carbon dot related questions, can I take it during lunch? I can have, if there are any other questions which is not related to carbon dots, you can ask.
Like inside the cell there is a pH. So how to calculate the pH change in time?
So one of my slides was intracellular pH. I skipped over it, where I mapped the intracellular pH also. So I can talk to you about it. Yeah.
Okay, thank you. I will. I think it was a very popular series of lectures, and it's very heartening also for so many people to ask questions, which has become a rarity. And I think I'll hand it over to the organizer.
Thank you. That was a wonderful theme. We will now proceed towards felicitation of our presenters and chairperson. May I request Professor Mitali Mukherjee to felicitate our first presenter of the day, Professor Ruchi Anand from IIT Bombay. Professor Ruchi Anand. Please have a round of applause for her. I now request Professor Mitali Mukherjee to felicitate our second presenter, Dr. Neeta Singh, IIT Delhi. Everyone, Dr. Neeta Singh from IIT Delhi. We thank our presenters and chairperson for theme 1. I also request convener of the conference, Dr. Ritu Gupta, to felicitate the chairperson of theme 1, Professor Mitali Mukherjee. Thank you. Moving on. We'll have our theme 2 for the day, Sustainable Chemical Synthesis. This theme would be chaired by Dr. Bani Mahanti, Assistant Professor of Banaras Hindu University. Dr. Mahanti has received her PhD degree from IIT Kanpur in 2014 under the supervision of Professor V. Chandrasekhar. Subsequently, she has worked as a postdoctoral associate at Uppsala University, Sweden, and University of Massachusetts, Boston. She is working as an assistant professor in the chemistry section of Mahila Mahavidyalaya, Banaras Hindu University, Varanasi. Her research interests are in the area of transition metal complexes for OLED and sensor applications, water oxidation studies related to artificial photosynthesis and coordination chemistry. I request Dr. Vani Mohanty to chair the second session on sustainable chemical synthesis.
Thank you for your words of introduction. Good afternoon, all of you, and welcome to another session. So we have two talks in this session, each for 20 minutes, followed by a discussion of 5 minutes. It is my pleasure to introduce our first speaker, Dr. Namrata Rastogi. Dr. Namrata Rastogi received her PhD from IIT Bombay in 2006. Subsequently, she worked as postdoctoral research associate from 2006 to 9 at University of Minnesota, Minneapolis, USA. She then served as senior research scientist in Jubilant Biosys Drug Discovery and Development at Bengaluru for 2 years before joining CSIR Central Drug Research Institute, Lucknow in 2011. Her research interests include exploring novel visible light photoredox catalyzed organic transformations, especially under organophotoredox catalyzed conditions. Her research group is also involved in the CSIR CDRI's drug discovery program in the area of parasitic diseases, developing small molecules against leishmania and malarial parasites particularly. I would also like to add that Dr. Rastogi is a recipient of Indian Society of Chemists and Biologists Distinguished Women Scientist Award 2019 in the area of chemical science and Chemical Research Society of India CRSI Bronze Medal for the year 2022. Today, she will be enlightening us on the topic Sustainable Visible Light Photoredox Chemistry. Over to you, ma'am.
Thanks, Vani, for the introduction. And it's a pleasure to be participate in this meeting, which is especially for women scientists. And it's so good to see, a lot of young female students in the conference. So today I'll be discussing sustainable visible light photoredox chemistry, some of the selected work from our group. When you talk of sustainable chemical synthesis, the term sustainability and chemical synthesis, it's very difficult to match these two because you are using chemicals and you have to use sustainable processes. So right from controlling atom economy or designing safer chemicals or preventing waste generation, the most important thing is to have safer chemicals, safer catalyst, or safer processes. What could be better than nature? The most sustainable and efficient and atom economical and the best reaction is photosynthesis. And scientists have long desired to mimic photosynthesis. Scientists have long been, desired to mimic photosynthesis. Because in photosynthesis, only water and carbon dioxide is used in presence of light energy, sun energy. Complex organic molecules are synthesized. So the idea to use visible light or sunlight for catalyzing or for mediating chemical reactions for synthesis of complex organic molecules is more than a century old. However, this idea of using sunlight or visible light of electromagnetic spectrum did not take off well until almost 2007, 2008, because most of the organic molecules do not absorb in the visible light region. But with the advent of, or with the realization that organometallic complexes of few metals, especially ruthenium and iridium, can absorb sunlight or visible light and then can transfer this light to normal organic molecules to activate them. So after in last 10 to 15 years, this field took off really well, and there's been progress in terms of new substrate design, new catalyst design, or newer reactions. So when we started this working in this field in around 2016, our first choice was ruthenium and iridium photocatalyst. So we developed several reactions in this one. We developed several reactions around the chemistry of ruthenium and iridium-based photocatalysts. For example, the first reaction which we developed was generation of aryl radical from diazonium salts and synthesis of methyl sulfoxides, aryl methyl sulfoxides from them, where we use DMSO, common DMSO solvent, as the source of methyl sulfoxide radical. This is a simple method for direct conversion of aryl amines to aryl methyl sulfoxides. Similarly, the same catalyst, ruthenium-based catalysts, were used for generation of nitrogen-centered radical using Bailey-Silman products for the synthesis of functionalized quinolines. We further used iridium-based catalyst for the synthesis of fluoroalkylated indinone molecules. The same iridium-based catalysts were further used for the generation of alpha ketovinyl radicals, and these alpha ketovinyl radicals were used in several reactions for intermolecular trapping with other chalcone molecules. We were able to synthesize urindavine chalcone moiety, and we synthesized urindavine B molecule. These urindavine A, B, C are a family of urindavines. Is a rare species, rare plant product, which is found in a Brazilian shrub. The same alpha ketovinyl radical, when trapped intramolecularly, produce these phenanthrene molecules. So we were quite successful, I would say, using these ruthenium and iridium chemistry. But at the same time, we realized that when we are using visible light, the whole purpose of shifting your focus from traditional radical chemistry, traditional organic chemistry, to using visible light for mediating the reaction is to increase sustainability in the reaction. And that aim is defeated or compromised if you're using iridium or ruthenium based catalyst, because these are one of the, among most rare earth metals. For example, the overall production of iridium worldwide annually is less than 3 tons only. So your idea of using visible light to increase sustainability in the reaction is compromised, on the other hand, if you're using iridium or ruthenium as catalyst. So our second choice for the photocatalysts were other commonly used photocatalysts at that time were organic dyes. So we used so this next reaction where we used organic dye rose Bengal, which can be activated under green light irradiation for the alpha oxidative functionalization of tertiary amines, where we use diazoenolates for functionalization of alpha diazoalkylation of tertiary amines. In this case, if you see, the rose Bengal is only mildly reducing as well as mildly oxidizing photocatalyst. So rose Bengal undergoes reductive quenching upon photoexcitation. The excited rose Bengal molecule undergoes single electron reduction by transfer of a single electron from this tertiary amine. In turn, this tertiary amine forms iminium ion intermediate, which was then nucleophilically attacked by diazoenolate molecules, and this alpha diazoalkyl functionalized tertiary amines were synthesized. We further use these functionalized tertiary amines for rhodium carbenoid mediated stable halide synthesis. We could shift from ruthenium or iridium based photocatalyst to organic dyes, but at this point of time we realized that the range of redox potentials offered by these commonly used organic dyes like rose Bengal or eosin Y is very narrow. You cannot, it is difficult to design many significant reaction within this range of redox potentials. So our literature says reveal a lot of common organic molecules can also be used as photocatalysts, which are photoactive molecules. And then we zeroed upon two molecules here lying at the extreme end of redox potentials. One is highly oxidizing methyl acridinium salts or Fukushima catalyst, and another was simple dialkyl dihydropyridinium dicarboxylates, commonly known as Hans ester, which are strongly reducing molecules. So we initiated our chemistry first with these two strongly reducing as well as strongly oxidizing photocatalysts. The first reaction where we used Hans ester as photocatalyst was for organophotocatalytic. Now these reactions can be termed as organophotocatalytic because the photocatalyst which we are using is a simple organic molecule. So this organophotocatalytic benzynylation of diazo compounds where we used Hans ester as as photocatalyst. The single electron reduction of diazo keto compounds followed by nitrogen extrusion is a difficult process, and it does require a very strongly electron giving substrate, very strongly reducing agent, reducing photocatalyst. And this reduction of diazo keto compounds is known with FAC iridium only. Because if you look at the highly negative redox potential of diazo keto carboxylate or diazo keto phosphonate, it is apparent that you need a highly reducing photocatalyst. Now, at this point, when we studied the properties of Hans ester, this is a unique molecule in terms that most often it is used as terminal reductant because it can donate H radical also. It can also donate a single electron, it can donate hydrogen atom, that is H radical, and it can also donate an alkyl functional group also. So we thought that is it possible that without using any photocatalyst in the reaction, can we use Hans ester only for single electron reduction of diazo keto compounds? If you look at the redox potential value, minus 2.28 volts versus standard calomel electrode of Hans ester and these substrates, thermodynamic feasibility, it looks like the reaction, the single electron transfer from Hans ester to diazo keto compound should be thermodynamically feasible. When we tried this reaction, we could generate this vinyl radical in presence of Hans ester. We could generate this vinyl radical not only from diazo keto carboxylates, we could also use diazo keto phosphonates, diazo keto sulfones, and so on. And this radical was further trapped with the triply bonded system, terminal as well as internal alkynes for the synthesis of hydroxy naphthols as well as hydroxyphenanthrenes. This reaction beautifully uses the properties, the single electron transfer properties of Hans ester and hydrogen atom transfer properties of Hans ester sequentially. So first, this photoexcited Hans ester transfers one electron, photoinduced electron transfer to the diazoenolate molecule, which eliminates nitrogen molecule for the generation of this vinyl radical. This vinyl radical is trapped by a triple bonded system for the generation of this benzylic radical. Now this benzylic radical upon intramolecular cyclization gives radical E. Now at this point, this oxidized Hans ester, that is Hans ester radical cation, transfers one hydrogen atom, and one hydrogen radical elimination from intermediate E leads to the formation of enolated product, which upon workup gives this final product. This reaction, the mechanism was proved by several other control reactions because the other possibilities this reaction could go through energy transfer mechanism or through electron donor acceptor complex mechanism was ruled out by recording the UV visible absorption spectrum of Hans ester with diazo keto phosphonates, where there was no red shift or bathochromic shift of Hans ester was noted. So this experiment could rule out the formation of electron donor acceptor complex between Hans ester and the substrate. So now the problem is not yet solved because generation of vinyl radical from diazo keto compound using Hans ester was done. So only thermodynamic feasibility of matching or compatible redox potential is not the only factor. What other factor comes in is, like, for example, when we try to trap this vinyl radical generated from diazo keto phosphonate or other diazo keto compounds under Hans ester mediated condition with other radical trapping agent, that is orthoaryl vinyl azide, this reaction gave only 18% yield, and most of the time, most of the yield, we got most of the product as this de-diazotized product because Hans ester transfers one hydrogen atom to quench this radical. So So this radical was quenched and the final anticipated product was formed in 18% yield. However, this reaction works well with FAC iridium. So we concluded that hydrogen atom transfer in this case is a problem, not a supporting factor. So at that point, we came up with another very interesting organic dye, rhodamine 6G. Now rhodamine 6G is a simple organic dye, and the interesting property is that rhodamine 6G absorbs in green as well as blue light, but the photoexcited rhodamine 6G is only mildly reducing with minus 0.8 volts redox potential. However, in presence of a base, rhodamine 6G radical anion is generated. It absorbs only slightly in green light, and its redox potential does not change much. But when it is irradiated, rhodamine 6G in presence of a base, when it is irradiated with blue light, it becomes highly reducing with redox potential going up to minus 2.4 volts. This property of rhodamine 6G is called consecutive photoelectron transfer property, or CONPET mechanism. This CONPET mechanism was beautifully shown in our experiment where we used rhodamine 6G without any base in our reaction. Yield with green as well as blue LED radiation was only 38-39%. When we took a base diisopropylethylamine in the reaction, the rhodamine 6G radical anion generated did not absorb strongly in green light, and again it's not highly reducing, so yield was only 34%. But in presence of base rhodamine 6G under blue light irradiation, it became highly reducing, minus 2.4 volts, and the vinyl radical was generated successfully, so yield went up to 68%. Further optimization revealed that triethylamine is a better base than diisopropylethylamine in this reaction. Mechanistically, when we performed fluorescence quenching experiment of rhodamine 6G, it appeared that tetrabutyl ammonium bromide, which we use for diazoenolate formation, is the major quencher of rhodamine 6G fluorescence, and triethylamine did not quench rhodamine 6G's fluorescence particularly. However, with increasing amount of triethylamine with the concentration more than 6 micromolar of triethylamine, rhodamine 6G fluorescence was quenched very strongly. This proved the interaction between triethylamine and rhodamine 6G, generation of rhodamine 6G radical anion in the reaction. So on that basis, this mechanism was proposed, where rhodamine 6G, when excited by blue LED, forms rhodamine 6G, photoexcited rhodamine 6G undergoes single electron reduction by a electron transfer from triethylamine, and rhodamine 6G radical anion then transfers one electron to the diazoenolate, which upon nitrogen extrusion forms this vinylic radical. Vinylic radical, when trapped by this this vinyl azide, followed by nitrogen extrusion, forms this iminyl radical. Now this iminyl radical undergoes intramolecular cyclization, and the radical E, upon oxidation by this oxidized triethylamine, forms the final product upon workup. So far, I discussed only strongly photo-reducing photocatalysts like hand ester and rhodamine 6G. Another set of reactions which we performed with highly oxidizing catalyst, that is Fukushima catalyst, was denitrative 3+2 cycloaddition of 2H azirenes with nitroalkenes. It is known that this Fukushima catalyst undergoes single electron oxidation with these 2H azirenes, and these azirenes undergo carbon-carbon bond homolysis for the formation of aza-alanyl radical cation. Now we trap these aza-alanyl radical cations with nitroalkenes. Because of strongly electron withdrawing nature of nitro group, this aza-alanyl radical adds on to nitroalkene in a Michael fashion, and this ortho-nitro radical is generated. Now this zwitterionic species C undergoes reduction by already reduced photocatalyst, Fukushima photocatalyst. So this this catalytic cycle is completed, and zwitterion D is formed, which upon cyclization followed by DBU mediated denitration forms tri-substituted pyrols. Now this reaction was successfully extended to the synthesis of tetra-substituted pyrols functionalized with different R groups by taking ortho-substituted nitroalkenes, which these ortho-substituted nitroalkenes were synthesized by Baylis-Hillman or Raut-Curie reaction. And by using these alpha-substituted nitroalkenes, we could prepare hydroxy or ketone, this hydroxy function, ketone function or carboxylate function containing tetra-substituted pyrols. In case where we took bromine X as the R group, reaction goes through dehalogenative mechanism rather than denitration, and we could also install nitro group in the pyrrole molecule. During the optimization of this reaction, when we were trying to optimize the catalyst used in the reaction, instead of highly oxidizing Fukushima catalyst, we took another even more strongly oxidizing catalyst, that is triphenyl pyrrolium salt. The redox potential is more positive than the Fukushima catalyst. Interestingly, in this case, only catalyst was changed, and it is again the thermodynamic feasibility is compatible enough. Of electron transfer is compatible, but we got this desired product only in traces. So while optimizing, when we increase the amount of triphenyl pyrrolium salt to almost 0.5 equivalents, another product was isolated, which was formed as a result of 3+2 cycloaddition between catalyst itself, which was not catalyst anymore. It was taken in 0.5 equivalent, a stoichiometric amount. So it formed as a 3+2 cycloaddition between 2H azarine with triaryl pyrrolium salt. A quick fluorescence quenching experiment revealed that the fluorescence of pyrrolium salt, which are very highly active photoactive molecules, the fluorescence intensity of this triaryl pyrrolium salt is moderately quenched, like 44-45%, moderately quenched by the substrate 2H azarines. So on that basis, we proposed a mechanism where this pyrrolium salt act as substrate as well as photocatalyst. So what happens is this photo-excited triphenyl pyrrolium salt are reduced by a single electron transfer from 2H azarines. So on one hand, this upon carbon-carbon bond homolysis, azalenile radical cation is generated, and on the other side, tripyranyl radical is generated. So this tripyranyl radical and azalenile radical undergoes this radical-radical coupling, and this azalenile cation C is formed, which upon intramolecular 1,5 cyclization followed by deprotonation and tautomerism leads to the formation of final product. So this is so far only example where a photocatalyst itself has been used as a substrate. I will summarize now my talk. So in this talk, I discussed few selected examples of organophotocatalytic reactions carried out in our lab, where we used the Hans ester or rhodamine 6G as single electron reductant molecule for generation of vinyl radical from diazo compound, and this vinyl radical was trapped by different systems for the generation of naphthols or this phenanthridine molecules. As example of single electron oxidants, we use Fukushima catalyst as well as triaryl pyrrolium salts for the generation of azalenile radical cation intermediates from 2H azarine system. In this case, this pyrrolium salt act as catalyst as well as substrates. This chemistry of photoredox chemistry was initiated by my first student in 2016, and I'm thankful to other students also who took up this chemistry. This was very challenging, given that we started this, and it was difficult to manage with calculations, photophysical calculation and all. For that, I'm thankful to my collaborators, Dr. Vijay Lakshmi from Thapar Institute, Patiala, Dr. Ruchi Gupta from IIT Gandhinagar, Dr. Saptarshi Mukherjee from IISER Bhopal. And I cannot be thankful enough to the funding agencies. First and foremost, my parent organization, CSIR, CDRI, and DST SIR, which has supported this photoredox catalysis work in our group by 2 core grants so far. And thank you so much for listening to my talk patiently.
I request the audience to limit your questions to maximum 2. We can have discussion later on during lunch also. So yeah, any more questions?
Hello, very nice talk. So I have a general question from the introduction part of your talk. So you talked about these rare earth metal or organometallic complexes, which are used also as photocatalyst. So my question is, what is the potential of using earth abundant metals for this particular purpose? I mean, apart from organophotocatalyst, like because earth abundant metals also, they can do 1 electron redox process, right?
I'm sorry, what is the?
No, my question is regarding this organometallic photocatalyst. For example, this ruthenium and iridium, they are well explored, right? So to attain more sustainability, let's say if you'd like to use earth abundant metal based organometallic photocatalyst. So what is your thought regarding this?
Well, inorganic photocatalysis is actually older or more used inorganic
Yes.
photocatalysts like zinc or cadmium based. But again, the problem of generating waste material, metal based waste material is a reality. So because on laboratory scale you may not realize, but when you go on industrial scale, that is not very sustainable.
Okay.
Right?
Yeah. Thank you.
Because zinc or cadmium are used as inorganic photocatalysts.
Yeah, because if you talk about thermal catalysis, now a lot of attraction has been given to the base metals.
Right.
So that's
Zinc,
what I was
cadmium,
wondering.
titanium, these are all used.
Okay, thank you.
Hello, ma'am. Ma'am, my question is, please go to the slide number 5.
Yeah.
Yes, ma'am. So, ma'am, here in the mechanism step, the oxygen is get oxidized in the
Yes.
last step. So, what is the source of oxygen? You are using.
We did this reaction in open air. You can see the conditions.
Yes. Ma'am, actually, I am working also this photoredox country. So open air means, ma'am, you are just open the. How can you?
We did not use oxygen balloon or anything. It is just open air atmosphere. Okay. Do not use nitrogen. Keep the vessel open. Okay.
Ma'am, if you are keep the vessel open, when you irradiate light,
Yes.
then the solvent evaporation also taking place.
We have methanol. Reaction gets over in at the max 12 hours, so it does not evaporate. You can, lightly cover it, lightly. I mean, just to, if you are using DCM or something. Okay. Then maybe you can just pass air.
Okay.
Just maintain a positive pressure of air if you are using low boiling solvents. But we had methanol, so this solvent evaporation was not an issue.
Another question. Basically, when we irradiate light, the reaction vessels getting heated mostly.
Okay.
So when we tried the reactions like DCM, the boiling point of DCM is around 45 degrees.
Sorry, I should have shown the reaction vessel which we used. This is like a vessel which has an inlet, water inlet and water outlet, which we got manufactured. Okay. Got a prototype from Germany and then got it made here locally in India. So it has a water inlet and water outlet. So you constantly run water. Your question is correct. For longer running reaction vessel get heated. So we maintain room temperature by circulating water.
And ma'am, this type of diazo type of compound, when you, so what type of light you are basically using? Means light means this yellow, green light you are using. So what is the watt? Means.
Yeah, what's your question? Green light we are using for this reaction. In other diazo benzanylation conditions for vinyl radical generation, we use blue light.
Blue light, I understand. Means, ma'am, we are basically using the Kessil light. So Kessil light is around 40 watt.
Okay.
So when you irradiate this diazo guns, means this N2 guns.
But Kessil light, you cannot control wavelength.
So what type of light you are using? That's
we have LEDs.
LED, Kessil LED we are using.
In Kessil LED, I mean, you have to see what is the wavelength, right? Ours is blue light is 544 nm, and for green light is 505 nm.
Can you tell the particular watt? Means this 2 watt, 5 watt, or 10 watt?
Sorry to interrupt you, but please, you can have this discussion during lunch hour. I'm extremely sorry to interrupt.
You can discuss. I can give you the.
Okay, I have few questions also, so I.
Sure.
Thank you, Dr. Rastogi, for your wonderful talk. So our next speaker for this session is Dr. Shabana Khan. Dr. Shabana Khan obtained her PhD program from IIT Delhi in 2008. Subsequently, she joined the research group of Professor Herbert Royski as a postdoctoral fellow, followed by a second postdoc with Dr. Manuel Alcarazzo at the Max Planck Institute for Cold Research. She joined IISER Pune as an assistant professor in 2013. Currently, she is working as an associate professor in the same institute in the Department of Chemistry. Her research interest includes the synthesis and applications of compounds with low-valent elements in catalysis. Today, she will be sensitizing us on the topic ligand effects in homogeneous catalysis. Over to you, ma'am.
So, yeah, thank you, Dr. Bani, for the nice words. And thank you all. And more importantly, I would like to thank organizers to give me this opportunity that I am able to share my research work with all of you. And actually, it's a very nice experience for me, seeing so many young people and the leading ladies of academia. So I'm privileged to be here and presenting my talk on the topic effect of ligand in homogeneous catalysis. So I am basically working on the organometallic chemistry and catalysis, and the core of my research is the silicon chemistry, the silicon 2 compounds and their utilization as a ligand in catalysis and as well as in some of the photophysical properties. But today I am going to talk about more their importance as a ligand in catalysis. Speaking. So before I start my work, I would like to give a brief introduction about what these silicon 2 compounds are and why they are called low-valent compound. Because if you look the N-heterocyclic carbene, which is a very well-known ligand system nowadays and have got popularity a lot in different fields of chemistry and materials, they have a divalent compound having a 6 electron and a vacant p orbital, which makes them amphiphilic in nature, and presence of an electron pair that makes them ideal as a donor ligand. And they are a very good sigma donor ligand and can coordinate to the metal strongly to provide it stability. At the same time, the carbene can be tuned for its electronic as well as stellic properties by tuning the R ligand. You can see in the nitrogen. Can I have a pointer, please? Okay, so the idea is that if you use a low-valent compound, they are actually extremely reactive because this octet is not complete, and at the same time, they are quite efficient in doing the reaction with anything, whatever is present in the close vicinity. So therefore, the 2 protocol, which is very important for the stabilization of them, is the kinetic stabilization as well as the electronic stabilization. So kinetic stabilization is usually being provided by the group which is attached on the nitrogen you see. So usually they are bulky groups. Yeah, thank you. And the sterics, that's what the steric protection from the group which is attached on the nitrogen, which gives the kinetic protection, means it covers it to react it further with the any incoming substrate. And the same time, the 6 electron, which makes it electrophilic in nature, that is being quenched by the nitrogen, which gives us the electronic support. So altogether, these 2 properties make them stable, and which was isolated in under normal condition in 1991 by Ardungo. So if you look at the group 14, going from carbon to silicon to lead, so carbon is the first element of the series and quite abundant in nature. We have a lot of carbon-containing compounds in the natural occurrence. However, if you go to silicon, this is also very much abundant, but the silicon 2 compounds are not as explored as carbenes are. So our main intention lies in the exploration of silicon 2 compound as a ligand in the catalysis. So therefore, we were more keen to use them as a ligand. And first, we tried to understand how it is going to be bonding with the transition metal. So our major interest was lying in the coinage metals especially. So before I begin with the work, I would say the most famous example of the carbene, which was actually came to the picture in 1999. So this is the first landmark application of the N-heterocyclic carbene, which is an olefin metathesis, the Gruff's first generation catalyst. There the ligand was tricyclohexyl phosphine. And in 1999, the second generation, where the one of the phosphine ligand was replaced by the saturated carbene, an heterocyclic carbene. And this catalyst was proven to be more efficient, more stable, and that actually opened the domain for the N-heterocyclic carbene as a ligand. And then now you see that they have a lot of application in different fields. And then we thought, can the silylene be used in the same way as the carbene is being utilized as a ligand in different fields? So we picked up a silylene system, which is having a base stabilized silylene, the silicon in the oxidation state 2 with the base pair electron. And we first tried to see how they are going to behave with the transition metal if we coordinate them with them. So initially, we just utilized the commercially available ligand system like gold chloride salt, silver nitrate, copper iodide, silver triplet. They are very much available. So we just tried the coordination reaction and isolated the first initial compounds to understand the bonding. And we found when the silicon is coordinated to the gold, silver, and copper, they are making a very stable compounds, and they can be actually handled in the air also, which is a very much problem when you are dealing with the low valent compounds. So all of them were well understood by using the single crystal X-ray diffraction studies. We had information about the bonding and all other parameters. So therefore, we next thought, let's move for the catalysis. Usually, you will see in the catalysis, mostly the coinage metals are having the halide attached to it, and you generate them in situ as a cation, which is actually the active species when it comes to the catalysis, because any unsaturated substrate which is coming in is going to coordinate with the cation. And it is very obvious because this the alkyne or alkene bond has an affinity for the cations. So therefore, the bonding and the back bonding determines the cleavage of the bond and the efficiency of the catalysis. So hence our idea was that use the silylene, generate the cation with a weak interaction, and use them as a well-established catalytic system in the catalysis. And when we looked in the literature, we found that is one report of copper complex having a eta-6 interaction. So then question comes, why eta-6 is very important? So if you look at the 3D series going from from your iron, cobalt to the copper being D10 system, there was no occurrence only other than this report where the eta-6 coordination was observed for the copper, because there is an inherent repulsion of the arene system as well as the copper, because it's a D8 system. So they have a strong repulsion when they come for the eta-6 coordination mode. So hence, this is the only available example. If you look at the structure, this is even not benzene, it's an hexamethyl benzene, and this was isolated with the aid of steric of the phosphine group. So in the same paper, they mentioned that if they try to theoretically, of course, they could not isolate the experimental data for that compound, that if they are trying to calculate it by replacing the hexamethyl benzene with the benzene, that compound is getting in the condensed phase for the eta-2 coordination. So that left with the question, can we isolate the eta-6 with the copper D10 system? So we thought, because silylene is a very strong ligand system, I mean, in terms of the donation, and the steric crowding is also there, so we can give a shot. So we prepared the copper bromide in the initial attempts, and then we utilized it with the silver hexafluoroantimonate to abstract the halide, and we used the arene system in situ to have a weaker support during the reaction. And we isolated both the compounds with the hexamethyl benzene and the benzene, and both the compounds were characterized by the single crystal X-ray diffraction studies. And the X-ray structure showed that in both the cases, hexamethyl benzene and benzene, the coordination mode is eta-6. And that was a surprising thing, because there was no report other than this where the benzene was coordinated to the copper in the eta-6 system. And the conclusion was, what we drawn from here, that because silicon-copper bond is little elongated, and that is giving the breathing space to accommodate the eta-6 coordination to the system, and that is how it is being stabilized. So since both the systems were symmetrical in nature, we thought to go further with the unsymmetrical systems like toluene, mesitylene, and see that how they are going to be make the bond with the arene here. So then we prepared all these compounds with the silylene and also with the N-heterocyclic carbene. Because being the lighter congener of the silylene, the carbene has their own set of properties. So it is always a good idea to compare the ligand system if you want to have your own set of catalytic application or the complexes you are aiming for. So then, so we figured out here in all the cases, there is no eta-6 coordination mode, both of them having a eta-3 and eta-2 hapticity in these cases. And the reason is obvious because there is an unsymmetrical distribution of the R group, therefore the repulsion is uneven and it is not going for the eta-6 coordination. So with these compounds in hand, having a cationic nature of the copper as well as a weakly coordinating arene here, we further went for the catalysis. So the first catalysis reaction was picked up was the CAC reaction because it's a very famous reaction by the copper. And we performed the reaction with N-heterocyclic carbene supported copper cation as well as the N-heterocyclic silylene supported copper cation. And if you look at the data, the carbene supported copper cation did not perform well. However, silylene performed very well. And then we, as a proof of the concept, we performed some reaction and we proved that this silylene system is working better in this catalytic framework and the yields are quite good in this case. So with this information in hand, we further extended our work to the gold because gold as a catalyst is very, very popular because of its alkynophilicity and it's a very good catalyst in the CC coupling. So with the same method, we isolated the gold arene complex supported by the silylene system. Method was same. We used the silver hexafluoro antimonate and then with the carbene also with the same methodology, we obtained the compound in both the cases. However, in this case, the hapticity was eta-1 and eta-2 because of the relativistic effect. They don't go for the eta-6. And these were well characterized. So it's important to mention here that gold catalysis is mainly, they use ligand, gold halide or OTF, and they generate the in situ gold cation. There are very less examples where the catalysts are actually well understood beforehand and have a clear-cut structure and idea about the bonding. So since we had this catalyst in hand with structurally characterized, we thought to perform the reaction. So since I am not from the catalysis, I figured out in my department, my colleague, Professor Srinivas Hota, he does a disaccharide synthesis. And they use this phosphorus-based ligand system. So we picked up this reaction as a model one, and we utilized our catalyst to probe this reaction. And if you look at this table, this is a disaccharide synthesis, you will see this is a silylene data. This is germylene, which is an analog of silylene. This is carbene, and this is phosphide, what they have used. So if you compare the data, you will see the silylene-based system is performing poor. And that was the surprise for us because I always assume the silylene is a very good donor, so it should perform good. The point I missed here that this system is actually electronically poor system because it's a phosphide, it's not electron-rich ligand system. And therefore, this performed badly in this catalytic framework. So with this information, we further went to understand the mechanism because we always need to understand what is happening in the reaction. So this is actually a very big catalytic cycle. So just I will give you the brief about it, that this mechanism actually what is done by my collaborator, Dr. Patil, that showed in the case of NHC, because there is a less donation, the back bonding from the arene is actually very strong. And I mean, arene means the alkyne which is coming, and that the bond activation is much more faster than the silylene. And when comes the theory data, there is always a good idea to support it with the experimental data. And there are plenty of methods in organometallic chemistry to find out the sigma donation of the ligand system. And one of the very popular, I think we study in our undergrads and graduates is that the Tolman electronic parameter. Since the nickel tetracarbonyl is extremely poisonous, it's banned. So we figured out if we use the cobalt CpCO2 complex, that is also going to serve the purpose, though we cannot have the parameter, just we can have an estimation of the donor properties. So anyway, that was good enough to understand the donor, at least the sequence. So we prepared the silylene supported cobalt complex. This NHC supported cobalt complex was already reported by Bayard and co-workers. And then we prepared the phosphide-based ligand system and we compared the IR stretching frequencies. And with this frequency, we figured out, as per this data, the silylene is actually better donor than the NHC, and NHC is better than phosphide. So basically, that was an experimental proof, the first time that this silylene is a strong donor than N-heterocyclic carbene. And that is the reason we could not get a selectivity in this case. But the thing is that we learned a lot during this process because there is a paper by Bozu. In this paper, he actually beautifully documented the gold-1 catalyzed reactions. And he mentioned step by step that first reaction is the generation of gold cation, then the coordination of the alkene, then followed by protodeoration, then again you have a formation of the gold cation as a catalyst regeneration, and at the end there is a decay of the catalyst, which is inherent in all the gold catalyzed reaction. And the end product is your metal, the gold, as a deposition is a 0, and then the di-coordinate gold system. And in the same paper, they also mentioned that eta-2 interaction, if there, it actually reduces the decay of the catalyst. And this is all observation we made during our studies. And we found this is a one experimental proof. When you do reaction in absence of arene system, your yield is comparatively less than the reaction which is being done in the benzene. So that was the experimental proof that this is, if you have a weaker coordination from the arene system, that actually enhances the lifetime of the catalyst. Okay, so then after that, we further extended it to the silver catalysis, though silver is not very popular when it comes to the catalysis, but then there are a couple of reactions which can be utilized to understand the ligand effect. And in a similar line, we prepared the low coordinate silylene supported silver cation with the same methodology, but then the abstractor was different because the silver will not work here, so we use the alkali metal here. And all these three complexes with this different arene like benzene, hexamethylbenzene, and the toluene, we isolated and characterized structurally. And then further, we proceeded for the catalytic reaction. So this is just a model reaction. We actually did a lot of optimization and screening. And if you look, we have compared it with the literature available report, and we found our catalyst is actually working very well. So the turnover frequency was quite higher than the reported catalyst in the literature. So that was the another understanding that this reaction or the ligand will work better wherever you need a strong donation from the ligand side. So this is a substrate scope. We did a lot of substrate to prove the wide scope of the catalytic reaction. We also showed the chemoselectivity, that if you have a HCHO group and the benzene group, it is more selective for the HCHO. Reason is obvious because we are using a quite aesthetically bulky ligand system, which actually prevents it for the substituted aldehydes. And we also compared it, and we found this turnover frequency of these systems are quite good. And then it's a good ligand system for the electronically rich ligands wherever it is required in the metal catalyzed reactions. So then further, we thought to do the palladium catalysis because it's a very widely used catalytic component. And one of the very famous one is the Buchwald-Hartwig coupling. And in the Buchwald-Hartwig coupling, this is the mechanism you see. This is coupling of the amine and aryl halide. And when they are being coupled, this mechanism is actually well understood for a very long time. And usually there is an oxidative addition followed by the base, the HX elimination, then reductive elimination to eliminate the product. However, this step is mostly controlled by electron-rich ligand system. Since we already had an electron-rich system, we thought, can we do this coupling? Because there are plenty of literature available, but there was no report for the coupling of the bulky ligand systems. So we looked into the literature, we found that there are the ligand system available. You see the commercial ones, because it's always good to compare it with the commercial, then you can bring up the more beauty to your ligand system. And this is a BiNAbs, X-Force, DPPF, Zone Force, all this. So mostly the biphosphine systems are much more popular and efficient in this coupling reaction. So we tweaked our system a bit and prepared a bidentate system like this one which can make a 4-membered metal catalyst, and another which can make the 6-membered catalyst, and many other ligand system we screened to have a comparison. And model reaction we performed, and we found the SiNP1, this one is performing much better than any of these ligand system. And it was already, we assume, because it's a highly electron-rich system, so this is actually making the metal also rich, and the oxidative addition is much more faster. So that is actually the major reason for the efficiency of this ligand. Then to understand more about aesthetics, we prepared the complex of the palladium with these two SiNP ligand systems. In one case, we isolated the 4-member palladium, another 6. And with the bite angle, if you see here, the 70 and 87, it's very clear that this system is quite aesthetically crowded. That's the reason the yield is comparatively less in this case. Okay, so then another important observation we made in this case, in the Buchwald-Hartwig coupling, Whenever you are using strong base and high temperature, there will be the racemization of the amines, and then you will have a mixture of the stereoisomers. So this is a major hurdle when you are dealing with the optically pure amines. So in our case, we observe when we are using the silane as a ligand sister, there is a stereo retention. And that was a very good observation because of the steric bulk of silane. We could observe the stereo retention in the CN coupling reactions. So with this, I would like to conclude that we have proved that the silane is a very strong donating as well as electron-rich system, and that get very suitable and potential ligand for the strong ligand-catalyzed reactions. And with that, I would like to acknowledge my students, my collaborators, and of course, the funding agencies for their generous funding. And thank you all for your kind attention.
So this is open for discussion.
Hello, very nice talk. I just have a general question regarding your silane ligand. Have you by chance explored the ligand itself for bond activation or small molecule activation?
Small molecule activation, but the problem with the silicon 2 is that they are extremely reactive. So we had a thought to use them as an organic catalyst, but so far not successful. Because the moment they have something, they will immediately go for oxidative addition. So that is a basic hurdle in the silicon 2 compounds.
Okay, yeah. And the second question, how about the hydrolysis? I mean, as you said, it's very reactive. So you need to deal in air sensitive.
Air sensitive. So yeah, we use all these air sensitive techniques like glove box, Slankline, and SPS. So everything is done till the complexation. Once you make the complex, it's stable because you are blocking the lone pair.
Okay, yeah. Thank you.
Thank you.
It seems there are no more questions. So let's thank our speaker, Dr. Savannah Khan, for a wonderful talk.
Thank you. We'll now proceed with felicitation of our presenters and chairperson. First, I request Dr. Bani Mahanti to felicitate our first presenter, Professor Namrata Rastogi from CDRI. Everyone, Professor Namrata Rastogi. I also request Dr. Bani Mahanti to felicitate our second presenter of the day, Professor Shabana Khan from ISO Pune. Professor Shabana Khan. I request our convener, Dr. Ritu Gupta, to felicitate the chairperson for theme 2, Dr. Bani Mahanti. We thank all our presenters and chairperson for both the teams. Now I request everyone to join for lunch arranged upstairs in room number 309. We will assemble here back at 2:15 sharp. You're also requested to watch the poster presentations that are being put up by our students, which is also organized in front of the lunch venue. So kindly proceed towards that. The ground floor. First floor and second. I can tell you. One more quick announcement. You are requested to visit the poster session on the second floor. Poster session on the second floor. There will be more posters coming up on the first floor, which you will visit next.
Just want to add to the announcement. There are poster number 1236 and then plus 65, 66. They are related to bio and chemistry theme, chemical sciences theme. So please visit them during the lunch session. Lunch session is for 1 hour and we can go through all the posters. And I also request poster session participants and registrant candidates who are presenting posters to particularly be on poster soon after their lunch. Okay? Thank you.
Dr. Kirutika S. Let me introduce Dr. Kirutika to all of you. Dr. Kirutika received her PhD degree from Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore in 2017. She completed her master's in chemistry from Bharati Dasan University, Trichy in 2010 and was awarded gold medal for securing university rank. After her postdoctoral studies at the Center for Nano and Soft Matter Sciences, Bangalore, she joined as the research scientist at Shastra Deemed University, Tanjavur, in June 2019. Her research interests include transparent conducting electrodes, transparent devices, smart energy storage devices, and nanomaterials. So far, she has published 21 research articles in peer-reviewed journals, a book chapter, and a US patent. I request Dr. S. Kirutika to chair the third session on advanced materials for energy and environment.
Thank you very much for your kind introduction. Very good afternoon to all. On behalf of organizers, I'm highly privileged to welcoming you all to the third session themed Advanced Materials for Energy and Environment. I'm highly honored to introduce our first speaker, eminent Professor Shobhana Narasimhan from Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru. Professor Shobhana Narasimhan has received her PhD from Harvard University and gained postdoc research experience from Brookhaven University, USA, and Fritz Haber Institute, Berlin. She is an active member in various committees related to women in science, like member Task Force of Women in Science, Government of India, and member Standing Committee on Women in Science, Government of India, and many more. She is the recipient of various awards and recognitions, including Kalpana Chawla Award by Government of Karnataka, Milkshake Lectureship by American Chemicals Physical Society, or to name but a few. She also served as a director, career development workshop for women in science 2013 onwards. She is currently Anna Boysen Fellow at IAS Technical University Munich, Germany. She is going to discuss with us today in silico design of novel nanomaterials. Please, ma'am.
Okay, thank you, Kritika, for that nice introduction. I would like to thank Ritu and all the other organizers for inviting me to give this talk. Of novel nanomaterials. I made the talk rather elementary because I know there are lots of students here. So what we do in my group is we aim to design new nanomaterials in silico, that means on the computer, using first principles techniques of density functional theory and a process of rational design. I'll tell you what all this means. So we aim to design new nanomaterials. So this is, of course, the Lego blocks, which many of you may have played with when you were small. But can you make out what these Lego blocks have made? What have they made out of? What's been made out of them here? What is it? What does it look like? Nobody knows? Look at these things here. What these colors, what do they remind you of? It's the periodic table. So the periodic table is our toy box, if you like. And the elements of the periodic table, we use them to combine them in new ways and make new materials. And we do this in silico, that's on the computer. So why do we do computations? Well, it's a lot cheaper than doing the experiment. You can work from home. That's something that I really grew to appreciate during the time of the lockdown. It's often nowadays a lot quicker. It can lead to greater understanding if you do a computation. I can simulate conditions that can be very difficult to achieve in a lab. For example, if I want to achieve a very high pressure, it's much easier to achieve that on a computer than in the lab. I can switch off certain effects in a computation. For example, I can switch off relativistic effects. I can switch off magnetism to see what happens. I can't really do that in an experiment. And I can make predictions for experimentalists to verify. Okay? So I said I do this using first principles techniques, also called density functional theory. So what is that? So when you're making new materials and you're doing this theoretically, what we're basically trying to solve is the quantum many-body problem. So you have a many-body system where you have some number of nuclei and some number of electrons. And they interact with each other via the Coulomb interaction. And examples of this are atoms, molecules, condensed matter systems, etc. And to get to know what their properties are, you have to solve the many-body Schrödinger equation. If you've had a quantum mechanics course, you know what's the Schrödinger equation. It's very simple to write down, H psi equals E psi, but it is almost impossible to solve. And the solutions must also be properly anti-symmetrized because the electrons are fermions. So they have to satisfy the Pauli exclusion principle. And as I already told you, you can write down this equation, but that doesn't mean you can solve it. It's very, very difficult to solve. So how do you do it in DFT? You map this many-body problem onto an equivalent one-electron problem. So to explain that to you, I have an analogy which might seem a little silly to you, but I think it explains the problem. So supposing you have a bunch of men and women, okay? So you can think of the red women as electrons and the blue men as nuclei. And they're interacting with each other in some very complicated way. You can see I have hate, like, dislike, indifferent, all that. And the problem I've given to you is that you have to arrange them all so that you achieve the maximum possible level of global happiness. Now, as you can imagine, this is a very hard problem to solve because it's a many-body problem. And what you do in DFT is you instead replace this many-body problem by this one-body problem, where you only have one woman, and you have to put her where she is happiest. Okay? And this is obviously a much easier problem to solve. But the remarkable thing about density functional theory is the solution to this problem on the right is the same as the solution to this problem on the left. And you might notice that I put these face masks on the guys here. And that's because that's to represent some technical problems that you face when you do this mapping, which I won't go into now. Okay? So when DFT calculations, you might also have heard of them being called first principles calculations or ab initio calculations. And the reason for that is that the only input in your calculation are atomic numbers and atomic masses. And then you grind through the whole machinery of the DFT calculation, and you get some remarkably accurate output at the end. Okay? So now I've said we do this using a process of rational design. So we have obviously lots of materials we use in our daily lives, but the surprising thing is most of them were discovered either accidentally or by brute force, and we instead want to use rational design. So what is that? So say I have three materials, material A, material B, material C. I do computations on them. Then I analyze the results. That's the hard part. Then the even harder part is I obtain from this analysis insight into design principles. And then using this insight, I design a new material over here, which has the desired properties that I want for a particular application. So that is called rational design. So I will give very briefly 2 examples from our work, how we can use DFT to understand the properties of nanomaterials and design new nanomaterials. I've chosen them relevant to applications in energy and environment, and they're both about supported nanoparticles. So supported metal nanoparticles, for many applications in energy and environment, we use catalysts that are very small metal nanoparticles supported on an oxide surface. Okay, so for example, cars have these things called catalytic converters. And in the catalytic converter, there is an oxide. And on that oxide, there are these little precious metal nanoparticles, platinum, palladium, rhodium, etc. And they convert the bad things that the car produces into better things. Like, for example, carbon monoxide is converted to carbon dioxide, etc. And we want to design better catalysts, see that they don't degrade, etc. So the first one, I'm giving you an example, is I'm asking the question, can we change the shape of a material? So supposing this is a gold nanoparticle, okay, which is my catalyst on an oxide support. Now, when you deposit these nanoparticles, they usually tend to clump up and they form a 3-dimensional shape. So you see here, it's a tetrahedral shape. It's a 3-dimensional shape. It doesn't lie flat on the surface. But the question we are asking is, can you make them flat? Because we have reason to believe that if you make it flat, lie flat on the surface, it will be a better catalyst. So what we showed using DFT calculations is, for example, say here you have magnesium oxide. If you replace some of the divalent magnesium atoms by trivalent aluminum atoms, which are these purple atoms here, then you have extra electrons in the system because the aluminum is trivalent. And these electrons get transferred to the gold, and then the nanoparticle lies flat. Okay, so this was a theoretical prediction from density functional theory. And this was done by my student, Nisha Mammon. And if you look closely, you will see her earrings. One is the flat gold nanoparticle, and one is the 3-dimensional gold nanoparticle. Okay? So, and as I said, this happens because of charge transfer. Here she has computed the charge transfer. So these red blobs here are electrons that have been transferred to the gold from the support. So we made a prediction. Does it work? So this is the experiment that was done, where people took gold nanoparticles on undoped calcium oxide. In their case, they used calcium oxide, not magnesium oxide. And this is an STM image, an experimental STM image. You see it's clumped up, 3-dimensional. And then when they instead doped the oxide with an electron donor, in this case they used molybdenum, you see that it became flat. Can you see the difference between the left image and the right image? Here it's 3-dimensional, here it's 2-dimensional. You know, it's like a pancake or a chapati or something. So this is an example where something was predicted theoretically by us, and then you do the experiment and it works. So this is the power of density functional theory. So the next example I'm going to give you is, can we understand the diffusion and stability of a material? So here, this is an electron micrograph of gold nanoparticles on an oxide surface. And you see that these nanoparticles are moving. These two moved and joined together to form a larger nanoparticle. And now these will move and join to form another nanoparticle, an even larger nanoparticle. So this is called diffusion when they move, and sintering when they coalesce to form a larger nanoparticle. And you don't want that to happen, because you want them to stay as small nanoparticles. So we want to understand this process. So, so here we've done studies. We start with the smallest possible nanoparticle. It's a single platinum, in this case, platinum atom, moving on a magnesium oxide surface again. And it moves by this process called hopping. And we can calculate the energy this costs. Okay, so to diffuse, it has to climb over this energy barrier of 0.88 electron volts, which is something we calculate using density functional theory. Now what happens if you add an extra atom? So instead of one atom, you have two platinum atoms. Now it doesn't move just by hopping. Now something's happened to the, okay, the movies are not working, which is, okay, slowly, it's working very slowly. Can you see that it's cartwheeling? So it's not hopping. And the energy barrier is much lower, and it's a much more complicated shape. Now, I have the trimer, and it's walking along. So I don't know if you've seen the Star Wars movies. They have these things called AT-AT walkers. So this, I think, looks like an AT-AT walker. So three atoms has yet a different mechanism of moving, and 4 atoms, okay, sorry, these videos are not very stable on this. Is it moving? Yes. It's moving very slowly. See, it's rolling. Okay, and it has yet a different energy barrier. So I can calculate all these energy barriers, and then I find something very surprising. If I do it for different metals, so this is in the case for the trimers, 3 atoms, silver, gold, palladium, platinum. They scale linearly with the melting temperature of the bulk. Okay, so the higher the melting temperature of the bulk, the higher that diffusion barrier is. So if I don't want it to diffuse, I should choose a metal with a very high melting temperature. Now, this is a very surprising scaling relation. It doesn't seem obvious at all at first, but we have studied it and we can explain it. I don't have time to explain to you why it happens, but we understand it. Also, it doesn't work for the dimers, and we understand that too. We understand why it doesn't work. So the take-home message of this part of my talk, where I talked about some of my science, I just gave you a few very brief examples, was that first principles techniques can be used successfully for the computational design of novel nanomaterials. And we can also gain insight into why materials have the properties that they do. So now in the remaining 5 minutes, I want to talk a little bit about women in science, which is another great interest of mine. So today we heard already several people mention Marie Curie. So here is this famous picture of Marie Curie at the Solvay conference. And tell me what you notice when you see this picture. Does anything strike you? I mean, what struck me is that she's the only woman. She's surrounded by men. This is a very famous picture because sometimes people say it's the brightest minds ever gathered in one place because nearly everybody in this picture won a Nobel Prize. And it really strikes you, she was the only woman there. So do you think things have changed a lot? So here is a picture at a conference that I went to. And do you think it looks very different? The sad thing is it's 100 years later. It's not very different. Can anyone find me? I am there before my hair turned white. Okay, and there's one other woman there. So the sad thing is it hasn't changed much. This is a map of the world colored according to the percentage of the women in science in that particular country. India, I was quite shocked to find that India does very badly when you look at this number. If you look at the number of working, percentage of women amongst the working scientists, working R&D researchers in that country, we're at about 14%, and that is the 4th lowest in the world. We're second lowest in Asia. Only Nepal is worse than us. Pakistan, Bangladesh, Sri Lanka are all better than us. So we really are not doing very well. So what do I do to try and help change things? Well, I'm on a lot of committees. So I'm the chair of the panel on women in science of the Indian Academy of Science, etc. I also have this fellowship from the Technical University of Munich in Germany, which is meant specifically for scientists who are interested in gender issues. So I have been on a lot of committees, so I'm trying to do my bit to change policy. But the thing that I'm very excited about is that I've been working, organizing these career development workshops for women in physics. These are conducted in Trieste in Italy, and women from all over the world come here. So we've had hundreds of women from 80 countries so far. We gather and we have a workshop for women in physics. We also did one in Rwanda. We were supposed to do one in India, but then it got canceled because of the lockdown. So what these workshops do is we try to bring women together to share their experiences, help them acquire skills to rise in their career, give them advice on how to write grant proposals, how to reply to a referee report, how to make better slides for a talk, how to perhaps be a better speaker, how to deal with it if you have a hostile environment in your work, if you have a colleague who's bullying you, this kind of thing. And most importantly, form a community that can support one another. So you have an international network of women physicists who stay in touch through WhatsApp, through email, etc., and who can support each other, encourage each other. So I will just end by saying this was at the end of one of our workshops. We asked the women who participate in these workshops what they gain from these workshops. And this is a quote from one of them. She said, "Sometimes I think that I'm alone, but this workshop is a good antidote to that feeling." Thank you very much.
Thank you very much for your enlightening lecture, ma'am. Any questions, quick questions? Any quick questions? Otherwise, after the next talk also, if somebody have, you can discuss with ma'am. Thank you, ma'am. So now I'll introduce our next speaker, Dr. Pooja Devi, an eminent scientist from CSIR, Central Scientific Instrument Organization. Dr. Pooja Devi has received her PhD from Academy of Scientific and Industrial Research, New Delhi. Her major research interest includes material design for hydrogen production, air-water pollutant degradation, and water pollutant monitoring. She has published more than 80 research articles, 20 book chapters, 3 patents, and developed 4 technologies, out of which 2 is already transferred to industry. She has received numerous awards, and now she is going to discuss with us about 2D material electrodes for wastewater to hydrogen generation. Please.
Thank you for the brief introduction. And at the outset, I would like to thank organizer for inviting me here and giving me an opportunity to present the work which we are doing back in our group. For today's talk, I decided to speak about our recent work which we are doing towards exploring 2D materials for the clean hydrogen generation. So my group, especially we are from the material science background. We work on exploring the materials, developing sensor platform for water pollutants monitoring, especially heavy metals and metalloids. And a few of them we have translated into the portable kits and devices that can be taken on to the field and could be used for the real-time monitoring of the parameters. Lately, we are more focused towards catalysis for indoor air purification and also for hydrogen generation. For the indoor air purification also, we developed the devices, which you can see here. This is a portable device, air purifier, which we designed in lieu of the current pandemics. We designed it for the clinician so that they can wear it while they are working, discharging their duties into the hospital. So this is based on the PCO, photocatalytic oxidation. And how we do it, like being from the institution with focus towards the product development, we focus towards the translational research, like developing the new materials and translating those materials into the products. So we work towards developing these materials, including carbon nanostructures like carbon dots for the sensing application, then semiconductor oxides, then 2D materials. And we play with their properties in terms of size, shape, designing the heterostructures for efficient charge generation, separation, and utilization. That's very important characteristic for a catalyst. And also the surface engineering of the material, which is an important characteristic for a sensor development, where we want the selectivity into the material. Now, for the today's talk, I'll be focusing more towards utilizing these material for the catalytic hydrogen generation by photoelectrochemical and electrochemical route. And I'll be discussing two systems which we have just investigated. And I'll give a brief about the background behind the utilizing these materials. So why there is a need to look for the alternative renewable energy solution, we all are aware. Because of the greenhouse effect and this depleting fossil fuels, it's important we come up with these sustainable technologies, sustainable solution that ensure that the environment safety should be ensured, and also there should be sufficient energy available to meet our global energy demand. Secondly, when we are using the fossil fuels, we are burning them and we are releasing CO2 into the environment. So CO2 is not only affecting the Earth atmosphere, the temperature, it's also having the negative effect onto the health, like you can see here. Then another major problem which is faced mainly in the developing country, but it's also there in the developed part, but in the developing country like us, where we are going towards a lot of industrialization, a lot of urbanization, lots of water is utilized in the process, and that water, it leads to the generation of the wastewater also, which goes waste. We discharge it into our natural river system, into the ground, which in turn affects the, cause the river pollution, soil pollution. So these two problems, we know that these are the, these require the good attention, technological solution to address them. And if we see the current kind of the treatment technologies which are designed for the urban wastewater treatment, they do not look after treating the organic contaminants. Like in the primary, secondary, and tertiary treatment, we remove different kind of pollutants, but the organic contaminants like PCCPs and pharmaceuticals or organic or textile kind of contaminants, they are not removed and they remain undegraded even after that level of treatment. So now coming to the first part, for providing the solution in terms of the energy, hydrogen is projected as a promising fuel. Why is it so? It's because the hydrogen is having one of the high energy density per unit mass molecule. And another thing with the hydrogen is when we burn hydrogen, the byproducts are the water vapor into the environment. So being a high energy carrier molecule, when we use it, it meets our energy demand, and also it ensures the environmental safety because it's not releasing any kind of toxic compounds into the environment. So that's the benefit of utilizing hydrogen as an energy fuel. And this is comparatively, if we see in the Indian context, it's abundant. We can generate it from the natural sources. We can generate, there are other ways also, but from natural sources, it can also be generated. So it's clean, it's economical, it's safe, and it's available in abundance. So there are different ways by which hydrogen can be generated. One of them is known as the green hydrogen generation approach. We also call it as water splitting. So in water splitting, what happens? We split the water into hydrogen and oxygen, which is energy intensive process where we have to give the energy. So how can we give this energy? By either using electrical or maybe thermal or biochemical. There are different routes by which we can do it. So one of the route by which we can split the water into hydrogen and oxygen is that we can utilize the solar energy, where the solar energy channelize the generation of the charge carrier. So here the important part is the electrodes. So the designing of the efficient electrode, which respond to that energy, and it leads to the generation of the holes and electrons, which can be channelized by giving external bias, and they can participate in the generation of the hydrogen at one electrode and oxygen at another electrode. So what should be the important criteria when we are exploring this part is coming up with a catalyst or an electrode which has the band gap more than 1.233 eV, which is the redox potential required to split water into hydrogen and oxygen. Second important criteria is that the catalyst should be stable, and the band which corresponding to the conduction band and valence band, they should lie with the band edge potential of the water. So that's also an important criteria. Then only your catalyst can participate in the water splitting process. So with these fundamental properties, now what are the challenges associated with these kind of material is coming up with the appropriate combination of the material and also cutting down the cost of the production. So there are, in the green hydrogen production also, we have the PEC and another is EC, which we call it as a electrocatalysis. So the cost of the production is one major challenge here that can be cut down by designing the stable catalyst, which should be stable to produce hydrogen over a period of time, and also having an optimal combination of the materials. So we have been exploring towards oxide 2D material combinations for design of efficient photocathode and photoanode. And another way is that can we utilize the wastewater, which otherwise we are discharging into our natural system as a feedstock for the hydrogen generation. Right now, like most focus, we are utilizing the normal water which is available. But because of the water scarcity of the water, increasing water pollution, so can we explore this unexplored abundant source which is available? But here the complexity increases when we are trying to explore the wastewater. What are those complexity? Because we are here exploring two kinetics happening at the same time, that there will be a competing reaction where you are having the oxygen evolution, hydrogen evolution, and also the degradation of the organic contaminants into the water. So there are a lot of thermal, you can see the processes which are involved when we are utilizing the wastewater as a feedstock for the hydrogen generation. So it's important to understand these processes. It's important to, based on that, design a suitable catalyst which can work in the harsh wastewater condition. So some efforts has been done in this direction, but mostly the efforts have been directed towards titanium dioxide based material. The major challenge which remains with the titanium dioxide material is it's a UV active material only. And so even though it's inert material and abundantly available, but because of the band gap, we cannot harness the solar energy to a large extent, so we cannot achieve the higher efficiency. So what we have done, we have explored the 2D materials. What is the advantage with the 2D materials and what are the 2D materials? Basically, these are the materials which belongs to the transition metal groups and they have the layered structure. The advantage of with the 2D material is that by controlling the number of layers, by controlling even with the defect engineerings, we can control their band alignment, we can control their electronic and optical properties. So that's the advantage with the 2D materials. And if we see what major category of the 2D materials which are explored or you can say the popularly investigated by different researchers include graphene, MXenes, and TMDs. Well, the MXene is in the latest one in this entry. So because of that control of their properties by controlling the number of layers, they have found a lot of application. I'm not going more into detail of each of them. So one of the materials which we have explored is the bismuth vanadate oxide in combination with molybdenum diselenide. So this, why we have explored this material, because heterostructuring enables us the efficient charge separation, which otherwise is not possible with the single set of material if we are exploring that. So this material has chosen because of the sufficient band alignment with the water redox potential, and also it's a kind of type 2 heterostructure material that allows the charge separation and also the participation. So you can see it in terms of their band diagram and also the band alignment with respect to water redox potential. And so what we have synthesized this material by a simple wet chemical route, and we studied it in terms of their optical properties, and we found out that their band gap is well as per requirement of 1.23 eV, and being the alignment, it is possible to use them for the charge separation. And we confirmed their synthesis by XRD, by photoluminescence, that ensure by PL spectroscopy, you can ensure that your heterostructure is formed or not, because you can monitor that by decrease in the recombination. So if you have decrease in the recombination, it means you have the efficient heterostructure formed, which is good for a catalytic application. But for a sensor point of view, you want a material which have the high photoluminescence. So these are the preliminary characterization we did for the material in terms of their Raman characteristics that helped us to confirm that material has synthesized. And then we have utilized this material for PEC properties. Like in the PEC, we utilize this material as a working electrode, like as an anode. And what we have seen that when we are using this heterostructure, there is a sharp increase in the current density. So this is a criteria we utilize to compare the catalyst performance when we want to scale it further. So we see when we are developing the heterostructure, the current characteristics are higher in comparison to when we are using it alone. And the material shows a change in the current density in comparison, in response to the light. So that confirms the photoresponsivity of the material. And also we can also check the charge transfer characteristic of the material by monitoring their charge transfers characteristics by impedance spectroscopy. That shows that there are very less resistance for the heterostructures that ensure that efficient charge separation. And by MOS Schottky, we can confirm what is the flat band potential of the material and what is the nature of the material. It's a P-type material or N-type material, what kind of heterostructure we are designing. So with all this basic characterization, we studied all material stability. That's another important criteria, because when we are using the material into the harsh condition, like into the environment where you have organic contaminant, the stability of the material is also an important factor. So we studied the material by chronoamperometry to see how the material performance is. And since we are using this material in the textile dye environment, which is a simulated wastewater environment, we also studied how it is influencing the degradation of the dye. And we found that when we are using this electrode, it's not only helping in the generation of the hydrogen, it's also helping in the degradation of the contaminant. And we could see that there is a degradation of the dye up to 62% within a 60-minute time and up to 100% within a 1 hour. So that shows that simultaneously two problems can be resolved at one. And another advantage, when we are using the organic contaminant-rich environment, the hydrogen production is more in comparison to the normal water, because your organic contaminants, when they degrade, they also add up to the release of H+ ion into your system that lead to the increase of the hydrogen production into the environment. So that way, these wastewater can be explored as a source for water splitting. So that is first finding. And second, we are also working towards the MAXenes, which is a new class of the 2D materials. And they are getting a lot of significance these days because of the ease of scalability if we see in comparison to other class of the 2D material, the vaccines can be scaled in a large amount. That's the important challenge which remains with the material scientist, that scaling the material which is demonstrated into the lab condition. So fascinated by these properties and also the excellent electronic properties of this material, we are also exploring the vaccine, and we are working on titanium and molybdenum based vaccine. So I'm presenting the result here for the titanium based vaccine. So we have synthesized this vaccine by wet etching method, where we are utilizing HF to etch the vaccine from its subsequent max phase, and we did further delamination by sonication to obtain the vaccine flakes. So we have utilized, you can see, we can synthesize this vaccine even in the liters, and the yield of production of this vaccine is very high. And the other plus point, the advantage with the vaccine is that because of their polar nature, they can be used in different kind of the solvents. So that's the beauty of utilizing the vaccine. So we characterize this vaccine in terms of the number of layers or number of the flakes. That's important because in the vaccine, what we do, we etch out the metal phase, that is aluminium. So this is the max phase, which is the precursor, the origin of it. And when we do the etching and when we do the delamination, we get a accordion-like structure that shows the sheets of individual layer of the vaccines. And that can also be confirmed by the XRD analysis, which confirms like by 002 phase that whether we have obtained the vaccines or it is still the max phase. And by HR time analysis also we can further confirm that we have how many number of layers we have obtained from the max phase etching. We further did elemental mapping that confirmed this carbide, titanium carbide has been synthesized. And when we have utilized these vaccines for electrocatalytic wastewater splitting, we could see that there is a significant enhancement in the current up to 300 milliampere per centimeter square we could achieve with utilizing vaccines, which is comparatively very, very higher than the Nephron. And also we could obtain a very high degradation efficiency of 80% within a period of 60 minutes. We are exploring it further by designing the phosphides, integration of the vaccine with different kind of phosphides, which acts as a bifunctional catalyst, which can be engaged in both OER and HER, and also they can simultaneously treat the water and degrade the pollutants. So these are the, you can see if we compare different kind of electrocatalysts, we compare it in terms of their onset potential at 10 milliamps, and we can see there is a significant decrease in the over potential when we have utilized vaccine. This could be because of their high electronic conductivity. And why we are more interested towards vaccine is because of large area electrode fabrication, which is we are very much excited about to integrate the large area electrode based on vaccine to the commercial electrolyzer. So this is all about the preliminary work. So I'm ending my talk here by letting you ponder upon different combination of material which you can explore from this periodic table to design an efficient electrocatalyst or a photoelectrocatalyst which can solve these two problems at the same time, which are the pressing problem for especially country like us, being a developing country. So with this, I would like to thank all my students and also the funding agency for all the financial support. Thank you. I'm open for the questions.
Thank you very much for a very enlightening lecture, and it's very informative too. Any quick questions from the audience? You may talk.
So Dr. Pooja, I just wanted to ask for these vaccines, how stable are these materials for any application?
Yeah, that's one of the challenges with the vaccine. Currently, what we do, we etch them out and before delamination we do before utilization. But there is a lot of investigation happening that if we purge it with the nitrogen before uses, we can make them stable even up to 2 or 3 months. So there are progress which are happening towards the stability part of it. So that's the only challenge with the vaccine. Otherwise, it's one of the wonderful 2D material.
Okay, thank you for the nice talk.
Thank you.
Okay.
Hello, ma'am. I'm from life science field. After your research work, I'm worried about that. In the era of scarcity of water, you are transforming a system of life supporting system to a life fascinating system. Then what will be?
See, that's what in the starting I told. I am utilizing the wastewater.
Ma'am, there are so many mechanisms to recycle the wastewater.
But it's not how many solutions are practically feasible. If you see the current treatment plants, even I don't know if you visit some treatment plants in Rajasthan area, we visited several sites. Like, even after the tertiary treatment they simply discharge it. Okay, they just put it into the field, and it still has the lot of colors into it because they are not able to treat the organic contaminant. They do only BOD, COD, and primary treatment, not to the organic contaminant. So that goes unused, and it's being like farmers are using it for the agriculture, which is in way indirectly harming us because we are consuming those vegetables, those crops, we are consuming it. So we are adding one step to the treatment, another one step to the treatment, where you are generating the energy out of it, and also you are ensuring the full treatment of the water. So we are ensuring the treatment, and we are also recovering the energy from it. So water remains unused. It's not like water will be,
I agreed, but I think there will be a research, much better possibilities of research to utilize or recycling is in it a better way, so that we can use it as water.
It's a recyclability only. So this is recyclability only. Basically, you're using it, or you are assuring it, you are treating it fully.
Okay.
Okay. We are not consuming it.
Okay.
Thank you very much. If you have any further questions, you can discuss during the tea time. Now, we are going to hear from Dr. Khushbu Kushwaha, Associate Managing Editor, Wiley. Dr. Kushwaha obtained her PhD from University of Delhi and did her postdoctoral studies at University of Antwerp and served as a visiting researcher for a couple of years at GU. She joined ChemSelect team of Wiley in 2019 as an associate editor in 2019, and in 2021 she became the team of European Journal of Organic Chemistry as an associate editor. And she is going to discuss with us today about the Wiley and its initiatives on women in science. Please. Before we listen to Dr. Khushbu, we just finish off felicitating our presenters for the third theme. I request Chairperson Dr. S. Kritika to felicitate our first presenter, Professor Shobna Narasimhan from JNCSR Bangalore. I also request her to felicitate the second presenter, Dr. Pooja Devi from CSIRO, Chandigarh. And I request convener Dr. Ritu Gupta to felicitate our chairperson for theme 3, Dr. S. Kritika. We thank all our presenters and chairperson. Now I request Dr. Khushbu Kushwaha to present her talk.
So first of all, I would like to thank Professor Ritu Gupta for organizing this wonderful conference, Empowering S&T with Women, such a unique topic. And I would also like to thank her for inviting me to deliver this talk about Wiley and our initiatives on women in science. So this is my career biography, but as I have already been introduced, I will not to spend much time on this slide, but I would just like to mention that as an associate editor for Wiley and for many journals in Wiley, I manage the peer review process, and I also conduct author workshops to create awareness among authors and to help researchers to publish in high-quality journals. So I will give you a brief introduction about Wiley. Wiley was founded in 1807 by John Wiley and Sons. So it is more than 200 years old company. The initial focus of the company was on book selling. So I'm sure you all must have heard about Wiley books. They're very popular. But later on in the 18th century, the focus shifted to science and technology publishing. So today, the 7th generation of the Wiley family is still involved in the business. The headquarters of the company is in Hoboken. We have around 15 million researchers and professionals as our customers. We have more than 5,000 employees, and the famous publish with us. So more than 450 Nobel laureates have published with Wiley. So Wiley has a global presence. We have 70 offices in different countries, in 28 different countries, and John Wiley and Sons in India. So the Wiley research team is initiated in 2018. We are now have 2 in-house editors, 3 commissioning editors, and 1 managing editor. 2 in-house editors include myself and Dr. Partha Pratim Pal, who is based out of Mumbai. So he looks at the computational-based papers, and I'm organic chemist by training, so I look at the medicinal chemistry and organic chemistry papers. So the model which we follow at Wiley is called in-house editorial model, so which is different from RSC and ACS models. So for the in-house editorial model, we have professional editors who are working full-time for the journal. So we are not active in research anymore. Then we have editorial board, advisory board, which consists of academicians and researchers like you. We also have societies, so we partner with societies. I will talk about societies a bit later on in this presentation. So this is Wiley VCH office, which is in Weinheim, Germany. The best thing for the in-house editorial office is that we site very close to each other, as you can see in this slide. So Chemistry, a European journal, then we have Chem Electrochem, Chemistry Open, Chem MedChem, and all other journals. So this is particularly feasible for the transfer system. So if we have a particular manuscript and we want to transfer it to another journal because maybe the topic is not suited for my journal, then I can just walk up to another editor and talk about the manuscript for transferring. So Wiley Online Library is an electronic platform which gives access to more than 1,600 journals, more than 21,000 books, 200 plus reference works, laboratory protocols, and databases, and we have 18 million visitors each month. I would also like to mention that Wiley is a founding publisher of Research for Life, so providing free or low-cost access to more than 1,200 Wiley journals in 90 developing countries. These are our top 5 journals: Angwanti Shimi, our flagship journal, then followed by Advanced Materials, Chemistry, a European journal, followed by Cancer, and at the 5th position is Advanced Functional Materials. So coming back to societies, I personally work with 2 main societies that I'm going to talk about, Chemistry Europe and ACES. So Chemistry Europe is a collaboration of 16 continental European chemical societies, such as Swiss Chemical Society, society from Italy, and various other European countries. So they have this collaboration, and with Wiley, we publish 19 high-quality journals. Then on the similar basis, we negotiated ACES, which is Asian Chemical Editorial Society, which consists of 12 Asian chemical societies. CRSI, which is highlighted here in yellow, is a part of ACES. So if you publish in any of the ACS journals, then CRSI receives the royalty from Wiley. And together with Wiley, ACES publishes 3 high-quality journals that includes Chem Nanomet, Asian Journal of Organic Chemistry, Chemistry, and Asian Journal. Okay, so this was a brief introduction about Wiley. Now I will talk about our initiatives for women in science. So we organize various activities. We do special collections, and I will just talk briefly about our activities. So first one is that we organize IUPAC events. In 2021, the theme was empowering diversity in science, so gender in academia and publishing, where we address the biases in academia and also in the publishing industries. The 2022 event focused on empowering diversity in science and African perspective, so which is focused more on African scientists and their contributions in science. So then another way by which we encourage and support women scientists is by doing special collections. So we are doing this since 2011. 2011 is declared as International Year of Chemistry by IUPAC, and one of the main objectives of IUPAC and UNESCO was to celebrate and encourage women scientists all around the world. Since then, we have been doing these special collections. So we published, Engwante Shimi published a special issue dedicated to women in chemistry in 2019. So very interestingly, and I would like to mention this, that one of the women researcher, she insisted not to include her paper in this special collection, which is very sad. And the reason she gave to us is that her work will be judged, and maybe her male colleagues will say that she was able to publish in Engwante because it was a special collection. So here I would like to mention that we do not write in our, we do not mention or write in the invitation letter to the reviewers that this particular manuscript is for consideration for a special collection. So we treat it as any other manuscript. So moving on, so Chem Nanomed then published a special collection on Asian women in materials chemistry and nanoscience. Then CatChem publishes Women of Catalysis, and Chemistry, a European journal, published in 2016 Women in Chemistry. So these are just few examples, but every year we publish many special collections, special issues dedicated to women scientists, the excellent research from the women researchers. We also sponsor conferences, so such as this one, and we are also going to empower, sponsor Empowering Women in Organic Chemistry, the conference which is going to happen in this year. Then I would also like to mention that we have many female researchers, excellent researchers in our editorial board. So for example, we have Sanchita Sen Gupta from IISER Mohali. She is in editorial board of Chemistry Select. We have Dr. Namrata Rastogi from CDRI Lucknow. She is in early career advisory board of Asian JOG. We have Shabana Khan in Chemistry and Asian Journal. And we have, as you can see here, these are just few examples, but we have many more women in our editorial board and advisory board. And they play a very important role. So we seek their help whenever we have conflicting reports and when we need suggestions and ideas to promote our journals. So they play a very important role. So while we are doing all these activities, there are also some problems, such as that lack of women in science leading to them be in over demand. So the question is, if we are overburdening women, because we invite them in the editorial board members of various journals, we invite them as speakers at conferences and as peer reviewers. So are we overburdening? Because there are few women at the higher level, at the faculty positions. So are we overburdening those women? So with this question, I end my presentation, and I will be happy to answer any questions.
Hi, this is Dr. Abhilasha. So other than this chemistry, does Ville also has some journals in engineering fields like chemical engineering and such? If you could provide some information on that.
Yeah, actually, I basically work for chemistry journals, so I mostly know about the chemistry journals. Okay. But we also have many journals for engineering disciplines, and for variety of there are variety of journals focusing on different disciplines of engineering, so chemical engineering, mechanical engineering, and so on. Okay. But unfortunately, I'm not very familiar with them.
Okay, thank you. And any women initiatives in those sites also similar to these chemistry?
Yes, so similar to these initiatives, we have also been doing several special collections for those journals which are focused on engineering and other fields. So similar initiatives, I would say. So thank you everyone for listening.
Any quick questions? If you still have, you can ask. Okay, so I request Dr. Kritika to felicitate Dr. Khushbu Kushwaha for her nice presentation, please. Now I request the audience to proceed for high tea arranged outside LHB 110. And you can also visit the poster presentations on the first floor. So you must have already visited the poster presentations on the second floor. Now I request you to proceed for the presentations on the first floor. We will reassemble here. We will gather back at 4:25 p.m. exactly.
आ रहा है? Good afternoon, ma'am. Am I audible? Ma'am, you are not audible. May you please unmute? Hello. Ma'am, you are not audible.
Hello, can you hear me?
Oh, yes.
Okay, good, good. I don't even know. I think let me just share pattern with. Oh, yeah. Okay. Let me just because my IT company is trying to help me. Let me have some. Okay, so now how, if I want to share a screen, I can't see you. Would I be seeing anyone when I'm presenting?
Ma'am, there will be option of sharing screen, right?
That one share. Is that one? And
Yes, ma'am. And
uh,
there will be an option of share application.
okay, I may see. I'm
Yes,
sharing
ma'am.
a
It's
screen.
visible.
Yeah.
Yeah, it's visible, ma'am.
Okay. So
We are just waiting for few minutes and then
yeah.
we'll start because there is some poster presentation is going on.
Okay, but let me just stop the sharing. I don't even know where am I sharing. Oh, sorry. Sorry. I don't even know. It's just I can't see the screen. Let me just take this off. I have one screen only. Can you see me now?
Yes, ma'am, you are visible.
Yeah, but I don't even know what I'm sharing. Oh gosh, I have so many things on my screen. That's one. Sorry, 1 minute. I can see you. I can see someone talking there. Yes. Oh, okay. Now I want to see what I share on the screen. I just can't see my screen.
Ma'am, you can directly go to the PowerPoint without moving from the WebEx.
Yeah, okay, that's it. Sorry, because I'm, you know what, I have there, you can see my screen.
Yes, ma'am, it's visible.
Yeah, okay. And I need to go to the first slide. Yeah, let me just go to the first slide. There, put it in. Yeah, okay. I stop sharing now. Yes.
No, ma'am, it's okay.
It's okay, just leave it there.
Yeah, ma'am, it's okay.
And if I
Within
want to, yeah. Okay, perfect. And you can see me, I can't see you.
So, ma'am, if you go to the right corner, there will be an option of layout, and if you go to the layout, there will be option of
Layout, just stop sharing participants. Is that layout? I don't know. Am I sharing the screen?
Yes, ma'am, your screen is visible.
So you can see my presentation.
Ali, good morning. Ajit here.
Good morning, Ajit. Good morning.
How are you?
I'm very well, thank you.
Today is supposed to be a holiday, but you're on.
No, today is not a holiday. It was yesterday.
Okay. Good. So the image on the dais is the one that you would see probably. The audiences will be on the back front. So audience would see you as the front display on the computer screen.
Okay, perfect.
So,
Thank you very
so
much.
far your audio, your video, your slide is all A1. No problem.
Yes, it's there on. So you let me know when should I start?
So I'll ask Rajesh to give you an SMS to sort of give you, or I'll ping you on Teams, something like that. Is that okay?
You know what, Teams, if you send me a WhatsApp is better because I have the WhatsApp. Yeah, the WhatsApp is better than Teams, if you doesn't mind.
No problem. So I'll just ask Rajesh to send you a WhatsApp as soon. So just 5 minutes before we are starting, he'll give you a heads up, and so that you can prepare.
Okay, perfect. Perfect.
So till that time, we can let the cover slide on the screen so that when people come, they can see what's going to be.
Okay, perfect. No problem. Thank you, Thank you, Ajit.
All right. Thanks. Take care. See you soon.
See you soon. Bye-bye.
Bye.
Oh,
Ali, can you hear me?
yes, I can. Yes, yes.
So the latest is that we still have about 10-15 minutes to go till before the presentations on the poster presentation gets over. So would you want to grab a cup of coffee before you start up?
Okay, will do.
So it's 4:11 here, and 4:20 is when the scheduled completion of
Okay.
poster presentation is. So
Okay.
Rajesh will give you heads up any which ways, but I thought I'll just let you know.
Okay, brilliant. Thank you very much. So in 15 minutes, yes?
Yep. Yeah. 15 minutes is good.
Perfect.
You can grab a cup of coffee and then
I
we can
will.
catch up.
I will. I will. Thank you. See
Thank
you
you.
then.
See
See
you
you
soon.
then.
Hello.
Hello, hello.
Good evening, everyone. We'll now begin the fourth and the last session of today, Societal Challenges for Women in Sciences. This session will be chaired by Dr. Shweta Raghavan. Dr. Shweta is a scientist and science policy expert who provides independent research, advisory, and consultancy services to several leading medtech startups, life sciences companies, and academic institutions. She has served as the Senior Science and Innovation Advisor to the British government's Foreign and Commonwealth Office, advising and supporting UK's bilateral relationships with India in the health and life science sectors. She also founded Scientists and Company, a social initiative to promote science education among students from the disadvantaged and underprivileged backgrounds, mentoring over 5,000 students across India and UK. She received her PhD from King's College London in cell biology for unearthing novel ways of mitigating lung inflammation arising from respiratory illness. She is the recipient of numerous international awards, including Global Health Pharma News Magazine's Most Influential Life Science Expert Award for 2020 and 2021. She has published in leading media outlets and has been invited to speak at prestigious forums, including the UK Parliament, WHO, IIT Bombay, and the Royal Society of Geography. I request Dr. Shweta to chair the fourth session on societal challenges for women in sciences.
Thank you, Shruti, for that very kind introduction. Before I begin, I'd really like to thank Dr. Verma and Professor Chaudhary for actually having me here. The generosity of SAB and IIT Jodhpur has really overwhelmed me. It's been lovely. Your staff and students are fantastic, and we at RSC are really thankful for that. Having said that, I'm going to quickly move on to introducing our next speaker. Rajesh, is Ali on? Fantastic. So we've got Ali here. Ali doesn't really need an introduction, but I'm not going to forego the opportunity to introduce her. Ali currently is the global head for inclusion and diversity at the Royal Society of Chemistry. She is more of an Indian than I am, perhaps. She seems to know pretty much everyone in this room, and I'm still getting introduced to them. She started off her career as an assistant professor in Argentina. From there, she moved on to Cambridge University before she started off with the Royal Society of Chemistry. She has a lot of high-impact publications and policy reports to her credit. Ali has worked extensively across the globe. She's worked in Latin America, in the Africas, as well as in India. And she's very passionate about progressing the career of female scientists, particularly chemists in India. And that's the major topic that she's going to be addressing today in her speech. Without further ado, Ali, this stage is all yours.
Thank you. Thank you very much for that very kind introduction. And I only wish I could be there in India today. It would have been fantastic. I'm very delighted to be here talking about our work towards making the academic chemistry community, the chemistry community, much more inclusive. I would like to start by introducing our, sorry, I just want to move. Sorry, I want to move my screen and I don't know what happened that it doesn't move. There. Thank you. So I would like to introduce, by introducing our new inclusion and diversity strategy, which the central objective is to increase the diversity of people choosing the chemical sciences and fulfilling their potential for a truly inclusive community. And this new inclusion and diversity strategy, the most important part is that it's based on evidence and data. If we have an evidence-driven approach to inclusion and diversity, so everything that we do is supported by the data and evidence, so that we can track progress on any intervention that we developed. And the other important aspect is that we want to work with others, so that we can effectively influence the culture of chemistry globally. And so, in a nutshell, our strategy aims at increasing the representation of underrepresented groups entering and progressing in chemistry. So, but what does it mean, the term underrepresented groups in chemistry? Today, it means women at senior levels everywhere in the world, includes Black and minoritized ethnic groups progressing in particular and being retained within the chemistry community, particularly the Black chemists, the LGBT plus individuals, those who have deprived socioeconomic background, and the important is how we attracting them into chemistry, and disabled people at all levels. So for each one of those groups, underrepresented groups in chemistry today, we would like to influence change by 2025. So if there is one thing that I would like you to take away today from our strategy and our implementation and our all activities is that chemistry does not welcome everyone, but it should and it will. And if we are working together, we should achieve this. So let me tell you a bit about how all this strategy began our new approach to inclusion and diversity. In 2018, we published our first report, The Diversity Landscape of the Chemical Sciences, analyzing available data to capture the state of diversity in our discipline. We found that chemistry is not representative of society as a whole, and we identify particular areas where improvement is needed. However, despite the work of many, including ours, this research shown us that gender inequality continues to be one of the biggest issues in our community, with the number of women dropping off at each stage of the academic ladder, as shown here for the UK academic chemistry, compared to the physics community, for instance. Chemistry within the higher education system becomes increasingly more male-dominated at senior levels. And this is not specific to academia. A similar picture is found in chemistry, in industry. And change is happening, but it's nowhere near fast enough. Furthermore, at the current rate of change, we did a statistical analysis of the data here. And a simple statistical analysis shows that the higher education data tells us that we will never reach gender parity in academia for the chemical sciences unless there are interventions that change the direction of travel and the pace of change.
Ali, can you hear us? Yes.
Yeah.
Could you please share the app because we're unable to see the slides?
Oh, what do you want me to do? Sorry.
Just share the slides. We just need you to share the slides.
I'm sharing the slides. It says.
I think you've shared. If you could just undo it and then restart it.
Okay.
Because we're
Okay.
not able to see your video.
Okay. So stop sharing.
You probably want to shut down the presentation because there's a lot of pixelated images across it. There's gray boxes that appear on them.
Oh, I see. I don't know. Okay, because I see it well, but okay, I'll start again. I'm here. I'm back. Start sharing. Sorry. So now I start sharing. Where can I see that? Sorry, I just don't see them. Show menu bar. Share. So is share what? Microsoft PowerPoint. Can you see that now?
Yes. Yes, that's fine.
So I was here, right?
You could probably project it.
Is that, are you seeing it now? Because,
It's all good. It's all good. Apologies
yes.
for waking up your talk.
No, that's all right. Of course not. So I would like to share this this cartoon, which appeared in the Punch magazine. I don't know if you know that Punch magazine is extremely old, and this appeared almost 30 years ago, capturing what might happen in the ballroom or in a committee. And I just wonder how many women who are listening to me today, or how many other underrepresented groups in chemistry, have had this mixed tricks treatment. You speak out, you say something, and it's not being heard. So let me continue with the presentation. So since then, since we launched the diversity landscape on the chemical sciences report, since then we began to work on a specific research projects to understand the lack of progress of developing and retaining women in senior positions. And we launched the Breaking the Barriers report. And we identify in there three main barriers for the retention and progression of women in academia. First was academic funding structures that create uncertainty and put unnecessary pressure in individuals, perhaps with the short-term contracts and with the short-term types of fundings that we have. The second is about the academic culture, which can't draw talented chemists elsewhere. And the balancing responsibilities that including carrying responsibilities at each stage of the career path. And of course, these three barriers affect anyone in the chemical sciences, but they disproportionately affect more women than men or than others. And we must address these barriers to really drive change for the benefit of everyone in the chemical sciences community. So in the report, which is accessible in our website, you can see all the evidence that we have and all the data behind this. But the question is, what can we all do to change what's happening? So work together, work with us to lobby for change, to demonstrate what good practice is, and to influence other organizations. Sponsorship matters to anyone and can be a major contribution to progression and success at all career stages. So support and sponsor women to succeed. Nominate women scientists for prizes and awards. Unfortunately, nominations of women and by women are still too low. So if you're not nominated, the number of prizes awarded to women and awards, it will be very, very low. It's continue to be low. Act as a role model. Demand and expect flexibility. Be proud of your own achievements at home and at work. And don't be afraid of asking for a sponsorship and mentoring, for instance. All this work helped us to design and develop multiple interventions to break down some of the barriers, such as, for instance, the grants for carers or the assistant grants. And those grants have been uptaken by the Indian community extensively. And this is funding supporting individuals who need to attend developing activities or conferences and have care responsibilities, for instance. One unexpected consequence of the research that we have undertaken in women and women's retention and progression was the incidence of bullying and harassment in our community. And since then, we launched a support line for anyone who is affected by bullying and harassment in the working environment. And it's a confidential line that helps others to understand what the issues behind are and get some support. We also have launched a video explaining what bullying and harassment is and what can you do as a bystander, what could be the way to react when you see bullying and harassment. And this is accessible in a YouTube as well, not only in our website. It is clear from our report that talented women are leaving the sector before reaching their full potential. And many of those who stay are not progressing at the same rate as their male peers. And of course, as we know, publishing output continues to be an important metric for promotion in academia. So we embarked in another piece of research analyzing the gender profile of authors of over 700,000 manuscript submissions across all our journals, also all areas of chemical sciences, between 4 years, 2014 to 2018. And we assigned gender to names using an established published method. And there are limitations with that published method. For instance, some countries cannot be considered because of the algorithm doesn't assign correctly to the name's gender. And that calls for the importance of self-reporting in terms of gender and gender identity. So what does the gender balance of our research community look like? And this piece of research told us that around 36% of the chemistry research community are women. And compared to this baseline of 36%, we found that there are several areas of imbalance across the publishing pipeline, and begins with the allocation of positions in the author list. The majority of women are not corresponding authors. And when they are corresponding authors, the choice where they submit their research paper usually is to a lower impact journal, impact factor journal. And this imbalance persists in the peer review process. There are fewer female reviewers. And women are less likely to have their articles cited, contributing to the overall challenge of achieving and maintaining visibility in their field. In conclusion, there appear to be small biases at every stage in the publishing pipeline, which results in a significant cumulative effect that hinders women and favors more established researchers, often male researchers. This research led to the development of an inclusion and diversity framework for action. And again, all of these reports are available on our website. And the concept for this framework for action was to set the standard for driving change within the academic publishing to increase diversity in the research ecosystem. Since then, we put an action plan to combat gender biases in publishing, and we encouraged intervention from publishers and from our community to increase awareness of the issues and also to call for an increased representation of female researchers at boards, increasing women at decision-making positions. And this led to the joint commitment on inclusion and diversity in publishing. And we have today more than 50 publishers joining this commitment, including others beyond STEM subjects, where we publicly commit to change inclusion and diversity within the research ecosystem. And the impact of this joint commitment is still to be seen, but it could be phenomenal in driving change in the research culture. We openly share knowledge and resources within the publisher. And we also, for instance, implemented some changes which actually really drive change in terms of increasing inclusion and diversity in the research community. We implemented author name change policy, and that was late last year, enabling authors to retain credit for their work, not matter what their personal circumstances are. More recently, we agreed how best to collect diversity data. And so we uniformly accept how to collect diversity data in terms of gender, gender identity, and race and ethnicity. And that will be extremely important because it's one research community, researchers publishing with one publisher and then with another publisher according to their topic of their particular piece of work. But it is the same community. So having a commonality how we approach, it will help us to identify issues and to act accordingly. Very briefly, I would like to mention about our work on gender identity with the Institute of Physics and the Royal Astronomical Society. And we created a network for those physical scientists who identify as LGBT+. And we carried out a survey and interviews to explore the current workplace and the climate for LGBT+ scientists within the working environment. And we produced a report summarizing our findings. Let me highlight two of those key findings from the report. Around 20% of the LGBT+ respondents had experienced exclusionary behavior. Around 50% of respondents saw a lack of awareness of LGBT+ issues. And of course, there are women who belong to this community and they are affected perhaps more than others. Since then, we developed an LGBT+ toolkit around key issues that needed to be addressed, and we created audience-specific booklets. For instance, it's interesting the booklet for allies and colleagues as a resource for anyone wanted to act in allyship and solidarity with LGBT plus colleagues, covering areas such as positive accountability and bystander interventions. And again, all this toolkit is available on our website. And when I talk about exclusionary behavior, and let me talk about the sense of belonging in the community. Previous research has shown that a lack of sense of belonging, defined as a feeling of membership and acceptance, is an important factor in the retention of people within academia or any working environment. In addition, we know that previous research showed that unless people feel they belong, they are likely to thrive in their profession. So keeping all this in mind, we conducted the first ever study of chemical scientists' lived experiences about belonging. And we produced a new report based on in-depth discussions with chemists from around the world who shared their experiences through virtual interviews and focus groups. And everybody that we spoke to said that a sense of belonging mattered to them. Feeling that you belong at work can contribute to greater innovation, creativity, and productivity, and also enables better collaboration. When chemists don't feel they belong, this can impact negatively on their performance, on their progression, and their retention. Feeling you belong or don't belong at work also has an impact on chemists' self-confidence, in their mental health, and their well-being. Questions of belonging and experiences of exclusion are particularly important for people from underrepresented groups. And again, women at senior level are representative of underrepresented groups. So the core takeaway is that fostering a sense of belonging leads not just to better well-being, but also to better science outcomes. And this report includes the enablers of belonging, what you can do, what actions you can take about building a culture of belonging in your environment, your working environment. And we are producing a toolkit that will be released this summer, so watch out that space. I hope it's going to be useful to everyone in the community, every one of us. And I'd like to finalize with the last piece of research that is about our latest report focusing on race and ethnicity in the chemical sciences. And acknowledging that racial and ethnic discrimination exists in society and consequently in the chemical science is essential if we really want to change the system. So achieving racial and ethnic equality is not just a social justice issue. We know that diversity of thought is good for science, is good for business, and is good for society. And there is plenty of evidence to back this. So we look at the data and the attrition for Black and minority ethnic chemists at each career stage. And we know that we are losing talent enormously, phenomenally. And so we started a large piece of work to understand the systemic issues behind the race and ethnicity inequalities. And I just want to, you can see the report and the actions that we are taking. And I just want to talk about only about the 6 key interacting themes that we found that affect the retention and progression from Black and minoritized ethnic backgrounds, chemists, because those are very similar to the issues that we found for the lack of representation of women and the retention of women at the senior positions. First is the attraction, inspiration, and progression. And this includes a lack of relatable role models, the limited career guidance and support, and the impact of familial and cultural influences. And again, the short-term approaches to outreach. Mentorship, sponsorship, and networks. And this includes the limited access to advice and opportunities, the impact of homophily, and this is the tendency that people form connections with people that are similar to themselves. So if you are an underrepresented groups, you might not form part of groups. And the need for a more consistent approach institution-wide about providing support for individuals. The culture of chemistry, which includes implicit and explicit exclusion to some, as well as the wider challenges of a chemical science culture that is often competitive, hierarchical, and inflexible. Funding systems and structural barriers. This includes a lack of equal access to research experience at earlier stages and later unequal access to funding, as well as narrow definition of success, which penalizes people that takes less traditional paths to progress in their careers. The importance of the global community, the global chemistry community, and this includes the need for increased diversity of thought and innovation by strengthening collaboration and recognition of the talent in the global south, ensuring a flourishing chemical science discipline. We heard extensively that many believe that the global chemistry community is not representative of the global community, they're represented mainly of the global north. We need to change that, and we are committed to do that. And the last point was about the need for a stronger and faster institutional and sector-wide leadership and accountability, as well as for individuals, particularly those in the case for Black and ethnic minorities, those who are white to act as allies, those who are men to act as allies for women. The last slide is about how many resources we have on our website, and I mentioned many of those just now. All our reports, including Missing Elements report, as well the Inclusion and Diversity Fund, which provides funding for any research, any project that tends to increase inclusion and diversity within their own communities. And the Indian chemistry community has been very successful in obtaining funding in different parts of India, in different universities of India. Our grants for carers in particular, but do encourage to take a look through the resources on our website. I mentioned the inclusion and the bullying and harassment video. More recently, we launched a new video about implicit bias for fairness and decision making, and it is very interesting about being aware about our own biases to make fair decisions or increase our fairness. With this, I would like to thank you very much, all of you, for hearing, and I really wish I could be there with you, seeing all of you. Thank you.
Thank you very much, Ali. Thank you, Ali, for sharing your insights and some of those really actionable plans. That's really what we needed. Any questions for Dr. Palermo? Sorry, was there a question there? Yes, we've got a question.
I have a question about some of the resources that you mentioned. I was wondering, who is the target audience? Is it the people who feel they don't belong, who feel they're excluded, or is it the majority to make them realize that they have to work to be more inclusive?
Oh, that's a really good question. It's an excellent question because when you read the report is about everyone, those who feel they don't belong or those who feel that they could make a difference. So there is for everyone who is within the chemical sciences, and it's almost like a mass read because there are quite a lot of evidence from individuals who kindly told us their own experiences, which sometimes are quite painful to hear and quite painful to understand. But when we are producing the toolkit, we are thinking about how each one of us can help in our own working environment. So, and I mean each one of us, in particular those who are in power, those who have the power to make changes, perhaps supervisors or head of chemistry departments or head of research or whatever colleague that you have in terms of that have the power to make changes within their community. But it is for each one of us to make sure that we now don't leave people behind, that we don't, what can you do to create that welcoming environment? And if you have even a small group, or even if you are a teacher in a class, how you make your efforts, what can you do to include everyone? I hope that answers your question, but it's an excellent question because we debated extensively about how we develop the toolkit, that it actually makes a difference. And we really focus on those who are actually in the working environment that can make a difference.
Thank you. That's exactly what I was asking.
Thank you.
Hi, Ali. This is Sandeep.
Hi, Sandeep.
Truly privileged to hear your thoughts and the incredible amount of work that has gone in the preparation of these toolkits, as well as the outreach activities. What I want to know on this issue is that if you look at a subset of, the communities that RSE has been able to reach, how satisfied are you with the progress and what you anticipate in addition to toolkits? What is next on the agenda to bring the inclusion, the desired inclusion and desired diversity, not just in the UK, but wherever RSE has footprints such as India?
Absolutely. Thank you very much, Sandeep. Excellent question, and it's a difficult question to reply. I think at the moment, what is for us is provide the undeniable data. So one of the issues around inclusion and diversity is when you present the facts, when you present the data that supports what you want to change, you can make a difference. Just talking about the issues without data that supports you, and we are all scientists, we are all working through data, and so presenting the data that really makes a difference. So that's in particular, for instance, one of the areas that I think that we need to focus as well is about disabilities. We have are we really including the disabled chemists within our community? And at least the data that at the moment we have so far says no. At least within the RSC, we don't feel that we are communicating with the disabled chemist. And so we need to change about how we communicate and how we work with them, how we engage with them, and how we understand the needs of the community to support them and to provide the definite actions. In terms of, and I just gave you about disability because I think it's almost like the elephant in the room. You're not talking about the disabled chemists, and we are not including them in many of our activities. But in terms of what's next for us about toolkits, I think is you collect the data, you present the data, you present it and you talk loudly about it. And you almost sometimes you have to grow a thicker skin to actually not being affected by some people who deny what you're saying. They don't believe that this is happening to the community. But the more you talk to the community, the more that you engage with the community, the more that you get the support. And that's why I said I wish I would be there talking to everyone and listening to what you feel, what you think, to make a difference and to identify joint actions. And our work on race and ethnicity was a piece of research that took almost 2 years to finish. And it has been a very difficult one, because many people didn't believe that racism or discrimination against race and ethnicity or ethnic minorities exist in the chemistry community. But if we know that we are part of society and there is racism, and in terms of and ethnic minorities groups feel discriminated, chemistry is part of society, should have the same issues. So talking about this is very important. And now we are defining the next action. So the RSC is now creating a race and ethnicity unit fully dedicated to that. And so we create this with a significant investment from the RSC to work with others to create and deliver change. And within that, it is about the global chemistry community. So I do hope that we can really talk about creating or supporting the development of a global chemistry community rather than a specific with some countries only. I don't know if Sandeep, I have I replied to your question, but let me know.
Sandeep, is that any further questions?
Thank you, Ali. I think we did get our answer, and we wish that you were here so that we could have interacted better, but perhaps next time. Thank you so much.
Thank you.
Any more questions for Ali? Great. Ali, thank you so much. That was really insightful. And again, you always come up with an actionable plan, and that's really important for us. So thank you very much again.
Thank you. My pleasure. I have an excellent day.
Lovely. So can we just give her a round of applause? All right, so quickly moving on to the next session. I'm really sorry to say I'm not here to make a presentation. You wouldn't be interested because I'm a life scientist and I work on lung health and disease. Perhaps COVID is of interest, but we can talk about it outside of this particular hall. I'm here right now to conduct a town hall meeting. To those unfamiliar, I just want to give you a quick background as to what a town hall meeting is and why we're doing it. So I'm here representing the Royal Society of Chemistry. We are undertaking a study to understand the gender disparity and the various challenges female researchers in Indian chemical in the Indian chemical research community are facing. So it's time to act, and that's why we're here. If we can get the next slide, please. So our objective is quite simple. We'd like to strategize a roadmap. We'd want to systematically figure out what are the various challenges, the gaps, the opportunities, and how to fix them in empowering our women. So we need to understand that this is not just about empowering women, but it's also about bringing in gender parity. So we want both men and women to progress hand in hand. So if we can have the next slide. So there are a couple of activities that we've planned. It's just that we're not going to be working with chemicals or reagents. We're going to be working with people, and those lovely people are yourselves. So we're going to have a couple of personal interviews. There's going to be thematic town halls. This is not one of those. We'll also be collecting and curating a lot of primary and secondary data. And then we'll also have a survey. Most of you will get a link to that, and we hope you can fill it up for us. Can we go on to the next slide? All right, so today we're doing a very generic town hall. What is a town hall? So town halls are generally open free spaces where you can voice your opinion. Although this is about empowering women, I really urge the men to also come up with their comments, because when you're working together, you obviously may have identified certain things that we as women may have overlooked. So you're very welcome to share your thoughts. And because I say it's an open space, anybody can say anything they want. There's no problem here. Please don't hesitate. The Chatham House rules apply. Those unfamiliar with Chatham House rules, what we basically mean is that whatever you say will be recorded, but it will not be attributed to you. So you could make a comment, you could give us an opinion, you could criticize something, perfectly fine. We'll never say X, Y, or Z said it, but we will include that in the report. Any questions about this before we go ahead? So this is going to be a very interactive session. Okay, so yeah, so the first thing we're going to talk about is breaking down barriers. Can we go to the next slide? This is one of my favorite memes. The reason is because I think, how many women here have a DL? I have one. How many of you have been told that women are poor drivers? I would probably raise both my hands. I mean, think about it, all right? The same people that tell you that women are poor drivers will also tell you that women drive men mad. Women drive men up the wall. Women drive men into the arms of other women. I mean, we ought to be really good drivers, right? So this is, stereotyping. And this year's Women's Day theme was all about breaking the bias. And that's what my gran used to tell me. If somebody makes fun of you, laugh with them, because they'll have no reason to laugh further. So maybe we'll start this session with you lovely women and men telling me about what you think are the biases that you face. Are there any gaps? Are there anything that you feel is a hindrance? It might seem very small to you, but technically speaking, it's something everybody is facing. So it's like small drops in the ocean, but everyone's facing it, so it's going to turn into a wave. So the faster you tell us about it, the more you tell us about it, the more details you give us about it, the more useful it will be for our study, because based on this town hall, we're going to chalk out the rest of the themes for our study. Yeah? Who wants to go first? I'll be a little cheeky. If somebody can give the mic to Sandeep, please. Yeah, I know. I'm just in the mood to be really cheeky today, so I'm sorry. So this man is really a champion for women's rights, and I've had a wonderful conversation with him twice. And I really want you to start off by thinking what you think is really hindering our progress. If you could just start off the conversation, and I'm sure everybody else will follow, the leader.
I think it's a good idea to have town hall. And it is even better idea if there are so many distinguished people here, they could start off. But now that you have asked, I think we are making progress. I would never say that, that there is a continued progress. There are winds of change that I can, almost see and, feel. And the right sentiments are in place, and the current generation and the generation who is driving all of us forward, they have the right intentions to break those barriers, as Ale pointed out, breaking barriers. I think so with all these instruments in place, all the right intentions in place, and support, mentorship, and everything else that goes around, I feel that we are on the right track, and things will change for the better, and we will see more gender neutral workplaces, as well as places where not just gender. I mean, what Ale pointed out is really transcends gender. It talks about lot other communities who are underrepresented. So one day things will change for the better. So I would start with that. If it's okay with you. Yeah?
Change
All right.
for the better.
Thank you so
Lovely.
much. Yeah.
Okay, since I don't have volunteers, I'm going to be really brutal. What's your favorite color? Favorite color? Red. The first person I see in red is the person who's going to talk about it. So if you have any grouse, it's against her, not me. She picked the color. So what do you think, ma'am? If you could just introduce yourself and tell us what do you think are the major barriers you have faced in your career? Yeah, there you
Should I stand up? No, it's okay. Yeah, no, it's okay. So I'm Sunita Bhagat. I'm from Delhi University, RSD College. In fact, I have faced lot of problems while starting my career. Right after, once I joined there as the, ad hoc teacher, and then faced many a times in the interviews also by the, interview board. Being a woman, and that too not from the Delhi, many a time I faced the bias, but I could overcome every time with my willingness and zeal to do whatever the best facilities I can create for myself and for my lab also. And I would like to say that I was the, in fact, pioneer of research in my college. Delhi University has got the 80 colleges, out of which 30 has got chemistry. There's not even one or two colleges are there where this research is going on, and our college is the first college where the most of the publications are coming up, and that too starting with a woman. Now other women are also getting inspired, and secondly, what I want to say is that I was discussing with Neetu also in the morning, that my research group, it started with, uh, women candidates only with PhD students. So whenever we interacted, we always found that we have, social boundaries, means how to come up with those, come out with those boundaries to achieve whatever you desire. So that's the basic difficulty we were facing. So we were discussing, I have been discussing with my students most of the time, inspiring them that whatever the, goals you have in life, you have to do your best to achieve those goals. So it's not, student teacher relationship, rather it's, being their mentor as well. And now they are doing well. Sandeep sir has talked about that fellowship in the morning. One of my students is recipient of that fellowship, and it's because of initiatives taken by the government as well as her hard work also. So she's having small kids, even then she's in a private university, and she's doing excellent work. So I'm proud of her, and that's all I want to say.
Right or left?
It's okay.
No, right or left? You have to pick one. I didn't say if it was your right or left. I could be very cheeky again. My level of cheekiness is invincible, so right or left? Left. Okay, I'll go for my left.
Okay.
You know, we gave Neetu quite a headache this lunch break. So can we have the mic here? Yeah. So if I had to ask you, sure.
In the morning, there was, one slide by Pam that there was in the interview board, there were 3 women. And that's what, I discussed with Sandeep sir also, that always there is a policy in the by the government that there should be one woman means candidate in the interview board. Why only one? That's my question to all the time with the authorities. So my question need to be answered yet.
I mean, what if that one is brutal like me? You probably don't want to have any.
Thanks.
If I had to ask you, what are the top 3 barriers to your career progression? I'm assuming you're an associate professor or an assistant professor at the moment. So to your next stage of career development, what are the 3 barriers? Don't worry, I'm going to be less brutal with you. You're going to just name the 3 barriers. I'm going to get somebody else to talk about it.
I don't think I've faced too many barriers as such in terms of my career progression. I think I've been at a place which is much more conducive environment. And yeah, so I don't think I faced so many barriers in my academic this. The barriers that I've faced are more when I have set up my own startup as an entrepreneur. The assumptions that come with, a lot of people walking into the company, assuming that there will be a man leading it and there will be a man taking the decisions, and they don't want to talk to you about, I think that has been the guiding stereotyping, and those are the kind of barriers
So
that
how do you
have to
deal with
overcome.
it?
Yeah, you just ignore those and you just walk in and say
Give
that
them this
I am the
meme
one.
next
Yes.
time. Give them this meme next time. So, okay, I think the other side is really missing me. Does somebody want to volunteer? Because she's given us one reason there. You want to speak? Oh, lovely. Please give her a mic.
Ma'am,
Once again, who's going to take the notes?
Ma'am, I will take the notes of mine.
Okay, thank you.
Okay. So, ma'am, there is a perception that men are more intelligent than women. And because of their children, they will not be able to meet funding deadlines and do not be very much active in the research. So, my point is this, like, is it true or false? Like, I don't believe in this. I want to know about the professors, like how they deal with this, because it happens in our society that women are considered less intelligent than men.
All right. Okay, we have somebody here who wants to answer that.
So I don't want to answer, I'm not going to answer that question, but I would agree with her that actually this is from the school level. So we have to go back and we have to look how we are raising our children and how is the environment at the school. So because I feel that there is a gendered-based perception of intellect, that boys are better in maths and science as compared to girls. So if we look at India, so we have around 11% colleges dedicated to women only, but those are for arts and commerce, and we do not offer science in those colleges. So why it is so? So this is at a very basic level. We have to go back and we have to break these barriers from the school level. So teachers and parents has to tell the girls that they are equally intelligent, and there is nothing like boys are more intelligent in certain subjects and women are more suitable for certain areas or professions.
Well, actually, I'll just come in here for a minute. So if you look at various studies, even the national statistics that comes out of our government, the educational outcomes for girls far outdoes that of boys. Be it your pass percentages, the number of school enrollments, they're quite high for girls, the dropout rates are higher for boys. Now, what's basically happening is, I think I spoke to somebody this morning, we have an inverse pyramid sort of a situation here. When you're at school and undergrad level, you've got lots of girls, especially in science, and then you come to your postgrad, that number is it's reduced more than half. And then as you keep progressing, it just keeps getting narrower and narrower. So as you go higher up the ladder, you have fewer women. So what is making them drop out? And also another really interesting thing, which Khushbu and I were discussing, just outside here, was it's not just RSC. There's also other journals who've done a lot of studies on submission of manuscripts. So apparently, of all manuscripts that are submitted, out of every 100, only 17 are from women. Now, nobody really has an answer. And then when I go around asking questions, the only conclusion I seem to draw from the responses I get is that men take more risks, women don't. So if a journal says, I have 10 criterias that you have to meet before you submit a manuscript, men, if they tick at least 2 boxes, they're going to just take the risk and submit it any which ways. They don't mind the rejection. You go to a female researcher, she'll say, you know what, I only have ticked 9 boxes, one more. I mean, what is this? I don't quite get it. So how many researchers here, I'm talking about you women, how many of you do this? Please be honest with me. Can I please say, there we go. We have one honest person. Come on, I'm sure we've got more honest people here. We've got more. So do you want to tell us, ma'am?
I said never. I said never. I don't do it.
You don't do that. She's an exception.
One box, okay.
One box,
You can
okay.
reject, yeah,
I
can
think you need to
reject,
give me a
can
high
reject.
five. Thank you.
But I will not submit it.
Can we have a mic here? I am so sorry. I'm just coming to you just after this. Do you want to tell us why that is and how do you overcome that?
So I've been teaching for a long time and in many countries, and I really see a difference in self-confidence in boys and girls, men and women. I don't understand where it comes from, but I have seen that, for example, if a woman does badly on a test, she will say, oh, I'm so stupid. I'm not good enough for this class. I'm not good enough for this course. I think I'm going to drop out. Whereas if a boy does badly on the same test, he'll come and fight and say, you didn't correct me properly. That question was not in the syllabus. This test was too hard. I mean, I've seen this happen so much. And I don't know why women are so self-critical. I think it comes from our society that women are, first of all, I think there are two things. One is we're criticized a lot. And also, I think the message society gives us is that our role in life is to make other people happy, not to make ourselves happy. And men are not given that message. So I think there's something going on there, and it seems to be across cultures. But I want to say a couple more things. What really resonated with what Alejandra said was she said this importance of belonging. And I think that's very important. I think women are very much in the minority in many science departments, and they are made to feel that they don't belong. And this happens to me even today. I'm very senior. I think I've proved myself. But every now and then a situation crops up where I'm made to feel I don't belong. So early in my career, the men would all go out drinking after work. And that was important for science because they make collaborations, they give each other advice, and they would never call me. And once I asked, can I go along? And they said no. And I said, what do you mean no? Why can't I come? And they said, a decent woman wouldn't come where we're going. So I don't know. And 25 years later, I've really worked at establishing good connections with my colleagues. I think they're friends. So they asked me to go with them. They were going drinking 2 weeks ago. We were all standing around chatting, and then they decided to sit to eat. And many of them said, Shobna, why don't you sit here? They pointed to a table at one end, a chair at one end. I sat, and then they all went and sat at the other end, leaving me all alone. And I was so discouraged. I thought, what is this, you know? I mean, how much longer do I have to put up with this nonsense? And I think this is the experience of many women. And it is, if you feel you don't belong, then you're going to drop out.
Completely understand. I come from life sciences. It's the opposite for us. The poor men are in the minority and we're always bullying them. So this is new to me. Neetu, you had a point, but thank you very much for that, ma'am. You just wanted to say the same thing. Does anybody want to add on? Ma'am, I think both of you had raised your hands.
That was about the fear of sending out the manuscript. Actually, we, three of us, we come from a women university. So we are from a place where we're all women all over. be it the professors or the students or the scholars. So, we are facing a absolutely different scenario there. And I think people who think that women are not being treated equally or not being respected enough or are being judged, please do come to Jaipur and visit the IIS deemed to be university, because that is one place where women are being given ample opportunity to do whatever we want to do. For example, it was just Sunday evening when I decided to come here, and my boss said, yeah, fine, go. That's fine. You can go and see what's going on there. So, I think things are changing. Things are evolving, of course, at their own pace. But all of us are from science. I'm from life science, ma'am. Both of them are from chemical world. But be it any field of science, what we are witnessing right now is the rate is slow, but of course, things are evolving. People are changing their mindset in the professional world. What has to be taken care of is a society where our personal lives, because we are being treated with a lot of respect when it comes to our workplaces. But I think back home, the scene is absolutely opposite. It is just the same everywhere, because again, once we are at home, we are not scientists and researchers anymore. We are housewives. So I think the society needs to change. The workplace is changing rapidly. So yeah.
I just hold that thought. I'm going to come back to you in the next session because all women's university need it. So we've just teased out a couple of points here. We had a point about lack of mentorship, or rather the power of mentorship and how it could inspire women to progress in their career. Sorry, did you want to say something? No, please give her the mic. I was just rounding up this particular.
Yeah, so hi, I'm Manjusha from NCL Pune. So I just share a couple of experiences, and I would suggest that don't be crybaby and don't be like wallow in self-pity. You be assertive about what you want and what you, you be assertive about your rights. So I'll tell you two experiences. First is when I have given my interview at CSIR NCL. So it was all mains committee. I think there are 10 experts, all were men. And my child was with me. He was 1.5 years old. So he was playing outside. So one of the committee member at the end of interview asked me that how you are going to manage your toddler when your husband, my husband was working in Bhopal at that time. Okay. So I just told them, I felt that they would not ask this question to a man. So why they are asking me? So I just told them that I thought about everything before applying for the post. So it's my problem. It's not your problem. So there will not be any compromise on what you are expecting from me as a professional. So after giving that answer, I felt that I will not be selected, but I was selected. So don't be afraid of giving the answer that you think is right. Okay. So I was selected in NCL, and later, after a few years, so a lot of couples were being hired in NCL. Okay, Neetu is there. Okay, so my husband was already having a job. He was a professor in Bhopal University. So I also asked to NCL's, the then director, that a lot of couples are being hired. Why not you consider my husband also, because we are living separately. So he told me, no, Manjusha, so those guys, like he took some of my colleagues' name, they are important for NCL, so that's why their wives are hired. Okay, so I said, does that mean that I'm not important for NCL? He said, no, you are important, but you should go to your husband's university, and instead of hiring him here, you can migrate to his city. So then I decided, that time I was really thinking of migrating to Bhopal, because Bhopal is also having CSR lab. But when he said that, I have decided that no, I will not go back. I'll stay in NCL, and then now I am having my own startup, and I have hired my husband as CEO of that startup. Okay. So I really liked when I told this to Neetu yesterday when we were coming from airport. She said, this is really woman empowerment. And then I also realized, yes, this is empowerment, that if you don't employ to my husband, I'll create a job for him. So I would say, don't wallow in a self-pity. That's what I would say, unless you tell people, they will not change their mind, okay? So it will take time slowly, but be assertive about your rights. Yeah.
So it doesn't seem to be a real chemistry problem. It's more the patriarchy in the society. So any other points before we move on to the next bit? So we've spoken a little bit about self-criticism. Yes. Mentorship.
I just want to say one thing very quickly. I think she's right when she tells women to be assertive, but I think there is a problem here, which is if women are soft-spoken, people just stomp all over them. But if you do become assertive, then they resent you and say you're too aggressive. And it's very hard for a woman to find the balance. I think if a man is assertive, it's seen as a positive quality. But if a woman is assertive, it's often seen as a negative quality.
I'd also, take another claim to that. So I think we aim for too much perfection. Like you want that degree of angle, you're placing a pen on a table, it has to be at right angle to something and acute angle to something else. We go too much into those details. I don't think men do that. They're like, okay, there's a pen, fine, I'm going to use it someday. Let it just sit there, let it gather dust. And they just go ahead with it, right? So I think it's not even about self-criticism or being self-critical, but more about we're just striving for too much excellence because we're used to being criticized. It's not self-inflicted, but more the society. And that's probably what Shobna was also trying to say in the first half. I think you wanted to speak? Yes.
Okay, so basically you were asking what are the barriers basically which we like stop us from succeeding in our career. So I would like to say the safety issue is one of the barrier because like I work in AIMS and I go around 2 to 3 a.m. to my home. But at my parents are living in Allahabad. To them I say around 9 I call them and I tell them that I have reached home. Because if they'll know I'm working till 2 or 3 a.m., obviously they won't allow me just because of safety issues. So
How many of us have done this? I've definitely done this. I've slept in the lab and not told my parents. And I've often wondered why I paid rent. London was so expensive. And I'm like, why am I paying rent? I'm going to live in the university. Just get a sleeping bag. So safety, yeah, that's a really important issue. Other than, it's not just safety of outside of your uni. How many women here feel unsafe inside university spaces? Bullying, discrimination. I don't, I was hoping somebody would pick that up. Harassment, bullying, and discrimination is a conversation we don't have in India, but it's very important. Subtle remarks, especially when you have a male supervisor and a female student. I've had several complaints. People say there were subtle remarks, inappropriate comments, body language that's inappropriate. Anybody's face, anybody wants to talk about an experience that they've heard of. I know it's a difficult topic, or you could just come and talk to me later. It's totally fine. Is there anything else anybody wants to add? Cool. We'll go to the next slide. Okay, you can always come back and talk to me about any of these issues. This pin drop silence is not good, especially when it is about bullying and harassment, because if you don't speak up, and you know what, men get harassed too. I probably am guilty of harassing my classmate when I was in 7th standard because I beat him up, but I've changed since. And the criminality of it has lapsed, so please don't take that into record. But all of us do things unconsciously, and a lot of times people who bully or harass don't really realize they're doing it. So speak up about it, because that's when we can go and address the issue. It's a behavioral change, it's not a personality disorder. All right, so I'm going to move on to something more cheerful, which is about the current opportunities and challenges. I know there's wonderful things happening. There's this all-women's university. I really want to visit that place, although I wouldn't go there because it's too much competition. There's like too many perfectionists in one place, and I don't, I'd rather be in a place of imperfection. Chaotic is my thing. So can any of you talk about some good practices, something that something that's out of the box, something that's unique to your lab or unique to your department, unique to your place, that's worked? Or if you can go to the next slide, again, my favorite cartoon, or something that you think is really important, but it's actually counterproductive. So I just like this cartoon because they did put on the sunscreen, but that's not going to stop them from popping. So you can bring in institutional changes, but that doesn't mean women are empowered. It looks like they're empowered. So you bring in, let's say we bring in a fellowship tomorrow. It's going to just benefit one girl, right? What about the rest? How are we going to address this as a whole? So does anybody want to? I think we could start with the All Women's University. One of the 3 charming women who want to. Any good practices, anywhere you find loopholes, gaps?
When you actually was saying that you would not want to come to the university because of the perfection, I was actually thinking she's right. Because, women have this, this knack of getting everything right, to park the pen absolutely perpendicular and to something and, in some other position, we are like that, yes. You just got me thinking, and I just realized in the past few years, we actually want to get everything right. When I'm having my meal, even at work, I want to have my spoon right. If my student is not holding the pipette, I want to kill her right there. So you're absolutely right. We women have this problem of being perfectionists, and in that struggle of getting everything right, we become so stressed. We are also stressed and barking at each other. The timeline, deadline stresses. Again, somebody said the funding stress, the budget stress. All of those things, I think they linger on more in our heads than men. So I have, yes, witnessed that stress in the university, at work, because again, in the objective of getting everything right, perfect, we do get stressed. Yes, that happens.
Can somebody talk about any good practices they've come across, they've implemented, anything that you did and you felt like this actually made a change? Yes, can you pass the mic on to her? And then after that to Ritu is.
I think that something that's helped me a lot in previous institutions that I've been at has kind of been having outside sources of support from the lab I'm in. So for example, kind of going back to your question about bullying, one time I was doing an internship and my PI was bullying me really badly and it was a really bad experience. But I was able to get support outside of the lab, and like the school had like a very, very accessible office for diversity and inclusion that made a very big effort to make sure that like every single student knew who they were and that they were accessible. And so having a support system that's just like detached from your work atmosphere a little bit was very beneficial to me, at least.
Does anybody have a peer-to-peer support group in an Indian university? I think that's probably not an Indian university, right? You're talking about student officers. So yeah, it's not Indian. So anything in India. So I do agree with that point about peer-to-peer mentoring. Yes, please.
Hi, I'm Namrita from CDRI. I just have a point. Before this good practices, I would like to say one thing. When we say that we women are perfectionists, there is another term I would use. For like a lot of things, what this young lady said, that why everybody believes that we are not intelligent enough. Then somebody else mentioned that if you are assertive, then you will be labeled aggressive. If you're soft-spoken, then you will be labeled. My question is that are we women alone to be labeled? Everybody keeps labeling everybody. We even talk about men. He is assertive, he is stupid, he is intelligent. Why do you keep why we seek approval from the same society or from everybody? Stop seeking approval. So long as it is not illegal, it is not made illegal to be assertive, let them say you are assertive. How does it matter? Why do you want to be labeled, Namrata is polite? You call me assertive, doesn't matter. You may be calling me assertive, she may be calling me sweet. How does it matter? Why should I seek approval? Isn't it most often when you talk about barriers, especially for the young girls, what I would like to convey that the biggest barrier for anybody, man or a woman, is your own conviction, right? You yourself. And most often than not, what happens is that we find as a human person, as a human, everybody, man or women, we try to find an excuse for our failures or for losing on to something. So it's my favorite phrase. I always say it's more often than not, it's convenience over conviction. Probably your convictions were not strong enough. Okay, and nobody wants to lose. Nobody wants to say or admit that, okay, I lost, I failed. Right? So you say that, okay, society wanted me to do that. Somebody pointed out that I'm not good enough. You carry on. As long as it is not illegal to be assertive, it is not illegal to be soft-spoken, because we are putting too much pressure on men. I'm sorry. Men here cannot say that.
The heat. I think Professor Mishra is feeling the heat.
No,
somebody turn the air
men
conditioner
cannot
on.
say all this because they are under such immense pressure of being politically correct. I can say that.
No, but with Professor Mishra, it's very unique. He probably will explain to you why. He goes from being Professor Anil to Professor Anila, so he's
I fully agree with Namrata, what she has just conveyed to us. Even in the previous slides, that when you were showing about that the man, when you would drive and then the look is different. I'm one of the very luckiest person in my life that my instructor in California, she taught me how to do the driving and also instructor to pass the exam. Even in the lab, whenever I write any manuscript, I give to my colleagues. They are mostly women, and they correct it, and then I accept it, and then I submit it. So I'm a very lucky person that in my lifetime, I have learned a lot from them. At any moment, you talk about any phases of life. So they were really a guide, you can say, in many, many terms, which is beyond imagination. Either I cannot explain it. Even being a director, whenever they come, only what I say to them, like Namrata was saying that, don't expose your weakness. Don't use that I'm a woman and then somebody is going to do something and this. Be strong and they give a befitting reply in a nice way and they will understand it. So I really...
Question for you. Everybody takes advantage of women, so why don't we take advantage of ourselves, right? Why let somebody else take it?
The point what I wanted to say here is like,
I'm
for
just pulling your
example,
legs.
yeah. So what I wanted to make, the point which I wanted to make out is,
don't look for
it's like
validation externally.
I'm sorry.
There's a fly on it. It's fine. Yeah.
It's okay not to be good driver. Everybody cannot be. Okay. There's another stereotype, like everybody is all hunky-dory gaga. If there is a man cooking who is good at cooking, why? Fine, you are good at cooking. Like, for example, I admit I am very bad at finances. My sister-in-law is good at finances. I'm good at cooking. I'm very good at driving. My brother is not good at driving. Why do we ourselves are emphasizing these stereotypes? Are we trying to break some stereotypes by creating other stereotypes? Don't do that. That's my point. And coming to the good practices, just a little example I want to give. In chemistry department in CDRI, we have only 3 women scientists. But in biology, we have a lot of women scientists. And more often than not, it happens that the lab meetings, we have a childcare facility in the campus. And almost everybody's kids are living in that. But a lot of times, meetings go beyond 6 o'clock. So some of us, even me, I don't have a child or anybody, but I'm very good with kids. So I've taken this as a responsibility for few of my colleagues. Not only me, like 3, 4 of us, we have a group sort of thing. So sometimes if a meeting is going on for late, I would personally go to, and this is not between me and another female colleague. In fact, I have a male colleague also. His wife is working. He has 3 kids. 1 kid is a special child. So we have this understanding between us that, okay, if a meeting is going beyond 6 and the childcare facility has to, close down, I would go to his house and babysit for a couple of hours. That I have done for a male colleague as well as for a female colleague. We often see that missing, that kind of comradeship missing between women's also. So it is not that only men are torturing us. It's not. So that is one practice which I feel should be there. I mean, that has helped a lot in the campus, I would say.
Do we have childcare policies in the all women? Okay. So how many other universities actually have that? Yes, Neetu.
Actually, I wanted to make 2 points. One was about good practices. I'll talk about it in a little bit. But one was about this, I feel like we try to listen to the society a lot. We try to, nobody tells us that women are not intelligent. I think it's there in our movies because probably it appeals to the masses. We have all kind of songs which tells that, women is supposed to do this and that. But if you don't listen to those things, and if you just live the way, just the way you want, I think we can get rid of it. And I'll give you a small example of when I was in the US, I told you that I had my baby really young and I was looking for jobs and my daughter was 9-month old. Of course, there was no Indian society there. So I was just me and my husband and the daughter. And I had to go for my job interview, which was somewhere away from my place. And I had to stay there for 2 nights, okay? It was a 9-month-old baby. So I was, of course, feeding. So there was a lot of other issues. I figured it out. And I left my daughter with my husband and left for 2 days without asking my husband or my parents or anyone. I just did it, When I came back, I called my mom and I told her that this is what I've done, and the interview went well and all that. She was like, "What? You left your 9 month?" She didn't ask me about my interview. You left your 9-month-old baby. I said, "Yeah. What's wrong with that? What's so special?" Then when I moved to India and I had my second child here in India, I mean, I was given all kind of advices, that this is what you're supposed to do. Oh, you don't leave your son like this, and but because I had done it the first time, all wrong things according to Indian society, I was very comfortable doing it again. And I mean, that inspired a lot of people. So women are also known to be very meticulous. Women are also known, there are memes where there is a clean table and a bad table, and they say which one is a woman. So why are we not proud of that? I mean, why are we just looking at that we are called not very intelligent, not driving? I think we should just get rid of these things that the society tells us or the movies tells us. I don't think men think too much about these things. And I mean, they don't, yeah.
Drop the pen there and let it gather dust. You
Exactly.
just use it when you need
So,
to use it.
so this was, I think we should move out of all that. But the other thing about good practices is in IT Delhi, we have recently, there are a lot of complaints about sexual harassment and other things. And you just talked about it. There was a pin drop silence. And the same thing happens there also. What we've done is every time we get these cases, of course, to go to the ICC, it's a bigger thing. But many times the students come to us and tell us that this is what has happened, maybe subtle things, And we would like to, we then counsel the male colleague or whatever, or the students also. Many times they told us that, oh, is it? I was not supposed to do this. I was not supposed to do that. They're not aware, So we don't teach this to our kids, I mean, we don't teach this to our kids. Parents don't teach this to their kids. No school teaches this, that this is how you're supposed to behave at workplace. No college has any education. We have sex education, but we do not have education about how to, behave in a professional setting, When you're talking to a supervisor and the student is talking, you're not supposed to close the room. When I went to do my PhD, I was given a talk, a proper session on how the professor is supposed to behave with me, how I'm supposed to behave with the students and the colleagues and everything, right? We don't have that here. So when we listen to a lot of students, we ask, why did you do this? But what was wrong in that? I mean, we're just friends, So we realized that the boundaries were not there. So what we did was, we created this, I don't know how many of you have taken safety modules when you are doing, if you visited a foreign university, before you start working in the lab, there is like a 10, 30, 15-minute video which you just watch and click, and there is a questionnaire at the end of it, which seems very stupid. How would you store an acid? How would you throw and things like that? But unless you clear that, you will not be allowed to work in the lab. So that's a very, it seems very boring and useless, but probably it helped in keeping a lot of things safe in the other countries. We did the same thing with sexual harassment. What we've created at IT Delhi is modules for students, for faculty, and for staff. Because remember, one thing for everyone will not, because the scenario that a female faculty or a male faculty will be in with the supervisor and supervising and other things will be different from what a staff feels. Maybe the security personnel, or maybe the janitors, they will have a different scenario. So we created 3 different modules for students, staff, and faculty. We asked them to watch this video. And this video literally showed, what are the situations you can be in, what you're supposed to do, what is harassment, what is not harassment, what you're supposed to, where you're supposed to complain, how you're supposed to talk, and things like that. And after that video, they all give a questionnaire, and you have to get a 70% score on that to actually continue to work. And we have this every 6 months. And then we asked everyone to sign off. So this also has legal reasons, because then in the court, you can't act innocent and say, well, I didn't know that I'm not supposed to write a poetry and send it to my colleague midnight, something like that. So we have taken those measures. And just doing this, people have started talking about it. They're scared. So, and they basically, why do we sign? What have we done wrong? We said, nobody has done anything wrong. When you're signing off the safety certificate, when you're getting the safety certificate, you have not blasted the lab. So, I mean, but you still do it, right? So why are you complaining about this? So that is a practice which we have started. And we have started another unit which is separate from the ICC, because ICC is always considered as, something very big, talking about harassment, and maybe there is a case. But now we have something called as a gender initiative unit, where we just have counselors, we have students whom you can talk to and all that. So those are small steps which we have started taking. And I feel this, our institute might be one of the few in India to have, IT Bombay has introduced this, and IT Delhi, we were all working together at the same time, and we've introduced this too. I'm not sure about other IITs, but that's something which, other universities can also look into, and maybe that will start everyone talking about, maybe some sort of a teaching to the kids. Yeah.
No, so the signing off part is really interesting because I think other people could probably at least signing off, because tomorrow legally you can't indemnify yourself. So that's really good. But just a quick point on that, we had this at King's College London as well. But then we did something really smart.
This DST Gati, UCL has been a pioneer in women and gender issues,
Well,
right?
actually, it was started off by UCL, and then everybody it's a golden pyramid, and everybody picks up. Yeah. But then here's the issue. So we did the same thing. This chemicals survey that you spoke about. So we go click, 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 and then at the end of it, you sign. You don't see anything. You don't see what's hazard. Actually, you know what? I have a lot of students who come into the lab. They see a sign and they don't know what that sign actually means. It could be a radioactive substance. They have no idea. So the same thing was happening with our sexual harassment survey. People were just signing it off, but they had no clue what was in it. So where do you bring in the accountability? And more importantly, what do you do?
At the end of it, there is a quiz, which, as I said, and we tell them in the beginning itself that 70%, so they all are scared that, okay, what is going to come? We don't.
But then that's exactly what I'm saying. The college undertook a survey. People got the right answers. So if we were supposed to score them out of 100, they got 100 out of 100 on the quiz.
Right, but I think it'll take
But
some time.
behaviorally,
right, so it'll
yes.
take time. So we are looking at changing these questionnaires every 2 years.
No, I think it's a great initiative. I'm not saying no.
But we've thought about these things because another students, the BTech students will trick it. They will in fact put someone else and ask them, ki, you fill it, on my behalf. So we've thought about all of this and we are working on that.
So I think it's a great initiative. Any other examples? Can we have the mic here?
Yeah, so coming back to sexual harassment, so I would share an incident which happened with one of my friend at University of Delhi. So according to her, she was harassed by her supervisor, and then everybody comes to know about it. But then after few days, we see that everything is back to normal, and she had to leave the university, and she actually went to other university, but nothing happened to the supervisor. So there was no complaint, and nothing happened. So we should have strict policies for sexual harassment. This is very important. And we should see some result. Otherwise, we see that, okay, some committee is set up, and then there were talks, and we think that, okay, something will happen, but then nothing happens. So that needs to change.
Yeah, fair. That's, again, it just feeds back into the same point about actually having something on ground. Yes.
We don't have an exam at the end, but we do an orientation for all incoming students about sexual harassment. And I've been there, and they don't look bored or anything. They do seem engaged. They do ask questions. And I think it does help.
It does help. All right. Okay, so I have a question because most of you are chemists, other than the two of us, I suppose. Why is it that I do see a lot of career progression for women in life sciences? Is that only because of sheer numbers? Because we obviously have an overwhelming presence. Why can the same not be true of chemistry? So if I were to normalize the number of women in chemistry and life sciences, even then we see that the progression is slower for chemists as compared to life scientists. So can we tease out some of those important points which is holding back female chemists? Anybody on that? I personally feel in life sciences, there are too many role models. So I feel inspired. Everywhere I turn around, I have like at least 10 people who've done it. They've broken the social barriers. They have a very balanced professional and personal lives. So I think that really helps for a life scientist, especially for a girl going into life sciences. And then the other thing is, it's traditionally seen as a girl thing. Although I'm not really sure if it is, because we do lift a lot of heavy machinery. A lot of my gymming happens in the lab. So again, that's a stereotype, right? So what is it that's going wrong in chemistry?
So I think in chemistry, there are not many women at the top level. What happens is that every academics also has a lot of committees and a lot of other things that controls the decision-making bodies, you can call them. In life sciences, because we have more women and more successful women, and just because of the percentage. In chemistry, that is not there. So you will have find maybe one woman in like a, some committee, and as Sangeeta ji mentioned, it's always one woman in one of the committees, right? So
what's the
point is that there's no one to advocate for or think about, because see, all those men, they're sitting there, they don't see a problem. I mean, they will say they want to do something for women empowerment, as I mentioned earlier. Sorry, but as
we're just putting the heat back up on Professor Mishra. That's not fair. That's not fair. Poor man.
Like, think about it. Women's Day, it's always women celebrating Women's Day. Have you ever heard of a surprise party in any institution for women on a Women's Day? It's bunch of, maybe aggressive women, we call them, coming together and putting up a panel discussion, putting up a town hall, putting up something like that, completely organized by women, heard by women. The hall will be full of women. Why? Why? You call your colleagues and, hey, you coming for this panel discussion? Acha, wo women wala? Acha, I have a meeting. Sorry, I have a meeting, I was planning to come, but, something came up. And
There's
then
a solution. Tell them we'll give you certificates.
No, but
I had more men in that meeting than women.
Come. Because see, the thing is that they want to do something about it, but they're not addressing the real problems. And at the top level, it is the problem. Because unless you have women sitting there, at least 4 or 5 of them, one woman is not going to make it, because nobody is going to listen to her. And she told us how they are asked. Nobody's going to listen. They will say, oh, yes, they're absolutely correct. Very good point. Gone. At the end of the day, it's just going to be in the minutes of the meeting, right?
So in interest of time, I'm going to quickly move on to the next question. I agree with that. My problem here is, okay, we want men to advocate for us. Fair enough. They will do it. I think agreed. So we're not really teasing out the problem, because we've had this town hall for we've had 1, 2, 3, 4 speakers, but there's way more than 4 people in this room. We still aren't speaking up. That's my problem. So I can't say let's put women on the top by creating reservations, because then you're just killing meritocracy. So how do we get these women to get to the top on their own merit, without waiting for other men and women to come and tap on their shoulders and say, please get going, or literally give it to them on a platter? So any ideas for that? Anybody has any solutions? Because we're looking at it futuristically. Can we get a mic there, please? Because the more reservations you bring in, exactly, because you're going to get people who are not meritorious in those positions just to fill it. Absolutely, yes.
So yeah, what I personally believe is just having discussions is not enough. Like whosoever, as being a woman, whosoever is having a seat at the table, it is their responsibility to bring changes in the grassroots levels of the society. Because I'll share one of my experiences. Like recently on National Science Day, we visit some of the rural areas for organizing an event, and there the students from government schools came. So most of the majority were girl student. So I asked them that what you want to do in career in future. So what they said was they want to pursue science as their career, but the problem was that they didn't had the facility to go to the places nearby, or the school, or those subjects were not there at those places. If they talked about boys as a student, they could go or they could do whatever they want to. So it was easy for boys to pursue that career. So these things actually are our problem in the grassroots levels. And the mindset, if we talk about at the literally root levels, is the mindset of the people, and they don't really want girls to go out to take science as a subject and do good or whatever they want to pursue. So things are comparatively easier for boys at the root levels as compared to that for girls. So I think that we as women, whosoever get position at any place, like even as a student, if you are if you are a 12th standard student or a graduation student, what you can do is you can help whosoever are there in the lower levels. You can guide them, you can provide mentoring to them. This will help to broaden the mindset, or at least to come out of the barriers which they have created, or to break the stereotypes which are already present in the society. So I think that we as women should help the ones which are not literally being able to come out of the box in which they are, or the four walls in which they are currently living. So I think we should contribute to that in every possible way. Thank you.
Fair enough. Anybody else? So we've got...
Yeah, I would like to add.
Sure.
Yeah. So my take on to the less women into the chemistry, more into the life sciences, I think it's all the stereotype which exist in the society at the grassroots level. Like we tell our kids, boys to do engineering and girls to become doctor. And if they don't end up becoming a doctor, they go to life sciences, taking BSc biology, biochemistry, or something like this. So if the supply is less, the output will be less only. So for the life sciences, supply is good. So we have more women at top level. So for the women, the choice becomes first life sciences, then chemistry, then physics. And even if you talk in engineering, like going down, if you go to the mechanical engineering, the supply will be very less. So it depends a lot on to the stereotypes. So if we, at the grassroots level, if we create awareness amongst parents also, that's also is very much important. Like one of the program of DST, this Vigyan Jyoti, which is very good program. It's not only giving an ecosystem to the girls, it's also doing like counseling of the parents of those girls. So that's very important. We have to take the society hand in hand so that the girls get that ecosystem and, to flourish and to realize their dreams.
Okay. Yes, please. Absolutely. We're taking off the heat from Professor Mishra and passing it on to Professor Dhawan.
आप डांट खा चुके क्या? Okay, good. So I think taking on what she said, and I'd just like to mention that people who are somewhere, anywhere, I would say, not necessarily at the as a head of the institution. I mean, I'll just give two very small examples, and it so happened that I was at that point in time head of the institute. But there are two instances where, so we have a program called Jigyasa in CSIR, where class 10 to 12 students, or maybe earlier than that, they come and visit the institute with their parents at some point in time. So, parents along with their only child, who's a daughter, they came to my office and they said, we want to talk to you after she visited the institute. And she was in class 10 at that time. She said that, I was I'm not sure whether I want to take science or not. So I said, can I talk to her first? Yeah, go ahead. So I said, is it under pressure of your parents that you don't want to take science, or is it because you don't like science? She said, I love physics. And what is it bothering you? So it said, my teachers are not good. So I said, change the school. Why change your, if you have love for physics, why don't you change the school? Or you take tuitions and you ensure that you get good quality teachers to teach you. Then I asked the parents, what do you want? He said, well, whatever she wants to do. This is the only child we have, and we like her to do whatever she wants. We had about an hour's chat, and then I said, well, I've given you everything that it takes. I painted the entire collage in front of her. What is in it for her to pursue science and how she can flourish in life, etc. Then they went back. She will decide. And 5 minutes later, she came back to my office. Sir, can I speak to you for a minute? I said, yes. I've taken a decision. I'm going to pursue science. And she did. And she's now in England right now, as we speak. The second girl came in, again, the only child of her parents. And she wanted to pursue chemistry as a major. And the parents were not ready to send her abroad. So they had come through somebody's connection. They came to me to discuss, and they said, "Saab, विदेश में कैसे भेज दें? बताइए, इकलौती लड़की मैं US में भेज दूं after intermediate, it's not possible." तो मैंने कहा, भाई आपको जो संस्कार देने थे आपने दे दिए. I think you should trust her. जाने दीजिए उसको, क्या है. बात होती थी तो हमने कहा ऐसा है उसको. She had to do some work before she can apply into foreign universities. So we allowed her to work during COVID times on a in silico facility where she could do from modeling of chemicals, etc. She worked for about 15 days. She could write a SOP, and then she started applying. She got through Cornell, and then she got full fellowship through Tata, which is equivalent to about $84,000 per annum for 5 years. She's currently pursuing her 3rd years in undergrad. So now she's from chemistry. She's going to shift to chemical engineering, she said, abhi aayi thi, Lucknow. So I think what she's saying is very correct. If you can just sort of slightly nudge them. There was another instance where that time I was in Ahmedabad and there were people from engineering, Olin College of Engineering, where students from the US had come and they were on a project together with students from our institute, and there was a topper of our life sciences MSc first year, and she wanted to be part of that group. But her grandmother didn't allow. She couldn't, she can't go out like this with boys. So it took me almost 3 to 4 days. Her mother came in, her father came in, the grandmother came in, we all had discussions. But when she actually went out and came back, she said she's a changed girl now. So I think we are very happy that you persuaded us to allow her to go. So I think it's incumbent on us, wherever we are, whoever we are, irrespective whether we are, males or females, it doesn't matter. As long as the pursuit of excellence or the pursuit that the child wants is encouraged, I think that is what should matter. I think the point she makes is very pertinent, because that's how it happens in the society. I mean, it'll take time for the society to change, but I think as and when we get this opportunity, we should definitely push. So
Agreed. Yeah. Thank you so much.
Just add quickly to that.
Yes.
Yeah, so I mean, as we are coming towards the end, I just wanted to add to that, like we say, charity begins at home. I just wanted to speak from my personal experiences. So I am by profession a mechanical engineer. I'm a faculty in the mechanical engineering department. When I was a kid, like 2 to 3 years old, when I had no idea about what is considered to be a boy's task, that was a time when I was introduced to tabla. I play tabla. I am a national level gold medalist in tabla, which is considered to be a boy's task. I have played martial arts. I am a taekwondo state level winner. And I was introduced to these things by my parents at a time when I had no clue about what is, made for girls and made for boys. So I think I mean, we have done a lot of bashing to the men here. And I agree to each one of you. I mean, from all of your personal experiences, I appreciate all of your opinions. But at some point, I think we should also thank men, because there are men like my father. And I'm sure there are many men like that out there who are still supportive and who are creating small changes. And all those small changes probably will add up, and then we can see a big change, big impact at the end of the day. So that has helped me a lot. And professionally, so far, I don't think I have faced very big discrimination as such. There could be some subtle remarks. I won't deny that. But probably because of the upbringing that has been given to me, I was not, it could not uproot me from what I plan to do. So I think, yeah, so that's my personal opinion. Right.
Thank you so much for that. We'll just wrap this up.
Right. So.
Thank you so much for that. So if there's anything, so before I say anything else, there's a lot of us here who are quite confident. There's a lot of us who've taken the bashings. We've, swum against the tide. We've made it big. But I think whether men or women, we're supposed to be talking for those who can't stand up for themselves, for whatever reasons. So Shruti and I probably had a really good environment at home. So, just like how you learned tabla and all that, I was not such a good kid. You've heard of mass killers and mass whatever, killers, kissers, Imran Hashmi, whatever. I'm a mass bunker. I never had more than 20% attendance at school. I've jumped every wall of every school that I've been in. I've been to 3 different schools. I've been punished the most number of times. I used to love going to the principal's office because there was a stint when I was in Delhi and then in Chennai and it was so hot. I just did mischief so that I could be in the principal's office and sit and enjoy the AC. So that was just me. And then nobody would believe that this girl would end up doing a PhD on a full scholarship. It happens. And then when I graduated from King's, so when I just a month before I graduated, the principal had my picture up the wall. So we have a little wall of fame. So my dad said, all that climbing you did all these years up the tree, up the classroom wall, this is the best of them. So it happens, right? But then we have to speak up for those who really can't, because not everybody has the same privilege as us. So if there's anything you want to talk about, and all points well noted, some of them work, some of them don't work, but the important thing is that we try. Anything else you want to talk about, please do come and see me just after. If there's something confidential, happy to talk about it. If you think it'll help with the report, please do help. And at the end of the day, the men here, especially Professor Mishra, I've been targeting him all evening. Really like you so much, really respect you. I keep saying I don't use my surname. So I ended up adding my dad's name as my last name. So no, I'm not Dr. Shweta, I'm Dr. Raghavan. So my dad keeps saying the effort is yours, but the credit is mine. So the effort is ours, but then we should not forget to thank the men who are behind us. Because in a patriarchal society, if some of us have made it, it's honestly because you've got those men pushing you from behind. So don't forget that. It's not about bashing somebody. It's just about walking ahead hand in hand. Right? Thank you so much. And do find me outside if you want to add something.
Thank you so much, Shweta, for this exciting and exhilarating theme for today. So I now request our convener, Dr. Ritu Gupta, to felicitate Dr. Shweta Raghavan with a memento. Thank you so much. That was a really interesting session. Next, we will have this group photography. I request all of you, all of the audience, to proceed to the brain tree. There is a golden brain tree, and the volunteers will guide you there. So we will proceed now for the group photograph directly, after which you will get a short tour of the campus. Yes.
So I have just few more announcements for students who are presenting posters. So your posters are still there. If anyone has missed out, you can have a look. But before we will go for that group photograph, and then please remove your posters before you go for the cultural program. We will have the cultural program at Director's Lawn, and that will be starting at sharply 7. So after the group photograph, you will have some time for touring the campus, but please come back in the garden for the cultural program plus the dinner. Okay, so see you soon and enjoy the campus now, and let's go for a group photograph.